Здравствуйте, коллеги, друзья. Я очень рад участвовать, видеть вас, наверное, виртуально видеть вас. Обнимаю своим взглядом все эти 1500 или сколько, 1600 человек на нашей ежегодной конференции PGConf, но в этом в онлайн-режиме. Я хочу начать конференцию с некоторых воспоминаний. Вот на этой фотографии вы видите всех участников нашего совещания в Торонто. Это первая международная конференция, которая была организована Postgres сообществом в июле 2006 года, через 10 лет после старта проекта официального. То есть вся конференция была посвящена десятилетию. Видите, сколько нас здесь? 50-60 человек. Но еще можно, конечно, увидеть, что здесь мы на 15 лет моложе. Вот здесь, видите, это Федор Сигаев. Здесь вот я спрятался. Вот Том Лейн. Какие мы все тут молодые. Мы 10 лет работали и не видели друг друга. То есть общались только с мейлинг-листом. И, конечно, в первый раз, когда мы встретились друг с другом, нам было очень приятно встретиться. Я познакомился лично с Томом Лейном. Вот здесь Федор Сигаев со знаменитым указателем Postgres. Посмотрите, вверх-вниз. Мы, конечно, очень волновались с Федором, потому что нам дали целых 2 часовых доклада. И опыта выступления на международных конференциях, вот таких Postgres у нас не было. Но мы справились с этой ситуацией, потому что на самом деле доклады, конечно, были действительно серьезные, и вы можете посмотреть на 2 слайда из 2 наших докладов. Первый доклад, он посвящался джину. Тот самый джин, которым пользуются сейчас миллионы пользователей Postgres. В тот год мы его изобрели, реализовали и были настолько поражены мощью того, чего мы сделали, что мы назвали его русским словом джин. Ну, мы-то все знаем, что джин – это волшебник из лампы, который действительно всемогущ, может много что делать. Но западные пользователи, они джин воспринимают как напиток или как по-научному обобщенный обратный индекс. Но вот вы знаете, что джин – это наш самый джин из лампочки. А второй доклад был посвящен полнотекстовому поиску. Это тот самый полнотекстовый поиск, который в Postgres встроен, и много людей им пользуются. Так что эти 2 серьезных доклада, конечно, они дали нам уверенность в том, что мы выступаем на такой конференции не просто так, а вот представляем такие серьезные работы. Ну а сейчас мы уже все встречаемся на онлайн-конференции. И вот Иван тут мне сказал, что пользователей зарегистрированных порядка 1600. Но я уверен, что их будет еще больше, потом смотреть эти все выступления. Так что мы видим, как Postgres вырос за эти 15 лет. То есть с 50-60 до 1600 только на нашей российской конференции. Популярность Postgres растет. Вот можно даже судить по данным сайта DB Engines. Это такая пузомерка для баз данных, которая собирает информацию про популярность всех баз данных. И мы видим здесь вот график, показывающий относительный рост популярности баз данных. И здесь сравнивается Postgres, это синенькая, голубенькая, MySQL, Oracle и MS-SQL. 4 популярных реляционных баз данных. Мы видим, что единственное из всех Postgres растет неумолимо вверх. Мне приятно думать о том, что он начал расти с того самого времени, когда мы с Федором изобрели JSONB в 2014 году. Вот. Но, возможно, он определяется еще, конечно, и другими более объективными причинами. Также мы видим, что за последние 4 года Postgres 3 раза был признан базой данных года. И вот в этом году Postgres опять же у нас. Только в 2019 году мы уступили пальму первенства MySQL. Но я уверен, что и в 2021 году Postgres будет также лучшей базой данных. Если посмотреть по сайту Hacker News, который публикует вакансии айтишников, то опять же, сравнивая эти же самые базы данных, мы видим, что Postgres, опять же, начиная где-то с 2014 года, вакансии растут вверх, в то время как остальные просто падают. Действительно, Postgres база данных, которая набирает и популярность, и показывает непрерывный рост. Всеми любимый сайт Stack Overflow для всех айтишников Вот, тоже проводит свои обзоры, спрашивает разработчиков, и мы видим, что Postgres находится на втором месте после MySQL по как наиболее используемая база данных, и на втором месте после Redis как наиболее любимая база данных. Но вот наши конкуренты Oracle и Microsoft SQL Server находятся где-то сильно ниже. В этом году компания DICE Tech опубликовала обзор зарплаты айтишников американских. Вот. И здесь можно увидеть, вот я сделал просто запрос из базы данных. Спасибо тому, кто мне предоставил его, Смолину Александру, эту базу. Мы видим, что Postgres находится на втором месте по зарплате и показывает рост. На первом месте находится NoSQL, но это понятно, что недавно был еще хайп NoSQL-щиков, но сейчас мы видим по третьей колоночке, что зарплаты показывают тенденцию к зарплаты падают. Oracle находится, ну, можно сказать, в пределах ошибок, но можно сказать, что на 10% меньше. И зарплата, конечно, растет не так сильно, как у Postgres. SQL сервера находится еще ниже, и MySQL тоже ниже. То есть и в зарплатном пространстве Postgres выглядит тоже очень уверенно и внушает оптимизм. В России Postgres, понятно, мы здесь собрались практически все из России, и мы знаем, что вся страна активно переходит на Postgres. То есть большие системы федерального уровня, такие как ФНС, Минфин, Казначейство, Ростелеком, Сбербанк, Роснефть, массово переходят с Oracle, Microsoft SQL сервера на Postgres. Мы обслуживаем системы, у которых сотни тысяч транзакций в секунду. Я хочу сказать, что Россия является самым, я думаю, большим пользователем Postgres, потому что по известным причинам у нас все эти системы именно федерального уровня. Мы ожидаем
that actually make them so system. So I think that in the near future the whole world will switch to supply because this is very thing, quite reliable and depends and
но не только государственные системы, но и крупнейшие компании, как Яндекс, Mail, Авито, они обязаны Postgres, они поддерживают Postgres, они используют Postgres. Если посмотрим на российское сообщество Postgres, то посмотрите наш канал, как вырос. В прошлом году я рассказывал про этот канал.
More and more interested in Postgres for Telegram, for example. Not long ago, I also delivered a lecture on that. It's a remarkable figure of Postgres users there. And I should say that in total, we had 87,000 messages.
Чтобы посмотреть на разные тенденции. Но вот пока что вот эти цифры, они уже тоже внушают, конечно. Серьезный канал, я очень хочу
definitely this is a serious channel. Our channel is
и очень активных пользователей, которые действительно просто видно практически работают и помогают новичкам развивать Postgres, решают серьезные задачи, интересные
to help those newcomers to use Postgres. Those who decide to start using Postgres. And I would like, yes, to thank
у нас в прошлом году было порядка 3000, сейчас уже 2800
approximately 3,000. Now we have almost 4,000.
Крупнейшие конференции в мире по Postgres происходят в России.
Level at big conference,
у нас целая серия региональных конференций по
PGConf.Russia, PG conferences. We also organize different meetups on a regular
на всех больших международных конференциях.
PGConf.Online is already gathered.
Можно сказать, что Россия является
huge number. We also have, like I said, a lot of regional conferences, and I should say that the Russian community is almost all the international platforms and conferences. I should say also that we have issued very interesting books that using SQL language, Postgres, some introductory information. And here we shared some links, and if you follow, you can find all those publications, plus online courses, so you can actually take those courses,
попытаться пройти сертификацию, которая тоже в нашей компании организована.
For quite a few people have been exposed to this kind of training and certificates. Well, what else? Also have another popular book, which is published in quite a big number of copies. I've just come up with a new edition.
Мы ее напечатали и будем раздавать уже на конференции офлайновской, которая, мы надеемся, пройдет у нас в мае, и все будет хорошо. По данным Хайлоуда, Postgres является наиболее используемой базой данных в России. По источникам свободным, которые мы нашли вакансии, мы можем судить о том, что мы уже в прошлом году перевалили, обогнали вакансии по Oracle, ну и в этом году уже мы данные не уточняли, но, скорее всего, этот рост, конечно, продолжится. Интересно я задался вопросом, а как же пандемия, как же этот наш тяжелый год сказался на Postgres? Если взять Google Trends, то мы видим, что, конечно, к сожалению, запросов
the number of queries, Postgres and PostgreSQL decreased.
То есть примерно осенью вторая волна, она повлияла на
was the second wave and it affected
Интересный эффект, что в России люди ищут слово PostgreSQL, скажем, а вот, скажем, Канада, Америка ищут слово Postgres. Это такой интересный факт, который показывает, что все мы люди разные, но ищем одно и то же на самом деле. Это просто Google не знает. Как же пандемия сказалась в России?
We are searching for the same things wherever people
посетители сайта PostgreSQL.ru. Наш сайт является наиболее солидным, большим сайтом по Postgres, то есть хорошая выборка презентативная. У нас опубликована русскоязычная документация, которую мы поддерживаем. И мы видим, что фактически особого провала, разве что летнего, у нас не наблюдается. То есть эффект пандемии в России не такой большой. Что нас больше всего порадовало, это то, что количество постоянных посетителей сайта достаточно большое. То есть, оказывается,
the number of
50 тысяч
visitors
человек.
is quite large, around 50,000
Postgres в России это не просто Postgres, это уже, значит, большая сила.
So Postgres in Russia is not just Postgres, it's
Я
a big
хочу с
power.
радостью и гордостью представить наших золотых
I'm
спонсоров.
happy and
Компания
proud to
Intel,
present our
наверное,
golden
представлять не стоит.
sponsors.
Все прекрасно
I don't
знают,
think Intel
чем
requires
занимается
introduction.
компания.
Everyone
Нам она интересна
knows
тем, что она
what
в
they
частности
do. We
разрабатывает
are interested
NVDIMы.
in it
Это
due to
новое
the fact
поколение
that
памяти, которое
develops the new memory generation,
прогрессистам. Например,
and we are really
тестировали
interested in that. We have
для того, чтобы хранить
tested
валы.
the
Все
chips
знают, что такое вал.
to
И хранение валов этих в памяти является одним из очень интересных, эффективных направлений. И в зависимости от нагрузки
write-ahead logging in there is really good in
десятки
terms of
процентов действительно мы экономим. Или не экономим,
we are
наоборот,
saving
производительность вырастает на десятки
dozens
процентов.
of percentage. Well, I mean
Вторая
the
компания
performance
это Nutanix,
is
это
improving.
молодой
The second
мировой
company
лидер
is
в
Nutanix is a
сегменте частных гибридных облаков
global leader
и является
in
пионером
private
гиперконвергентных решений. И мне приятно сказать, что
leader in
мы являемся
hyperconverging
технологическим партнером компании
solutions, and
Nutanix.
we are
Уже
happy to
несколько
say that
месяцев работаем
we
с
have been working with them for
компанией,
several months already as
помогаем его
partners,
клиентам,
and we are
в том,
helping
чтобы Postgres был
their clients to make sure that their Postgres is fast, is reliable.
базу данных Postgres Pro.
We have tested our database Postgres Pro using Linux platform, and we hope to carry on our collaboration. So herewith, I want to thank everyone for their attention. All we need is Postgres, and I want to wish everyone good luck during these 3 days, and I give floor to Vanya.
Ваня, тебе слово.
Vanya, the floor is yours.
Ваня, тебя не слышно.
Vanya, we cannot hear you.
Да. Ну вот пока Ваня решает свои проблемы со звуком, вот, я займу немного ваше внимание.
While we are having the sound issues, I'll take this time. So how about we take a look at this slide?
Покажу вам.
I'll show you.
Так, все готово. Все хорошо.
Oh, all right. We are set. Hello, dear friends. I also want to welcome everyone, but I'll be brief.
Что я хотел бы сказать, да, сейчас я тоже покажу картинку, но они будут не столь содержательные, как у Олега. Мои картинки попроще. Вот я просто расскажу, что будет на этой конференции, чем она отличается от обычной конференции. Мы, честно говоря, очень хотели провести обычную человеческую конференцию, по которой все так соскучились.
To have a regular conference, everyone's listening, but due to the situation, wouldn't have been able to hold it even for Russian participants, not to mention not being able to get foreigners. So we decided to have an offline conference later. We hope it happens at the end of spring, in the beginning of summer, but we'll see. So it's similar in terms of structure. It has a similar structure to our conference in Russia.
Команды Понтика, это наш технический партнер, это организаторы широко известной конференции High-Load.
These are the organizers of the High-Load conference.
онлайн-общения, на котором мы сейчас находимся. Ее всем нам предстоит освоить, посмотреть, какие там есть возможности. А именно возможности такие. Ну, во-первых, слушать доклады, это вы уже, по-видимому, делаете.
Listening to the presentations, more clearly you are doing it. You can ask the questions in chat, and in every room we have a moderator who will be passing questions on to presenters.
Это тоже партнерская система такая, очень интересная, в которой можно двигаться, и слышать тех, кто рядом с вами. Вот, не забывайте голосовать за доклады.
Don't forget to vote for the presentation.
Вы сможете голосовать за доклады.
You'll be able
И
to
обратите внимание, на этой конференции, как на обычных конференциях, у нас есть блиц-доклады.
Блиц-доклады — это 5-минутка,
на которые вы можете подать заявки. Их может быть до 10 штук всего. То есть мы прекратим прием после 10-го. Все, кто успеет зарегистрироваться, смогут выступить перед закрытием на сессии блиц-докладов. Новое — это пользовательские митапы. У нас выделено в сетке 2 слота для пользовательских митапов. Вы сможете на платформе подать заявку на митап. И, в принципе, за метапы и доклады можно голосовать, я имею в виду доклады, можно голосовать, и, значит, как вы будете голосовать, оно скажется на том, какие метапы и доклады вы услышите. Вот, что еще? Поскольку заранее неизвестно, сколько будет блиц-докладов, то и время закрытия конференции тоже трудно сказать, поэтому приходите на блиц-доклады, и вы узнаете что-то, что мы хотим сказать именно в конце заключения. Вот. Ну и обращайте внимание, конечно, на правила поведения. Они обычные, ничего необычного нет. Это принято во всем сообществе Postgres и на всех конференциях Postgres правила. Вот ссылочка на них на моем слайде присутствует, они на сайте есть.
It's common rules for Postgres that we have here, so just check.
Я дам слово Юлии Поповкиной, которая расскажет
And now I'll give floor to
более
Yulia
подробно. Она представитель компании Онтика, она расскажет
give us more
более
information
подробно о том, что может делать
So she'll tell us more about what the platform can do. And as of now, just check out the list of our partners, and we really appreciate their support.
Возможно, у нас в ходе конференции появится еще один партнер, потому что бывает и такое. Все, спасибо за внимание. Слово Юле.
In the course of the conference, so it happens with us. And now we give floor to Yulia. Hello, everyone.
Рада вас приветствовать на конференции PGConf.Online
in the PGConf.Online 2021.
Еще раз всем привет, рада вас приветствовать на конференции PGConf.2021 онлайн. Меня зовут Юля, и я вам сделаю небольшое демо по платформе онлайн.
My name is Julie, and I'll give you a short demo on online platform.
Пойду прямо сразу по меню. Первая вкладка идет сейчас, показывает то, что идет сейчас, и то, что будет идти в ближайшее время. Кнопка «Трансляция» перекинет вас в нужный зал, кнопка перекинет вас на страницу, где рассказывается, о чем конкретно этот доклад. Как вы видите, уже сразу на экране у меня есть сбоку напоминалка за 5 минут. Это значит, что
and you can see the content of presentation.
Именно такие уведомления будут показываться, если вы отметите избранным звездочкой.
These are the notifications that you have if you start the presentation you're interested in.
Всего у нас 3 зала.
Rooms. We have 3 rooms.
Вот. Вы видите плеер. Сверху над плеером полоса таймлайн, который рассказывает, что идет сейчас.
You can see timeline strap above the player that has information on what will happen next. On the side, we have a chat where you can ask all of your questions.
Тогда наши ведущие и редакторы увидят вопрос, и ведущий после доклада.
And here you'll be able to see the questions and everything.
Да, вопросы будут зачитываться именно из чатов, находящихся возле залов. У каждого зала свой чат. После доклада, если вопросы если осталось желание пообщаться со спикером, приходите обязательно в special чат. Там 3 комнаты, каждая комната на каждый доклад, на каждый зал, и вы можете голосом общаться со спикером. Там интересно очень прям попробуйте. Кружочек увеличивается, уменьшается, звук увеличивается, уменьшается, в зависимости от того, Обратите внимание обязательно под плеером. Сейчас у нас не доклад, сейчас у нас просто выступление.
Here,
здесь
we have just talk. But here, when we have presentation, there will be a description of the presentation and the time. So you can vote for it for the presentation.
Выберут топ докладов, и вы узнаете, кто победитель. То есть вы можете прям влиять на то, кто выходит в топ. И тоже обращайте внимание, вот здесь вот сбоку, под чатом, будут появляться сообщения.
Getting
Да,
notifications.
вот так вот можно скрывать сообщения, которые напоминают вам либо о том, что ждет вас в ближайшее время, либо о чем-то важном, таком на синем фоне будет уведомление. Это то, что хочет вам сказать организатор конференции.
These will be the notifications with the messages from the organizer. So some partners. This is the partners, information on the partners and conference organizer. And you can talk to some of them like that in a separate chat. Schedule. You can see different rooms here. The time that you see here is Moscow time. You see, this presentation I saved before, and you can see a reminder in about 5 minutes ahead. You can check the schedule here, and you can remove things from here. And when you click on presentation title, you'll be able to see the library. Here are the references to the previous
events. 2 слота под бэкапы и 1 слот под Light and Talks.
Ivan was talking about. Two slots for meetups and one slot for live talks. You fill in you press suggest and you'll be able to vote if you are interested or not interested. 1 or 2 hours.
Прием заявок на метап откроется, и программный комитет определит, какой из метапов взять в программу. И вот как раз тоже покажу.
It'll be, well, the time will,
например, метап.
And the decision will be made.
Вот здесь вот пока что заглушечка, но здесь появится нужный нам метап.
Here you'll see the meetups.
Даже если вы добавите звездочку, то вы получите напоминалку о нужном вам метапе.
If you start it, then you'll be able to
get
notification.
Метапы будут идти в спешл-чате, а именно блиц-доклады будут идти в эфире в зале номер 1. И последняя вкладка чаты. Здесь собраны все чаты конференции. Во-первых, это чаты по залам, первый, второй, третий.
3 room chats.
Чат
One,
организаторов, чат
then
партнеров,
organizers,
партнеров
partners,
и последний это чат конференции, где вы можете общаться, задавать вопросы. Вот, это все, что по меню. В любом случае, если у вас возникают какие-нибудь вопросы, пожалуйста, задавайте их, вы можете перейти как здесь.
If you have any questions, you can ask them. You can write them like that on the right-hand side, or use those contacts at bottom. That's it, and I hope that this conference is useful to you, and I give the floor back to Ivan.
Еще раз здравствуйте.
Thank you.
Здравствуйте, те, кто подключился.
Hello again.
Я буду первое время ведущим этого зала. Вот, и первый доклад у нас это доклад Олега.
Who are here, and the first presentation we have is presentation by Oleg Bartunov.
Олег, я надеюсь, отдохнул после своего вступительного слова и готов продолжить, готов снова к нам присоединиться. Вот, Олег Бартунов в данном случае имеет соавтор Никита Глухов, это один из разработчиков того, о чем сейчас Олег будет рассказывать. Доклад посвящен JSON-B. JSON-B, значит, рассказывает, все помнят, что JSON-B это не просто JSON, это JSON быстрый, с моей точки зрения, B означает именно быстрый, вот, а благодаря тому, что сделали Олег и Никита, той работе, которую они сейчас будут представлять, JSON быстрый стал еще быстрее, а может быть даже гораздо быстрее в некоторых случаях, поэтому слово Олегу.
Добрый день. Я рад приветствовать вас всех на нашей конференции. И сегодня я и Никита Глухов будем рассказывать про внутренности JSON-B. Сначала хочу представиться. Я работаю с Postgres с 1995 года. И за это время сделал довольно много проектов. И мне от этого приятно и радостно, что миллионы пользователей пользуются нашим JSON, нашими индексами, H-Store, пользуются полнотекстовым поиском, методом наименьших, KNN и разными другими. А сам я работаю в Московском университете, я профессиональный астроном. А также я работаю генеральным директором компании Postgres Professional. Вот, я являюсь также ее сооснователем. И в подгрессовом сообществе у меня есть такая медаль. Я мажорный контрибьютор. Никита Глухов, он работает тоже у нас в компании, он старший разработчик, и за несколько лет уже сделал много работ в Postgres и является официальным контрибьютором Postgres. Ну, как вы знаете, JSON-B является очень популярным типом данных в Postgres. На самом деле Postgres являлся первой реляционной базой данных, в которой появился JSON. Вот. И сразу через несколько лет мы сделали бинарный JSON, то есть настоящий тип данных. И вот на этом графике, который показывает относительную популярность баз данных вот за несколько лет, мы видим, что Postgres начал расти примерно тогда, когда появился JSONB. То есть многие NoSQL пользователи, которые стали на радостях пользоваться NoSQL базами данных, они разочаровались и вернулись в Postgres или пришли в Postgres, потому что Postgres, помимо всей своей монолитности, надежности, хорошей истории, хорошим roadmap, он еще получил такой интересный тип JSONB. Целью нашего проекта, который мы затеяли с Никитой несколько лет назад, является сделать JSONB First Class Citizen в Postgres. То есть это тип данных такой же, как все остальные типы данных. Это означает, что нужно иметь, чтобы он обладал эффективным хранилищем, чтобы были быстрые запросы на поиски, обновление данных, был хороший API для работы с JSONB. И вот сегодня мы представим некоторые наши результаты наших исследований, экспериментов, которые мы начали где-то, наверное, полгода назад, но основные результаты были получены где-то с осени, о том, как можно ускорить JSONB, как можно сделать его более таким, более мажорным типом данных. И для начала я хочу показать вам пример, вы, наверное, сами сталкивались с непредсказуемой производительностью JSONB. Посмотрите, создалась табличка, которая была всего 10 тысяч строчек. Первый запрос, он выполнялся за 6 миллисекунд. Простенький запрос, вытаскиваем ID-шку. Потом мы добавляем к этому JSONB маленькую строчку, ключик, повторяем запрос, и мы получаем 66 миллисекунд. То есть в 10 раз производительность упала. Сталкиваются с этим, и мы-то знаем, как разработчики, мы знаем, с чем это связано. То есть это вот такой пример, который нас вдохновлял И вот второй пример. Мы делаем здесь табличку, которая содержит 100 JSON,
Only of
130
JSON
Ну,
of
они
different sizes, from 130 bytes, 13 bytes compared to 130
выглядит как ключ,
27 gigabytes.
обычный ключ,
And
такой длинный
every
ключ K2,
and an AU
K3
just
и длинный
ordinary
K4.
one, K2, K3, K4, so we can see the key out of them, and we try to analyze the number of time that is needed for the operator to get the JSONB per every row, something that we accomplished 1,000 times. So here is the query that we had.
Для того, чтобы потом анализировать, получить такое представление о том, как
general view as to how actually JSONB productivity depends on the length and the position of the key. So, as we can see on this slide, we have here within the 2 kilobytes. So then it goes up to 100 kilobytes for the second part. And here is the third part of the whole app, and here we can see growth. And here the number of the rest. Yes, here we have 100 kilobytes. This is actually the size of JSON that was compressed up to 2 kilobytes. This is the size of inline JSON. Here data is not compressed that fits 2 kilobytes. The 100 kilobytes can also fit within 2 kilobytes, but and here we have entries of that are longer and they are in compressed styles, just like Postgres does. They are kept in separate storage. We can see the number of up to 100 kilobytes. We don't need any additional blocks. And we start this 3, 4, 5, and so on and so forth.
Возьмем теперь посмотрим на эту же картинку, но по оси X уже лежит компрессированный размер JSON.
here we can see compressors of JSON. Well, the first picture we had row, it was done in textual type, and now we can see how it's kept on the disk and compressed type.
Здесь лежат вот
1H, 2 kilobytes. Here we can see line compressed part, and here we can see just a very good visual representation.
Наглядно показывается поведение
how actually productivity behaves depending on the sites and actually how it is.
Вот мы возьмем теперь еще второй пример.
Now let's take another example, also motivational examples. It was can be downloaded from this link, and here we created the typical document. It looks like that we have ID, we have quite a long mass of rows, and different IMDb ID, so ID numbers. And here we can see some other fields as well, but we require specific that one for our analysis. Here we can see how the distribution of JSON looks like, for example, JSON IDs, rows, and IMDb ID, so they are presented everywhere. The rest
мало популярные, то есть
less popular, I should say, yes. Now we are searching for different keys. Here we are asking for different keys. And so that we keep track of time. Here we can see quite a beautiful picture, also segregated in 3 parts. The first part is for those JSONs that are positioned in the space of 2 kilobytes. This is the part of JSONs that after compression also equal to 2 kilobytes, and JSONs further on. What can we see here? What's particularly interesting about this picture? The point that actual productivity only depends on the size of JSON. It doesn't depend on whether this key is kept in the feeder or whatever. A little bit further, we have to take the whole JSON and then resort to compression, to retrieving, to search, etc. And here we can see the sizes. We start with this point, something that is online is kept 2 kilobytes, compressed parts of 10 kilobytes, and it can vary with this range, and toasted. This is marked in blue color. Well, looking at this picture, we can see that decompression, this is a real problem, and decompression is the biggest problem, and toast also thing which is source intensive, and sometimes we can see too many blocks are read with excessive number of blocks, but we only needed to beat the desired blocks. So we need some kind of detox, and we need to decompress the initial stage, something that we really need. But what about the tools? Here we can take a look at the documentation of more detail, but here it's reflected in a simple way. Here we can see column JSON ID is not compressed. We don't do anything about that. Usually ID this have a special type plane, and so the way it was in heap, it is preserved the same way, something that goes to the memory. As for JSON, here we had here 2 kilobytes, so then it's compressed and then segregated into parts. Then are then stored in different tables, those relations, and it was this kind of name, PG-tools, x6 created for each table, and then it was table attributes, and here we can see those triples, yes, those, that's for the table itself. For example, here JSON is substituted by point, and pointer has 18 bytes, and it was chunk ID, toast relate, row size compressed size. This kind of method data. So as for chunks, access is provided through indices. Here we can see indices and 2 fields, and in order to reach one of fields, you need to take it one chunk from the total. We also need to read 3, 4, even 5 additional index blocks, and this is quite an overhead. Speaking about toast strategies and passes, compression, how it's accomplished, it's quite complicated. The whole toast work is all about compression and an effort to fit in as much as possible with 2 kilobytes. And if it's not possible, then we should simply have an additional toast storage, and then substitute all those attributes that were not compressed with the pointer. For example, speaking about extended routing, external attributes are compressed. External they are not compressed if their size is more than 2 kilobytes. They are toasted. Here we can see, for example, extended attributes.
Если он меньше 2 килобайт, вот здесь он
and if it is less than 2 kilobytes, then it is compressed. It's compressed in C1. External, for example, it goes like this, and it is more than 2 kilobytes. It goes to toast, and it has a toast pointer number 1. This one, for example, you have to remember, first you take the biggest one, and you start with the biggest one, and then it goes to the smallest one. So it was the biggest one, this is one smaller, and the next is also small, and then again it's it is more than 2 kilobytes after compression, and then it is taken to toast, and after that we have another point, 2 points instead of it. As a result, so we get it's a kind of line. And the very second stage,
те, которые не тостены атрибуты,
look not just, for example, the previous pass, yes, we analyzed the extended and external attributes only C1, and so as for here, we see that we also have to toast, and instead of that, we get one more 3 points. Third, or toast pass 3, here we have only main attributes, and they are the only ones that are considered. So we get main, external, without compression, extended. There's something that is compressed. Yes, and here we can see main, compression. Then after compression, we can see 3. Then in another attribute main again compressed. We can see here it's C4, and everything is fine. And if toast pass number 4, we again try to compress all that. So this line is more than 2 kilobytes anyway. When we take this main attribute that we performed here is C3, yes, we take it to the compressed one and take it here and then leave it for the toast point. So this is the final line that we get. What about the plan of our improvements? First, we before partial decompression, it means that we compress only those components that we should compress. Then we try to sort the JSON the object key by their length, for example, short at the beginning, longer at the end, and then we try to analyze that we did toast this JSON using those iterators. Then the next stage, we're trying to take a part of toast and inline, and the next one is share its chunks. We need to learn to do them in order to also perform the JSON updates. This is how JSON partial decompression works. Here we can see that, for example, we have full decompression, and as for the access time the keys 3 and 5, it is all doesn't depend on that. So first you need to have JSON, then have some binary search and take all those, for example, number 5, but if we perform decompression step by step, then here we will see that the first decompresses this amount. It's performed quite quickly. V2, V3, V5, they are not, but as for the key number 5, we still have to read the whole part. Here is an example for synthetic example. Yes, we can see that stuff for partial decompression. There is the water. We can see also partial decompression, and we can see that the red key they were taken away. They are a little bit. Close to the longer
такие красненькие точки.
and those red dots, they were taken away from all those curves. And we can see that for JSON, more than 1 megabyte, we can see this acceleration and quite considerable acceleration. It's quite significant results. Pretty much the same results can be seen for IoT. Here we can see that first, for example, ID and the way they are positioned here, that the red key height was significantly improved. And also we can see that still there is room for improvements.
IMDb ID, они коротенькие, они все равно находятся там же, где роли. Вот желтенькие выпали, потому что у нас есть оптимизация, потому что высота, это редкий ключ, и у нас есть оптимизация, когда мы уже из хедера понимаем, что не надо читать тост. Поэтому желтенькие тоже здесь отвалились. Вот здесь. Следующая оптимизация, это когда мы решили перегруппировать JSON-B так, что вот длинненькие находятся в конец ключи, а коротенькие в начале. Поэтому, когда мы берем ключ 5, мы не читаем вот эти длинные ключи. Вот V2, V3, они в конце. То есть мы не до конца, мы не декомпрессируем, разжимаем не полностью, не читаем и сжимаем не полностью. То есть мы получаем оптимизацию для коротких ключей. Посмотрите, на самом деле вот здесь выглядит, как выглядит на самом деле, как выглядит JSON-B, его потроха. Это вот оригинальный, здесь значения сортированы по ключам, а здесь значения сортированы по их длине. И поэтому мы тут, видите, существует специальная карта, которая показывает, где на самом деле находится для данного ключа, находится его значение. Ну, и некая модификация произошла этого JSON-B-H. Очень приятно, что сам формат JSON-B, он позволяет поддерживать обратную совместимость, при изменении, при добавлении нового типа, скажем, этих JSON-entry. Фактически вся работа у нас происходит вот здесь. Мы добавляем и оптимизируем новые поля, новые типы entry и так далее. И сейчас мы покажем результат. Видите, предыдущая была partial decomposition. Мы уже видели, что здесь были красненькие, отвалились. А здесь уже отвалились еще и синенькие. Потому что синенькие на самом деле стали спереди. Вот. Ну вот, соответственно, вверху остались самые длинные. Это K1, K2. Вот. Синенькие ускорились тоже. Они в 10 раз меньше, чем K2. Вот K4. Они тоже отвалились вниз. Вот такая оптимизация. Ну и, соответственно, на IMDb похожий результат мы видим, что остались наверху только зелененькие, длинные роли. Все остальные так или иначе сползли вниз. И тоже мы видим здесь выигрыши порядке. В 5 раз, например, правда, остался вот этот разрыв между inline, вот это inline данные, и toasted. Дальше мы решили делать
So then we decided we should perform the toasting partial one. We decided to initiate it, and then we decided to use only decompression when there is need, for example, chunk toast that is there, and it allowed us to get this kind of optimization. We can see previous optimization. we can see short keys. They are positioned here. They grow a little bit in size, but here it's a little bit different. Here they are no longer dependent on the size of JSON, but still we
partial detosting дал вот такую оптимизацию.
can see this partial detosting, that this kind of optimization.
На MDB мы видим тоже такой же результат. То есть здесь был такой
загиб. Here on MDB we can see this result. We can see how this line goes regardless of the size of JSON-B.
Мы видим, что вот предыдущая
Based on the number of blocks, we can see the previous optimization for other keys.
Здесь мы видим,
They were
что
made like that, and now we see that as for these long keys, they are in the upper part.
А все остальные читаются либо один блок,
to 5. Others are calculated either 1 or 2 blocks as for short keys. 4 blocks.
Индекс блока и один хип.
So 3 index blocks,
Это то, что
you can see here.
это для тех ключей, которые лежат в тосте. Вот чтобы
That's for the keys in toast.
До первого чанка. Для него нужно прочитать 3 индекс блока и взять этот.
Still get there, but for that you need to read 3 indexes. The next optimization is inline toast.
Что хотим сделать? Мы хотим,
So what do we want to do?
часть вот этого первого
We
чанка,
want
которая могла
to have the first part of this chunk that could have can be placed here in the heap in the region table. So we place it here, hoping that if we take those attributes that are placed here, we hope that we won't have to refer or talk to toast. So we have created new type of storage. We call it tapas. Temporarily, it's similar to extended, but we are trying to just trying to get the content of the first chunk. And it got us the results straight away. It just disappeared, and for short keys, and for everything, we got this kind of picture.
Такой же результат и для IMDb, для реальных размеров.
And same,
это для
same for here.
Мы видим, что здесь вот эти все цветные,
so all those colorful short stretches, that were upper there, they dropped down there. So here you have just the long rows.
Есть проблема такая, что нам захотелось, чтобы JSON-B, раз мы говорим, что это первый класс, что это first class citizen, то есть это нормальный тип данных в Postgres, а для нормального типа данных нужно не только быстро читать и хранить, а нужно еще и уметь апдейтить. То есть мы идем в сторону OLTP JSON, но, к сожалению, есть проблема, что вот этот toast, он был изначально сделан для атомарных типов данных. То есть toast совершенно не знал ничего про внутреннюю структуру этих типов, таких как JSON-B, HStore или массивы. Для него это просто какой-то, непрозрачный объект. Он работает...
It's kind of intransparent project locked with binary blob, and it doesn't, with binary blobs, it does not try to find differences between old and new values of updated attributes. So when the toasted attribute is being updated, does not matter at the beginning or at the end how much data is changed. Each chunks are simply copied. What about the consequence? No storage is duplicated. This is the major consequence. We can see 1,000 JSONs. So we can see the size and actually we can see how a table is updated. Every JSON it has the length of 90 kilograms. and then it's stored in 4 toast chunks. Yes, but this 19 kilobyte JSON is compressed to 6 kilobytes first of it, and it allows us to obtain information. If you take to update this ID column, you can see it actually here from JSON ID. We can see that well, how it is presented here. This 1.5 150 bytes per row, or total 1,489 kilobytes. At the same time, heap has grown twice in the size, but the toaster has not changed at all. And we actually updated all that, and here we can see actually it did 2 attributes, but we started to update JSON column, which is quite long, and for which it actually toasted. Then we will get 12 seconds, which is 300 times lower. We can see the size of, well, 130 megabytes, but previously it was 1.5 megabytes.
Вот таким проблемам приводит к тому, что тост в Postgres он не понимает
in Postgres, it doesn't understand the structure of JSON. That's why we have come up with this kind of optimization. So let's try to have partial update, make sure that all the toast piece, to avoid toast piece getting copied. So share toast. We took JSON-B header and we have altered it a bit, keeping the reverse compatibility with the old version, so it'll be reading the old JSON. So what do we see here? Here we see this tuple, in-memory tuple. First, it's getting cut into pieces like that, and then it's processed. And you can see that JSON-B with long fields, it's being replaced by toast. And you get such a structure where we can change some chunks and some chunks we can leave. So that's what you get. Here, we got this kind of bar. We have updated this attribute. So we go here, and these toast pointers, they refer to their own chunks. So attribute B is kept in one chunk, and C, it's kept in 2 chunks. So when we are updating C attribute, we are not touching B, because, well, we just refer to the old value, to the old chunk, and C has updated, and then this pointer refers to the new value. So that's what it looks like. So here is the example of this first of the chunk. It's shared between different versions. So it led to the following thing. So see the case that we had. So this gap that was small here, it basically disappeared.
Доступ к синим ключам, вот, он, то есть среднего размера, он немного стал медленнее.
This blue one, it became a little bit slower.
Хотя часть из них
we do know why they are toasted a little bit slower, but you know, that's what we got. And in IMDb, we have a similar example. All the short keys, IDs, and everything, have been optimized as much as possible. And this whole part disappeared. It's just the toasted bits. So to sum it up, we can see that how from master, when you have access time to key depending on the whole JSON type, we went to this kind of optimization through short keys, and that's the most popular thing. When in JSON we have lots of metadata, but in search you use all the metadata.
Тогда, когда нужно показать какую-нибудь там уже конкретную информацию.
And those big things are needed only when you need to display some specific information. So first we have 1 megabyte JSON. We can see that we have optimized like 3-4 times. So it's times. And for the short JSONs, it's also significant. You can see how far we went. So these are all the optimizations that we have.
Шарит тост. Вот здесь IMDb. Здесь апдейтов еще не было, да. Нет, есть.
So we didn't have that. Oh no, we had the updates.
Производительность селектор.
Yeah, right. We are showing select.
Апдейтов. Здесь вообще просто интересно.
As for the updates, it's really interesting. The update time for keys does not depend on size of JSON at all. So basically, we have it the way the metadata is getting updated. So the update for the fields in tools, they depend only on their size. So they do not depend on general size, but only on their size. And I believe that it's a big win. We have a calculated wall. And mind you, this table contains seriously compressed data, and you can still see that in master you have 10 kilobytes. You have 10 kilobytes of wall. Here, it changed considerably. The short keys, they are not using up a lot of resources like kilobytes. These keys, they're also generating less than it used to be. Well, as for the long keys, they're the same.
При апдейте длинного ключа приходится все его
So when you update the long key, you have to copy all of its chunks.
До того, чтобы пойти вглубь. Дело в том, что шарит тост, вот текущая оптимизация, она сделана только для рутовых объектов.
So the optimization was made only for the root objects. It wasn't made for
нельзя обойтись без... Нам просто стало любопытно, а к чему привели наши все оптимизации, если...
We got curious what we get from our optimizations.
Полностью ненаучное сравнение, потому что, конечно,
of course, it's totally non-scientific comparison because it will require a lot of
взяли вот IMDb базу данных и стали искать
work and research, but we planned to do that. So, you know, we took this ID Kabirius. It was a very nice Italian movie. So we have Postgres completely in memory, so DB is in memory. Last Mongo version and 2 versions, 16 gigabytes of memory and 4 gigabytes. It's in So in Postgres, the buffers in memory, they are compressed, and in Mongo, they are not compressed. So 4 gigabytes for Postgres, it's more than sufficient to fit in the memory. So on the left-hand side, we have master, and it's worse than Mongo. It's like 3 times. 3 times.
читать, раскомпрессовывать и так далее.
And
Да.
here, if you do not instantly remember. So our optimizations led to the following. You can see that
Мы попробовали взять мастер, и в нем
we try to
включили
take
компрессию. Ну, то
master,
есть
and we
база
have
с типом external. Действительно,
turned off the compression.
затрат оверхеда на компрессию нет. Она по-прежнему помещается в памяти, и производительность, ну, стала быстрее.
Everything's
А вот
fine with
к мастеру,
the performance improved, you can see.
Мы
And if you
применили частичную декомпрессию,
and we have applied
потом
partial
отсортировали
decomp
ключи по
to master, then we sorted
размеру ключа.
keys,
Потом
sorted
сделали
by key
partial
size.
detose, то есть
Then we
детосы
did partial detose.
необходимые. Вот. А дальше мы сделали inline toast и сделали
We
потом shared
did
toast.
inline
Мы видим,
toast.
что уже в inline тосте мы уже
And we can see that
который в памяти. Shared toast,
in
он стал
inline
еще быстрее.
toast
Ну, а
we
если
are fine with Mongo.
тесты,
And
конечно, мы делали отключенный
so, of
параллельность,
course,
то есть если мы включили еще параллелизм, да, то, соответственно, параллельный секскан, ну, раз в 5
if we
быстрее.
use the parallel,
5 раз, и мы
and then
стали
it's
сильно быстрее,
5
чем
times
Mongo.
production, and we are considerably faster than Mongo in this.
Из-за того, что она читает, видите, она...
4 GB is the case here. Of course, it's not a scientific benchmark, but that shows us that we need to carry on. So, to give you a short conclusion, we have demonstrated that in compatibility with the previous versions, we have increased the performance of JSON in some cases like 10x or 100x, sometimes even 1000x for selects, and update became much cheaper. So, this is the input from Postgres Professional in the open source. We have uploaded all to GitHub. The slides are available following this link, video, the link video. It's not PG-14 rate because we know it's research. We are getting deeper, we are getting wider, and naturally we'll have to keep on working and work a lot. And this technology, I want to tell you, is applicable to any data types with random access to parts of data. In header, you can navigate throughout all values. Arrays, story, you can come up with movie where you can navigate through frames, or a big PDF document where you can navigate between pages. JSONB is very popular, it's being promoted, and you can see the links to our presentations on version 2 and version 3. It contains a small part of what I just told, and there are a lot of things and ideas for future development. There are a lot of things that are worth researching. So here are more contents, and if you want to join our team, we are very open to that. It's an open source project, and you'll be able to learn a lot too, and become part of the family. So to do, we need to optimize JSON code because there is a small certain overhead. Basically, it's a general interface JSON, and in previous presentations we talked about this in detail. And you can, we worked on JSON, and we know that there is some overhead there, and for us to understand how to move on and how to compare Postgres with Mongo, we need to have more benchmarks, and we need your use cases, and if you share them with us, your cases, your queries, they're really helpful for us. Then we also need to extend shared tools to support arrays and strings, because now it's only root objects. We need to integrate it in Word. and we need to figure out how to make this patch, which is a big patch, less invasive. And today we came up with this idea to call it wired elephant, following wired tiger. It's MongoDB storage. But here we have tree-like structured storage that have big attributes, avoiding tools at the same time. So I think that this kind of storage will be really useful when we talk about JSON. Of course, not only JSON, there are many other ideas. I'm not going to talk about them. And things may change, but something that will not change is that we shared some information and we really look forward to receiving your cases. Maybe the guys from Allzone will help us with their data. And I'm really looking forward to receiving an email from you. And finishing this with the slide deck is this slide. All you need is Postgres. And if you have your questions, I'll be in spatial room chat. You can, my name is Nikita, and come up, ask your questions, and I'll be happy to reply to your questions. And thank you for your attention.
Да.
Right.
Здравствуйте. Доклад Олега закончился.
The presentation by Oleg is
В чате есть
over.
вопрос.
So
Значит,
we have a
может быть, это
question
даже не один.
or maybe
Вот
not.
Рашид спрашивает Олега.
So Rashid is asking,
Олег, здравствуйте.
Oleg.
Я правильно понимаю, что
Hello, Oleg. Do I
оптимизация
understand
tools
correctly that
работает только в Postgres Pro и не реализована в отдельной версии
works
Postgres?
only in Postgres Pro and
Я сказал о том, что
well,
это все...
I said,
Здравствуйте, Рашид, вы меня слышите, да, все?
Hi, Rashid. You can hear me, right? Everyone can hear me? Yeah.
Так.
Right?
Олег, говори.
Yeah, Oleg, go on.
Слышно? Хорошо.
You can hear me. Okay, good.
Повторение, но вот я...
Потом отключи, пожалуйста, трансляцию на платформе. Слушай только ГК.
Stop, well, switch off the broadcasting on the platform. Just listen
Нет, она
to
реализуется именно для ванильной порции Postgres.
Yeah, it's only for our share of Postgres.
Так, и Рашид еще спрашивает,
Rashid
значит,
is
работает
also
ли эта оптимизация для туплов, не содержащих JSONB?
this optimization works for tuples containing JSONB.
Мы сейчас рассматривали JSONB.
We have been looking at JSONB now.
Вот, и еще вопрос есть,
Yeah,
задает
yeah.
Андрей Игоревич
And the question from
Маленчук. Он спрашивает,
Andrei
частичный
Igorevich
апдейт не приведет ли к фрагментации толщинных данных и к увеличению времени доступа из-за этого?
Won't it lead to data
Так,
fragmentation
я
and
хочу извиниться, да, у меня тут
sorry.
параллельно я слушал сам себя. Вот,
Sorry,
на первый вопрос. Во-первых,
myself
это все не
So
для
I'll try
Postgres
to
Pro,
reply to the question
для
again.
комьюнити, это
So
просто
it's not
пока
for
эксперименты.
Postgres Pro,
И
it's not for
наше
community.
желание это сделать
just experiments.
доступным
And
именно в
We
ваниле,
want
но сейчас пока это не
have it
готово для того, чтобы
accessible
куда-то
to
вставлять.
Vanilla, but as
Мы
of now,
поделились
it's not
с вами
ready
нашими
to introduce.
самыми
basically
горячими результатами.
We just wanted to share
Мы все проверяли это только на
recent
JSONB.
hot results.
Но в
So we
голове,
tested
конечно,
it all
держит
in
вообще
JSONB, but of course in our mind,
для других типов данных.
of
Я
total
написал в конце, что у нас
other
в году это разработать такой
I mentioned that
в котором
or
можно
two
было
plans
хранить атрибуты,
create that storage
большие атрибуты, без
for
этого нарезания.
attributes without
Насчет
cutting them in
фрагментации.
chunks. So as for fragmentation,
Любой апдейт, он приводит к какой-то фрагментации. Вот. Но
any
у нас,
update
мы
leads
разрабатывали это дело так, что
fragmentation. What we have created in such a way that access to metadata should not change at all. So it'll be not in Postgres long. As for big attributes,
они как были, так и остаются.
we won't have access to. They'll be the way they are. They'll be pieced together from chunks, so we won't have to do much.
Так, хорошо, Олег, значит, и еще вопрос тебе задают.
There's another question to you.
Планируется ли поддержка JSON-схема из коробки?
Do you plan to support JSON scheme out of box? Well, we haven't yet got there. Well, we had these conversations. We have only 2 heads and 4 hands. So if someone wants to join our team, then we have to talk about it. But we have so many projects in our head, and we just don't have something extra, although it's really interesting.
But if you talk about the scheme itself, so probably you should better use relation, I mean, this kind of relational network, not like JSON.
Хорошо, спасибо.
Okay, got your point. So far, we don't have any more questions in the chat, but I would like, on my behalf, also ask you one question. Do you have any plans to change the internal structure of JSON for faster access to the fields, where we could use this kind, some kind of a tree structure or hashtag page?
Конечно, разговоры об этом велись.
Well, of course, we have been talking about that. When you have a lot of keys, of course, it makes sense to have this kind of hierarchy structure. But this could lead to a situation where we would have to lose some to really have considerable update of JSON-B. But so far, we haven't, came to this point. We don't have cases for that. And one more question: what kind of a perspective do you have in order to support SQL 2016? Perspectives are really high and good because JSON fast already is there as for JSON functions. I mean, we're just waiting for it to come and do that, but it takes a lot of work to do that, and it's not that easy to accomplish and to integrate it into a tree.
30% надежды есть, что...
But we still have small hope that in 2014 release will be completed, and then we'll see that 2016 can be regarded as finalized. 2014, yes, you said. I say yes. So-called 30% who did committed to committed. As for batches, they are kept, there. What about people from the community? What do they actually do in order to make it come true? What can we do apart from committing and writing code? As for what you, this is number 1, and number 2 is testing. So instead of testing real data and real queries, we also should say that there is such a no better stimulus or motivation for the communicators when we use some synthetic data. That's one thing, but when we have a serious player like Ozone, Mail, Yandex, etc., everything is fine. Let's. We're still waiting for that. Okay, I got your point. So maybe some of our will be there to help us. So far it hasn't been committed. And if we have the opportunity that we have right now, could we also use some external means to facilitate this work with big JSONs? Do you have any suggestion? No, I don't see any such opportunities. Probably we could just take out badges and we could try to do that manually. Yes, by the way, we have those batches, gigs up, etc. And Nikita, one of the co-presenter, shared link. And, but if you know what Markdown is, you still will be able to work with that, even though that's nice. Well, you could really give it a try. But what about the book on JSON? So would you like to write a book about that? Would be nice to do that. Why? Because despite the fact that a lot of people take JSON quite negatively, and sometimes yes, they say the car can be destroyed, so to speak, JSON could die. But we see that the popularity of JSON is growing year by year. So I think that we could really write a book on that, just to make some things easier for people around. Well, if we take people somewhere from the society, so to speak, those who can write perfectly well, then it would be nice to really write a book together. I could organize some meetings to discuss all those issues and to reflect in the book. And I think that people could really help with that. Have anything else in the chat? So, if you want to, you can keep on ask questions. So far, Oleg, I would like to ask you the following questions. The point is optimizations based on the KPIs, and we now have the stable access methods. We can create our own users' storages, which is quite complicated since we don't have a lot of them. Is there any points to have a specialist storage for G specifically? Yes, exactly, and I have told that when I talk about Fire Elephant. I said that we should have this kind of storage. Even Toast, it should be presented in the form of a separate storage, because Toast is just a secondary table, which should be quite transparent for the users, and in order to really understand and to work with this second. Also should have to read some blocks of indices, but as for overhead, it is not needed. As for index organized table, I think that it could actually perform these functions for those chunks. I mean, to search for those chunks. That could be quite an interesting piece of work. We would like to create a storage that wouldn't be exhausted through nature. I mean, at all. And have you ever conducted such experiments? Well, as for Nikita, it has already occurred to us, but we are thinking about that. But as for this process, it's sometimes quite irrational, and it takes time. Sooner or later, we come to a certain idea. We have one more idea in the chat. Question: as for homogeneous structure, can we use? I mean, storage. Yes, of course, it is still useful because it's quite simple, but fast that it contribute for it specifically. We have new optimization for indices that can actually speed up considerably. It's not quite a standard, but it's faster than XNB. It used to be a little bit faster than XNB, but still that is not a major difference. But the XNB occupies more space on the disk sometimes, but what about HStore? What about it? Quite compatible, pretty much the same. So JSONB was kind of a modification of HStore. And so, by the way, we also should say that the conference would have author of Cyclone keys for Postgres. So we initiated some piece of work for transfer JSONB to binary, so that in Python we could work in a quite natural way with JSON, so that we don't waste the time for this conversion and textual forms, etc. Yes, exactly. And I think that we could accomplish something of that kind of available in the third edition. By the way, our company sponsors this one, the development of new Python drive. Is it only for Python? And what about other programming languages like Java, or do you have any ideas of that kind? Yes, of course, it can be done for Java. Also, we have also an author of the Python driver, and everything is fine. I think that, well, as far as you know, Daniel, he will take the floor later on, and he will extrapolate a little bit further this subject. So we are about to cover the last question. On the slide, it was saying for sure it's not PG 14. What about 15, or is it not too optimistic as PG 15? We do really hope that it will be feasible if we will not be a little bit deviated from that direction. What about Postgres 15? Okay, I got your point. By day, are you gonna optimize that? What is the best way to make this online stream and not to do it byte by byte by day? Probably we could have separate storage for that matter. So here we don't have any pre-buffer storage. Postgres, despite it's quite an advanced database, but previously we didn't think about that. So now time is right for us to reform a little bit Postgres. We have a certain movement to do that. For example, have a table access method. A lot is being done about compression, and I really hope that we will have the power to do that. So take the decision to the people. If you feel that you are interested in this kind of work, then you are most welcome to do that. We together with Nikita, we do really need developers. The project is really interesting, and you could really, live your it's in the sense of time and just something interesting. Andrika, thank you very much. We are now running out of time, so we're gonna have a 5-minute break, and a little bit later, Oleg will show up on the special chat, and we'll have a chance to talk a little bit about those issues. Next presentation will be developed by Mr. Sher. He will be talking about consensus, Postgres, multi-master, and moderator difference. It will be moderated by Paolo Pomachov. Okay, then go to that room. I will be there. Thank you. Hello everyone, my name is Tomachov Pavel and I work for educational department of Postgres professional, and well, I will act as a moderator up to 3:30 p.m. And I think that it's time to proceed to our next speaker. It's going to be a recorded video, so you're most welcome to address your question in the chat. And it will be delivered by Arseniy Sher, developer in Postgres professional. Let's give the floor and give a round of applause, so to speak, to Arseniy. Arseniy? Yes, so this video is ready for us. He will be talking about consensus Postgres multi-master, and he will be talking mostly about data management system, how we work with different faders. We also be talking about distributed consensus and rafts, and how they could actually help there.
So he'll try to explain some algorithms string by string, and there is a lot of literature on that, so it won't be the key thing there. The key thing about this presentation is about giving an overview for you to be able to orientate yourself well. So here I give floor to Arseniy. Hi everyone, my name is Arseniy. I work with in Postgres Pro, and today, or I mean, when you watch it, I feel like a president who's giving congratulations with everything, with the background of snow and Christmas tree, but snow is missing the president. So I'll be talking about how things are done overall. So this presentation is about fault tolerance and the disaster recovery, which gives us high availability. And although I'll be talking about some sharded databases, we need to understand, we may assume that the database cluster consists of several nodes, because this is easier. You isolate the distributed transactions. And you know, in sharded databases, there are many groups like that, and they replicate some data in there. And a bit of history. Starting from about 2005, we got a boom of horizontally scalable databases. Everyone started creating them, and scalability is the thing, and transactions are not needed, or we work on them later on. So that was kind of the motto. But then it transpired that it's not easy to write the apps, and it wasn't just due to the fact that people thought that it's not necessary. It was about automated recovery with automated consistent recovery is not easy. And if you want to have it scalable, then it's also different. And so it was even more confusing because it was like a theorem that was not understood quite well. So in starting from 2010, the so-called new scale DBMSs appeared that were trying to combine scalability, consistency, and so what is strong consistency? Well, ideally, it's something that's called strict serializability when transactions, well, database is acting like a black box, and the sequence follows the real time. Sequence of transactions follows real time. But I'd say that the strong consistency line is somewhere even before that, and you can you can approach it from different degrees. So like snapshot isolation or read. And from database point of view, these are the consistency levels that majority, when majority of replicas are consistent. So from the user's point of view, it means that the DB detects and prevents the conflicts when you have write. It's called lost update if you do not prevent it. So both transactions started, and for instance, there were 100 watermelons, and one took 40, and then one took 20, the other took 60, and there was a disappearance, there was loss. So this is an important line here. Because this is a outrageous semantics for a user. For instance, losing the transfer is an example of that. It's really vicious. Or when you have a distributed log, and you can use this log twice, or you can violate unique constraints when DB doesn't notice that there are some conflicts in itself. It's bad. But to prevent that, you need to commit on majority, and you get an overhead in terms of efficiency, performance, and in other senses. Here we have a picture from an article when they say what kind of consistency levels you need to communicate with other nodes. So the red ones is something that you need. So it transpires that all new SQL databases provide consistency at least as strong as read and snapshot isolation. And they also try to approach to having linearizability. For instance, this transaction is committed and the next started. The next transaction will see the changes in the previous one. It's not strictly connected to HA, so we won't be talking much about it. So, strong consistency, how do you reach it? The fundamental thing here is the distributed consensus issue and algorithms, how to reach it. And there are two main ways of wording it. The first one is called something like single value, when a node needs consensus on a single value. For instance, whether some particular transaction should be aborted or should be committed. Whoever can suggest different things, but if somebody says that you have a commitment, then the rest should not think that there is an abortion. So it sounds easy, but it's not. And the Paxos algorithm is the most famous one. Basically, it's a protocol family. Its basic form, synod protocol, single value. It was created by Lambert in 1998 or something. And I'll skip the rest because we might not be able to get to multi-master. But single value is not really convenient because you cannot change it. Well, you can create a database, but it's not easy because it's not sufficient. So there is a second very strong formulation, replicated log. Well, the idea typically is to have a replicated state machine where you have a set of nodes and they each has a log of certain commands, and clients come and add commands into this log. So these commands are applied to their state. And the job of the consensus algorithm is to ensure that this logs running in all the nodes. So it's like a route. And you can see the log. X is 3, X should be 3, Y should be 1, and so on. And eventually they all get the same results. And when you have something like that, you get basically a rate database. Everything's working fine, everything's consistent. And single value algorithm, regular taxes, can be generalized to a replicated log, but it's not really easy. And Lambert has described it in his article, not clearly though. It was so unclear that the wrapped algorithm appeared targeting this very problem, and thanks to it being worded very clearly, it became very popular straight away, and that's why we'll have a look at it. So how it works. Wrap consists of two parts, leader selection, because draft is about strong leader. So there is one node that accepts queries, records the logs, and everything. So the first part is leader selection, and appending the log is the second part. So leaders are needed for a reason. There is a unique number associated with each elected leader. It's called term number. And it's a very important thing. Because it allows to track what's happening in the system. So we know who the right leader is for two leaders. So such term number works as logic clock. And all the distributed algorithms that try to agree on something, in there you have something like that. And elections are quite simple. Each node can vote only for one number and only once. And the candidate must collect majority of votes. And if you get the majority, you've got the majority of votes, then this is the unique leader. Sure, because there's only each node only votes only once. In case of any problems, like same number of votes, you can the vote is restarted with a high term, and all the nodes will re-vote. So now about log replication. All log entries are marked with the term number of the leader who wrote it, and it's quite straightforward. Leader receives entries from the client, writes it, and sends to everyone. So you can see 5 nodes. The upper node is the leader. And see the entry number 7 is the majority node. So once you have this entry in the majority node, it becomes committed, so we won't lose it. So that's why the command from this entry can be applied to the state. And first, the elected leader is setting its log above. So if there is a mismatched leader, we'll re-record it. And there is another condition the voice is the node can give its voice to a certain candidate only if this candidate has the log as full as its nodes. So there is a query is written. You send to everyone, confirmations are received, and you commit. And of course, it should be a majority. Sounds not too bad. And there can be so these are the reasons that Raft is very popular, and it's used by such databases as CockroachDB and some other ones. There was interesting story with Aurora. I read recently that their protocol for synchronizing logs looks very much like Raft. Well, not exactly like Raft, but it's very similar. Although they are stating that they are not using consensus altogether. I think it's about words and terminology. And due to logical clock, all these algorithms are similar to each other anyhow. Now, and there is another thing to mention. Having all the data going for consensus is, it's reliable and it's polished, but it's expensive because it requires minimum 3 copies of data, and it requires synchronized replication at the same time. Because 1 or 2 doesn't make any sense, because there should be a majority, so it's minimum 3. So then there is this alternative for that. You can set up a separate small consensus-based metadata storage and use it to change the master, and you can run usual application at the same time. And you need this consensus to replace the master in case it's down. That's what they do for Stolon and Troni. It gives you more flexibility. You can have asynchronous or synchronous replication. There is still consensus. There are many things doing. Database, some middleware consensus. So it looks like things become slower. So now we'll move on to our response to challenges. So we'll talk about HA and multi-master. What is it and how it works? The initial idea was to avoid this need for the application to have to separate read and write queries, and of course having HA. And you get a symmetric cluster in which each node can read and write. Technically, it's an extension to Postgres, and there is logical replication due to natural reasons, because otherwise you need binary identical instances. So it has its own output plugin and parallel applier. The only thing is that you have a parallel thing to distribute things. So multi-master is strictly consistent. So before committing, transactions must reach the majority of nodes, and conflicting transactions are aborted. So that's why you need to put 3 or 5 nodes extra, because it's a complete copies. It's another instance. And that's why invented special 2+1 referee mode with 2 nodes, keeping data, and one is a voting one.
So actually, it cuts down on the availability rate. What about the good side of the matter? I think that you don't have to make a difference or separate read and write queries. It is not needed. It can be for both. It is also built in. Settings are absolutely simple. No additional middleware. Easy setup, like I said. Doesn't lose data, and quite fast failover. It depends, of course, on the setup and settings, but actually in distributed system, you cannot make a difference between slow responding nodes and the so-called dead nodes. That's why sometimes you have heartbeat between nodes, and then you set timeout between them. And if you don't receive ping, then it is classified as dead. So you can set that differently, and a lot depend on different factors and also the quality of the networks. But actually, I would say that this is just a matter of several seconds. And the linear red scalability. Now, what about the bad side of that matter? We don't have inter-node, no cross-node red committed, which is whatever Postgres bears its name, why it is not supported, and what it is all about. In Postgres, this is a snapshot database as for classical snapshot. In isolation, if you have all those transactions, update, then inevitably one of them will definitely goes out of order and something goes wrong. But as for IT guys, they hate mistakes, but they have to repress them, and that is why this the red committed is quite softer here. And when I have a conflict, the one who approaches the line has number 2, then they have to wait for who is going to actually capture that, and also wait for the completion of the transaction. Then we'll have to wait. And if it's abort, then there was no conflict. If there was a commit, then it needs to be verified. So we take updated versions, and then if something is removed, or we don't even have to do it. You cannot do that in multi-master, because if we have updates on one of the nodes, I mean on one node line or another node line, we cannot do anything about that. We cannot just wait for it to be accomplished and so then see what we can do about that. And inevitably, 1 or 2 such transactions, they will be aborted. And multi-master is a bit slower than desirable. There are 2 reasons to that. The first one is that commit is quite expensive. I will show you. We have 2 round trips with 2 syncs during commit operations and route, as it was already discussed today. It can do it within just 1. It's in the multi-master nature, and due to those possible conflicts we might be exposed to, first we need to make sure that the majority actually agree to commit the transactions done during the first round trip. We do it the second round trips. You actually perform the committed. As for backhands, they do nothing during the waiting, and there are no coroutines in Postgres. This performance is quite impacted by this fact. And another reason to that is that logical replication is generally slower than streaming one, and because when you go from WoW to a protocol, and it's quite the opposite from text to protocol into WoW. Yes, it is not that fast. And moreover, we also talk about decoding and uncoding overhead, send after commit. Large rejections are a real pain for that matter. And probably it might be elevated in the 14. For example, we can commit bigger, who can sell big transactions, just as a part of these routine operations. As for my presentations, I'm done with the introductory part, so to speak. Now it's time to proceed to the hardcore part. How it works. Consistency is enforced by two things. The first thing is ICP, atomic commit protocol, a consensus on each transaction outcome. Plain access or synod protocol is used. And so here we use access, like I said, plain access, synod protocol. And the second factor is generations of online nodes, because for the opinion about the possible outcome of the transactions is one thing, but we also need to also make sure that the transactions must lie in the same order on all nodes. And that is another subsystem or generations. And they decide when the transaction can be committed and actually how we can, for example, perform recovery and so on and so forth. Speaking about commit protocol, here we use access, like I said, but we can zoom in a little bit and take a closer look at how it is actually done during the normal operations. As for commit, first we have this generation, we have this stage, this is called prepare, and if we manage to do that, if most generations can be prepared here, then we proceed to Paxos. And for Paxos here, we have only one round trip, but Paxos itself requires 2 round trips. But as for the very first time, since we usually use 0 belts, then it can switch immediately to the second phase of access. Here we can commit transactions, and then everything is performed within the commit phase. Or we could also wait for third round trips, and then we'll be able to see when we have these customers, and we can see all these transactions on other nodes. If there is a problem, for example, and if Harvey said that there is a problem with nodes or node as that, then we have to resolve all these transactions unless or until we find the reason and what situation is with the node. Generations, example of reordering. What kind of problem we might have? For example, here is a very simple topology where we can see that sometimes during 2 transactions we don't have sufficient number of nodes. So for example, node A can see BC, but BC cannot see each other. And here we say that B can write transactions to T1 and C can later write transactions to T2. And we can see that they're different order. Probably later on they will receive each other. But still they are in different order, and here we have a distortion of data as a result. So there should be a more sophisticated protocol where we could commit a transaction. And so this represents generations. Generation is a pair of, technically it is a pair of generation number at different nodes or members making part of the generation. But conceptually, this is a subset of nodes that is allowed to do transactions. And nodes, so they always live in some generations and immediately switches into the one which is higher. And what is learned about the election, for example, it lives in B, but it was 12, it can switch immediately to this generation. It's like terms in Raft, pretty much the same. And during the commit, node stamps its current generation on the transactions, and nodes it can be in the generation one of the 3 conditions. So online, so it enters generation, performs normally, can write a transaction, then recovery when it's a member of the generation, but in order to proceed to the normal mode of functioning, it also have to use transactions from the previous generation and then do it. And then become online, and that when it's not a member at all, in order to become a part of work, it needs to bring a generation with on its own. And here is the basic story. For example, we had initially ABC, 3 nodes ABC. First, we had generation number 1. Everything was online, everything was great, but then nodes just became dead. And here we can see one node was back for ABC, and then it asked for the system to be included. So it voted for this generation for ABC, and it was chosen first. It's just to the recovery mode for the transactions to be reflected properly. And so then it is recovered or recovers, and then it is already online. What about the basic rules of the game? Before getting committed, the transaction must be prepared. Means that it should reach all its generation members. And immediately we see that committed conflicted transactions, they are of the same generation. They lie in the same order on all generation members, because otherwise it couldn't be prepared. So there could be conflict and deadlock, where you cannot go anywhere. So you are deadlocked. And so, for example, members of a generation AB, we can see there are 2 nodes. We prepare it's 1 and 2, but we cannot have an exchange because no one can be committed unless the other one is prepared. And what else? Speaking about generations, I think that we can see all the transactions, they are in a kind of conflicts. And here is another point, nodes which is online in generation and refuses to apply transactions from less than n generations. And generations, they always include a certain number of nodes. Actually leads me to the next, or the main property of generations. The point is that node, which is online in generation n, it contains all transactions of lower generations which have already been committed or ever can get so. There will be no more of them. And all of these transactions which will be committed, they will be for further generations and or higher. Moreover, these transactions are increased monotonically. All transactions of generation M are applied later than transaction of generation M-1. And moreover, order of transactions of a single generation is the same as the order of this generation number. The same. It makes it what it is. As for the order, everything is fine. But I mean, it's very difficult to always understand why something goes wrong. But I'll try to just put forward a number of examples to understand how it works. So there are 2 modes of replication. Normal, when A pulls only B changes from B. And recovery, when A pulls everyone's changes from B, and it doesn't matter where it was written initially, C or D, whatever. And when node in recovery, it pulls all changes in the same mode, recovery mode, from the nodes called donor, and when it is online, it is pulls a normal mode from all nodes. Here is the question. Generation election process determines who is the donor and who must recover, because this is the major question. Who is the donor and who must recover? And it should be decided upon during the selection of generations. How does it happen? As for uniqueness of generation, it's done just like in Raft. Node can vote for a single gen number only once. Majority vote is required for the election. But here we have one more point. Along with the votes for N, the node sends the so-called last online in. This is the highest number of generation they have ever been online in. And at the same, they, when they vote and say last online in, they promise never to get online in generations. And so there will be no transaction because last online in and N, where actually voting is happening. This movement, so to speak, looks like phase 1 in taxes. There we also, when we have ballot in phase 1, those who actually suggest that we should participate in that ballot, that node sends its last vote and promises never to get online and vote in that gap between the last votes and actually the moments where participation was offered. So the point that it freezes last online in till N in terms of logical clocks. And as a result, we know that, for example, we have the majority of votes, and so we can see which of all those nodes have all the transactions and up to N generations. So they will be donors, and so all the others will have to recover from them. It's not always feasible, and that is why I'd like to share some examples with you. So here we can see 3 nodes. All of them belong to the first generation, but online, A, B, C. Then we have, again, this, as I call it, sausage. A can see both B, C cannot see each other. And so then C, we can see the possible scenario. So here we can see how voting is organized. Then we see, okay, this answer is sent, and since both A and C have this one, they immediately get online in 3 as donors and do some exact. But B is dead, at least in generation 3. Then B suggests that we should vote for generation 5, both for A and B. A agrees to that and sent here 3. B has 1. As a result, B has to recover, and it switches into recovery, or switches to the recovery mode. When donor has to write a special message that shows that P must recover until PS5. That is what is applied. We can see specifically in this picture PS5, and it applies after transaction T3 that was written in generation 3. Accordingly, before B switches back to normal, it needs to get this T3 and recover up to PS5. Then it goes online in 5 and can make own exact. And now I would like to share another example, maybe a little bit more complicated, why shows why it is important to give this promise. Not to go online between last online in and N. actually that is being voted for. So to begin with, we can see that everyone can see each other, but then again, C suggests that here we can see 3 for A and C, but it stands last on line 1. And before, no, let's put it differently. Now B, again, wants to vote for 5, generation number 5, and do it for both A and B.
And there was vote for generation 3, but the results were not announced, so we don't know what will happen. That's why when we vote for 5, A sends to B 1, and B thinks that it should not recover. And it'll go online in 5th generation, so later. And if you allow A to become to get online in 3, take the transaction, and B won't get this transaction. So we have already created something in generation 5, and it didn't receive from generation 3. So something like that. Here we have been looking only at safety. We left liveness out of scope. Oh, we have another half an hour talking about that. The unpleasant thing here is that you need to prepare a transaction to get to all the generation members. And it's worse than in Raft, because there, the leader, if one of the nodes is down, the leader won't notice it and it will carry on. But here, node 3 is out. You get a small gap in node 1, and transaction will be aborted. Maybe it can be improved somehow, but we didn't figure out how to do it. So it's now easy. And we have described the algorithm for TLA plus and shipped properties. So what it is, I just want to share my positive experience here. So TLA plus is a high-level language that allows to quickly create an algorithm of distributed, but not necessarily, and you can get away from the implementation details. And then you have tools that allow to do something with this specification. And the most popular tool is TLC Auto Checker. This is such a thing that checks all the invariant, checks all the states, and checks whether invariants are stored there. It cannot, there is the number of them, but it checks billions. And of course, it's not a formal proof of things working correctly, but very often I find a problem when we use this tool. Or the process of creating the specification itself is also quite enlightening, because to write the spec, you need to leave the details away. You need to just really, really get deep into the algorithm, and it really helps you with problems, errors, and so on. And it's it's a usual problem when you make mistakes when using distributed algorithms. So this is it from me, and I want to remind you that Multi-Master is open since recently, and you can take it from GitHub and test it. So thank you for your attention. Okay, our presentation is finished. Thank you, Arseny. I want to remind you that you can you can rate the presentation services. You can click stars there, and you ask your questions in chat. So we will carry on and read questions in chat. So if you send 2 queries at the same time, write and then read how many milliseconds will it take to see to get the data from the first query. Okay. Hi everyone. We need to clarify what the question is about. Is multi-master? Well, if we think that this question refers to multi-master, have a special mode when you don't get confirmation to the client until all the nodes are committed. In this case, you don't have to wait. The commit is happening in service. This is late stage. You just use the network. It depends on the disk, of course, and you just do the sync, but it's milliseconds. Okay. We got another 2 questions. Andrei Zubkov is asking, in the sausage topology, how often B and C nodes suggest node A voting to the generation? That's a good question, because if they do it all the time, nothing will be working. And this is something that refers to flatness. Because when the majority is okay, everything's working. Yeah, this is a challenge. But in multi-master, it's tackled the following way. Well, the short answer is they stop doing that when everything stabilizes, when changes stop happening. How it is implemented. Well, the hard bits that are going between nodes, they're not just going between nodes. The nodes also share the information who sees who, and they create who, and there's a subgraph between nodes and one selected. So if everyone's there is no B and there is not A that sees everyone, then it means that both A and B will be chosen. Oh, we have same issue with graph. There was a guy, I forgot his name. He wrote a huge post that there's a need to deliberately stabilize this, blinking when everyone's trying to be in the lead. Okay, another question. Is it possible to multi-master into nodes? Yeah, it has been done. It's called periphery mode. You need node 3 anyhow, but it doesn't contain any data. It interferes with availability, of course, because when you get the situation when you have one node is okay, one refer is okay, but one was working okay, or the other one dropped. The number 1 was working, and then it went down, and then the node number 2 is up, and you lose transactions. So, okay, more questions coming. Do you plan to publish the algorithm in a scientific paper and some verification PLA plus? All that has been published. There is published in the multi repository, and on the slide you have a direct link to there. And there is a not only pure TLA plus, and there is pure English description. And also, yeah, pure C too. So pure C, TLA plus, and English. As for scientific article, well, it can be done, but it's very likely that I won't do that. Oh, yeah, it's possible. It could have been, it could have done this, yeah. Well, consider that. Another question from Maxim. Have you verified the algorithm with the help of fuzzing testing, Jamson? Well, it's not really fuzzing testing. By fuzzing, I understand that it's when Jepson, it's writing. It's a good idea. We have our own framework for tests that was written by Postgres, and it's very similar to Jepson. It's Python and container. That's what we use. And it was a long time ago, and back then we decided not to use Jepson because Jepson's working on we have containers, so we have real overheads. But basically, it does the same. It gives you load, it pulls nodes, it interrupts the connection between nodes, checking that data is still alive. Yeah, so it can be improved. And the test, what we have now is quite nice. Good enough. Will multi-master become free at some point, even in a like short version? And if so, do you have any timeline? Did you hear me? I didn't catch the end. Can you get an estimation when? Well, several months ago, they decided that that it should be open source, so it's available in GitHub. There's a slide. There is a link on the slide, and I can copy it to chat. It's in GitHub. The only thing is that now it's not really convenient. Well, we are collecting the packages. But here you need to, put together Postgres and patches and extensions. So you have to do it yourself. Okay. There's someone's conversation. Be quieter, please. Yeah, okay. Next question. We have same question to the sausage topology. How do you protect yourself from clusters falling apart if node A is down? Well, if node A is down and B and C, nodes B and C cannot see each other, then that's it. But if they see each other, we'll see that the connected graph is BC graph, so they will vote for it. Okay, and questions coming up. When node is restored, from where the missed transactions are taken physically? Are they taken from wall? Yeah, there are some logical slots, and there is always of course, there is a threat that wall will be overwhelmed if one node is not. It's quite a complex mechanism of sync points that you need to ensure that is necessary to ensure that wall is not too big, not too small. Question from Alek Vyacheslav. Please tell us, where can we read more on multi-master, how we install, how we use it? Multi-master. There is a response to this question in chat. There is a link to doc. It has to be updated. I didn't have time to do it by today. But basically, yeah, this documentation is right now. I know it's open source in GitHub, and I think I'll try to arrange for the documentation to be accessible. Well, the latest documentation should be accessible. I'll work on that. And we have another question. How fast should be communication between nodes for master to be working? Possible to have multi-master running in the network when there are some delays, or where you have 1 megabit per second. How you make sure that the cluster is put together? Well, there are some settings there. And as for this kind of networks, well, it will be running there. But due to difficulties with committing, routines Postgres becomes very slow, and of course you need to test. And I don't think it's very realistic to use something like that to communicate between data centers. But you need to test physical one, and it uses less traffic, considerably less traffic. And question from Artem. We'll be able to start the read transaction if you connect there. Well, database will tell you that you can't, because you need to check the last state. You can allow it, but there is a risk of getting unfresh reads. It was a question not about transaction, it was a question about. Okay, Maxim, your still is asking. Overall, is multi-master production ready solution? As of now, I went for physical synchronous replication. Well, I'll tell you that we have customers who use it. Well, I can't say that hundreds or dozens, but we have such customers who use it as production. So then testing, yeah, of course you have to test. And one of the last questions, I guess, is Anatolyevich. What kind of limitations does your implementation have in terms of logical replication? Limitations? Well, about DDL. DDL is very simple. DDL sends statements. Like it gets create table, and you'll get create table and this is a simple solution, and in the majority of cases it is working. But of course, you can invent DDL that leads to some weird results, or maybe like create table and it won't be working. Oh, you can invent something. Yeah, there are some limitations. I'm checking the time. Okay, let's take the last question. Dennis, how do you restore when the cluster is when the cluster falls apart? Well, it's not a short answer. Full presentation was. We have more questions in the chat, but we have to wrap it up. Thank you very much for your responses. And as for the questions that I didn't have time to read, please ask them in special chat. You have a link to the special chat, and hope that our city will reply to them in detail. Yeah, I'll go there. So I want to thank everyone. I also want to tell you that if you're interested in all these things, you can come and work with us. And Lambert has good lectures until I class. Yeah, and here I go to special chat. Yeah, okay, you go there. And now we are having a short break, and we will reconvene in 25 minutes at 1 p.m. And now we'll have a break.
In the early days of Intel, Robert Noyce once said, "Don't be encumbered by history. Go off and do something wonderful." And wonderful, we did. For more than 50 years, we transformed computing, putting Intel Silicon at the heart of innovation. But with all the breakthroughs we made, all the possibilities we created, what's truly wonderful is we did it together.
Let's go higher, higher than we've ever gone before.
And today, as we head into the future, fueled by cloud, AI, 5G, and the incredible potential of data, we are united by what we must do. We're making Intel hardware and software a catalyst for a better tomorrow. To protect our planet, make technology accessible to all, and enrich the lives of every person on Earth. Because the truth is, if you have an idea and Intel inside, you have everything you need to go off and do something wonderful.
И мы продолжаем.
And we are about to continue our conference.
Следующий доклад тоже будет
The
в
next
записи
speaker
представлен, поэтому в
will
чате сразу
also
можете
be
вопросы
presented
задавать.
here in time of a
После
pre-recorded
окончания
video.
записи
You can ask
докладчик
your
выйдет в прямой эфир, и там я ему уже
question after the presentation, pre-recorded presentation. You'll be able to address your question to the speaker. I would like to give the floor to Vasily Puchkov, head of database management system, Gazprom Digital Solutions. He'll be talking about development of integration base for production data for oil depots or plants based on PostgreSQL. And there he'll be talking about pros and cons of these solutions and some business requirements. Where is the compromise, and if there is any? This is something he's going to cover during his presentation. Please, over to you.
Тема презентации – проектирование и
The
разработка
subject of the
интеграционной
presentation is
базы
design
данных
and development
нефтебазы.
of integration
Мы
base for
сконцентрируемся на
oil
теоретических
depots,
основах,
storage
принципах.
depots. We will be based on theoretical parts, on different approaches rather than practical implementation. A few words about myself. My name is Vasily Puchkov, and I'm head of database management system departments. One as platform, Gazprom Neft. I worked with the digital solutions, and I've been responsible for TBA. MS system started from 1995. I also was directly involved in design and development of such management system. I'd like to highlight once again that the process was launched back in 1995, and I became an integral part of the whole process, specifically development of integration database for production data for oil depots. I have some ideas regarding database management system. We are now living in a new generation, and generations substitute each other, and we have to adapt a little bit. I have some probably biased or subjective opinion on that matter, and probably that could trigger some questions, but still I'd like to share that with you. So since our design works is a live it's a process. It means that it also has to comply with this kind of principle. So contradiction in terms where we have unity and quite the opposite things. Here we have this sign where we show that on one hand opposite things are united together in its fight, but at the same time, every thesis has its own antithesis, but together they synthesize, and as a result, they represent one whole thing. And it actually, as a result, well, rotates a little bit, works as a whole. And we have this contradiction in terms, but it actually gives birth to a certain one single form, and we need to understand what kind of approaches we used in order to find a way out of all those contradictions. What about those contradictions? What I'm talking about? And let me explain. I decided to take certain things that on one hand rule out each other, hamper development of each other, but at the same time, I would like to explain how we still managed to reach a certain consensus, and why the development of an integration database is a very good example to explain that. A few words about the subject of our project, or oil depot. What is that? This is special premises where we actually accept, store, and actually then send or deliver different amounts of oil to different destination from. Yes, we have different tanks, different measurement nodes, or counter meters where we actually control the acceptance, oil acceptance. So usually we used different, for example, oil pipeline, or used tanks to do that. And then we also used fuel tanks or oil tanks in order to deliver the product to gas stations. We might have some additional equipment if we need to have it delivered, for example, construction sites or some other locations. But anyway, the principle is pretty much the same, and within all those nodes, we have special measurements nodes or counters that are used to measure different components per meter, for example, density, mass, penetration level, moisture content, difference, also other parameters. It also gives us an idea about some emergency situation if there are any, and of course, all this information is then integrated into the system. What about data flow? How it's organized? We have different oil depots. That one that you've seen on the previous slides, that is quite an ideal scenario. But oil depots, they sometimes might be quite old, and they might have minimum equipment, hardware, no complicated system. It might have only these steelworks or metal structures, different primitive sensors that are used for sending different signals and for also processing of different data. We have two major data flows. First one goes from the automated system, and the other goes from MES, the one that is used for managing technological process. Then we have corporate structure, and all the signals are sent there. I would like to say that oil depots, they are usually located in quite isolated areas, quite at a distance from other locations or premises. We have special tires. We have also corporate system for data processing. Some information is set to the corporate hub, to the centralized system, and if we have a special commercial accounting system there that is used there, for example, that's the system of control, analysis, etc. There could be a lot of them, but again, we can also connect some other systems to that. So on top of that, for example, for repair works, for investigation matter, for, I don't know, maintenance purposes, and so on and so forth. But what about database management system? Or why it actually can be found on the edge or on this, this complicated point with different paradigms. Like I said, we have automated management system. We have MES or MES, manufacturing executing system, the system for manufacturing processes. Then we also have commercial reporting systems like 1S, etc. So what do we usually have that? As for automated system, usually they work with different sensors, pieces of equipment, devices, and of course it is adjusted to our technological specialists, manufacturing gurus. Usually these are just the plain tables that contains information about the different devices, their states, and send information about the state of these devices to the system. I mean, the state of pumps, valves, etc. What about MES system? It is of higher level, and it includes different variabilities. For example, we have, I don't know, special tank track. It goes to the oil depots, that it goes to the fueling stations, then it moves further and it drives all along the oil depots, and then all this information is registered. So, for example, we have an tank that is delivered by railway, so there we keep track of all the maneuvers, then how it is sent to different utility channels, to different corridors. Again, here we have a particular technological process in place. But what about other documents? For example, commercial reports. And here we work with bill of lading, consignment notes, different reports, and of course, here it is more adapted with a particular regard to accountants and all those accounting purposes. So these structures, these paradigms, they are quite strong. And I wouldn't say that they contradict each other, but I would say that they are not quite, so to speak, compatible or fit into each other. On one hand, we have some plain flow of different measurements or tables, very simple one, and we have clear processes in place with certain reference points at the beginning of the completion of the procedure. On the other hand, we have more complicated processes that are supposed to be filled in somehow. They are attributed certain status. They have information about dispatch, about other also accompanying processes with all the corresponding documentation, like I previously said. And amongst all that, we have our database management system. Why actually we need that? So that's a good question, because theoretically, of course, we could just make arrows here, have a quite simple structure in place, and organize all those flows of messages that will be moving from one place to another. But here, apart from the so-called security issues, there are some other issues involved, because I want to say that it could actually lead to certain chaos, chaotic situation where we could risk of having different messages formats, and of course it could ruin the whole thing. We could have absolutely different approaches at different levels, different sets of messages, or also could repeat the same information over and over again when it's actually not needed. And of course, inevitably, it leads to certain complexities. And we talk about hundreds of oil depots, or at least tens of depots, forward their information on a regular basis. Just think about the amount of information that should be forwarded. I mean, probably very, very regular. So it turns out that our oil depots is like the center of order, something that should have an absolutely transparent management system in place, where we could actually strike the right balance to understand how it should be work out. So what can we say? In order to understand how it should be worked out together, yes, for quite a long time, we worked on different design issues related to management system. We used different materials related to the development of databases and their management. I should say that even those books that were written 30, 40 years ago, they still allow us to tackle this issue correctly from the very beginning. So, because they contain some relevant information, and I would like to draw your attention to the fact, say that, for example, this kind of table, let's just use it in our work. We have very interesting data sets, and that is just take this database management system and related information, take this table, then we apply another table for commercial system, and then we will try how to bring them all together. A very important point from this perspective is kind of a unification. We use one single approach, but also you can use approach that was also developed some time ago. This is the foundation that you will be using in your work. This is something that could allow you to do that correctly. These tables should be tailored in the most efficient way. They should be designed properly. And if you really want to do that, you can actually do that. You can use all those systems and apply it together with our systems, and then to have a certain representation that allow us to take a look and to keep track of all the internal data that could reflect the current state of the whole thing. Why is it good? Something that I'm saying right now, it is based both on my personal experience when I designed other systems and some previous efforts to come up with a similar technological solutions when the above-mentioned mistakes were committed, and as a result, we could not actually bring all those data pieces together. Very good example where we could use different reference books for unification is, for example, classifications that have already been developed for example, oil products or petrol products. We have different codes attributed to various products. Sometimes when we use different systems, we might lose certain codes, and it can lead to really chaotic situations. Again, equipment is another very important point. So different nodes that are used for maintenance or repair works. And of course, it would be desirable if we could use those nodes and understand that we should have a very clear reflection of all those nodes to have all the necessary equipment well reflected in the documentation. And this is something that is used for further reflection in different other documents. Or, for example, tracks. Those who have used with trucks, we know that sometimes we might use, for example, plain space, use different letters, partial letters, writing letters, especially. It's actually allowed us to do that. We might use Cyrillic letters, and this leads to quite very interesting piece of entertainment when we have to work with different classifications. And drivers, it is also applied to them. We have different ways to address drivers, but we have to have a reference books, quite a unified one, so that we can keep track of all the drivers when they enter the site, when they leave the site, when they go to World Depot, what is delivered by these or that driver to a certain location. We have to remember about that. So you really need to bear that in mind. This is something that you should start your design works with and development of integration databases. Unification, this is a very important point. Now, another question about design. We understand that we might use different methods. We might use right and the so-called fast approaches. And even though that we might have some quite old approaches, still there are some classic ways to do that. We know how to write good codes, and if we really come up with good codes, then we can really make a system really good and perfect. If we start to do something really fast, it seems like everything works, and when it almost works, then it might become still not manageable, because we might have a certain mix of different processes. Sometimes it is easier to start from scratch, and it's not very clear to how we can get a good code. Again, based on my personal experience and experience of all those implementation processes, there is a set of rules that you should always bear in mind, especially in the context of design works or development of integration databases. First, when we work with database and it has its own foundation, there shouldn't be any, like I said, contradiction terms, or, for example, different interpretations of the same things. Surprisingly enough, one of the important criteria is the aesthetic part of the matter, which might be a little bit counterintuition, but still those working with mathematical methods would confirm that there should be a proof to everything. The same is applied to engineering solutions. And sometimes we can also...
Same here. It's not necessarily that the nice solution will be the right one, but usually the right solution will be a nice solution. Next, we have some basic things like modules, and we've been talking about this for like 50 years. Have your basic operations functions separately. Don't repeat them many times. Don't repeat the code many times. In the beginning, it'll take some time to understand what's needed. So it's like a process with iterations, but it's worth investing effort in this because it pays back really well. And at some early stage, it would be nice to take some basic things that you did and you make a test run, just take some case and try. And many people like Agile, and Agile really works here well. We can do those sprints, you can test and get back and redo something. Because if you start from it, like we start from basic, you start with some bicycle, then it's bikes, then you make a car out of it. And then you'll be seeing such like a truck with a bicycle steering wheel. So you'll have to live with the solutions that are there from the very beginning. And the earlier on you get the errors, the more you'll be spending effort and time to fix it. As for aesthetic, this is basically a foundation, the basic diagram. It's like a basic founding diagram in which you can see the whole implementation. So we have oil depots list. You have reporting notes, some reference documents too. Well, of course, there are not all the type references, but the resulting diagram is also quite streamlined, because you can often see issues with design if you design from even the units, measuring units. You have to have that from the very beginning. So you have tasks, you have some, for instance, the task is to repump from some reservoir to some truck. So from a certain node, the transactions is starting like from A to B, and then it ends, and then and you see like the sequence how it should be, and this is the foundation of the search database. But I want to repeat myself. There are a lot of things on top of it, like there are bulk wagons, there are some other attributes and so on, but it starts from the very beginning, from the very basis. So type some measurements. We have a lot of measurements, and you have the process control system as a database, and you have different densities, masses, everything, and all it looks like a single table, one sheet. And if you want to introduce another measurement, then you need to do something about it. So we have created a universal measurement table, and we see what is being measured in which node at which point of time. So we have time, space, So we have the way of like seeing the state of oil depot. Then it specifies what we measure: mass, temperature, density, level, like, and of course it comes together with units. And I'll talk about this later. So how much and what's the error ratio? And for some systems, it's important. Some other ideas, some regarding some contradictions. Well, let's talk about rules. The rule is that it's a bad thing to use triggers for business logic, and it is true, because sometimes it's tricky to see what kind of triggers we have and what. And well, if we have several triggers in one in one table, it's hard to predict in which order will they like start. So it's a bad idea. But if we have instead of insert triggers that initiate some function and logic, starting from such elementary things like recalculating units from one unit to another, writing some values, like recording or writing this transaction about oil product being moved from A to B. This is a good solution. Why instead of insert is a good thing? It's good because some systems of ours can't work with functions. And we give them this option, and everything works fine. Everything is like sequenced in order. And the next contradiction that's also subject for holy wars, and but it can be resolved actually. In IT, there is this perception that evolution in technologies that we get rid of all the old things and we pick up some popular things, new things, forgetting about the old ones. But actually, evolution in nature and in human knowledge works as follows. If there was something good, it stays there. Hundreds of millions and billions years ago, cells cells are breathing with the help of oxygen, and we have mitochondria, and thanks to them, we and together with them. So since we are multi-cell organisms, we use that. So it was a good thing in evolution billions of years ago and still with us. Here you see a sewing needle from the Stone Age. And anthropologists say that it was the ability to sew made person, a human, like made you get Homo sapiens. You become Homo sapiens instead of Neanderthal. They were sewing clothes for themselves. They started doing that. So at some certain stage of database development, CSV format was invented. And people like to say that this is Stone Age and, advanced people do not use that. But basically, it's a very powerful and very convenient tool to tackle certain tasks. And I'll give you the example. There is some, for instance, there is some oil depot in a remote location, and the connection is not that stable, and there is some system with MSQL. And when things are working well, we have some presentation and some loader takes it from SQL, and in Postgres you get, instead of insert, triggered, and all of it is distributed into tables according to the design of your database, and everything's working. And then you get this need to upload historical data, like millions of lines, some, I don't know, indications for the last few years. And it's, you open the connection once, you don't open DBC for every line. It would be very slow. You can do a very simple thing. You take this presentation, you upload it into CSV. CSV is compressed and through file system and sent to database server into the same table, and there is insert and trigger launches, and it's like dozens of times faster. And there's a difference between hours and days, which is an okay solution. And there are some systems where you have things stored in different structures and platforms. So for such cases, it's very good. For instance, SAP really likes to give everything and receive everything in the form of CSV, and it's not always possible to implement something else. Sometimes it's possible, but once again, I'll repeat myself that when you talk about big volumes of data, then this is a better way. New technologies. You shouldn't be afraid of new technologies. We use JSON-B very actively, but it depends on the task. For instance, there is such a thing as quality certificate. And you often see them in the gas stations. You have those certificates like sulfur content, density at 0 degrees. So there are a lot of attributes like with like A4 sized paper list of characteristics. And it is issued by a laboratory, and it is sent to the gas pumping station. So it's just a document. You don't do much with it. And it's very convenient to store this document in JSON as a set of values. Why? Because it's not something measured by oil depot, and oil depot doesn't do anything with the document. Of course, there are some, end-to-end documents that you have to like receive, print out, and everything, like commercial reporting system sends attributes, sends the where bills, and it has to be printed out, and it's also, JSON also works well for that. Moreover, it's very comfortable to use JSON-B for such data, even structured tree-like data for certain documents. For instance, if you need to send a document as a whole, for instance, the document is stored in several tables, and we use an aggregate function, making one JSON out of it, and we send it. And it's really topical when we have some situation like when the system has to read the document as a whole, not in several iterations. So then they do select, they receive one JSON, and they work with it. Next thing. When you have to compromise, when it's not good it's not the right thing really to compromise. Well, again, it's a subjective point of view, but it's based on experience. Some examples. So there are principles that we have: internal data integrity, we have normalization, and our data has to be consistent, irrespective of the system use. And there is this rule, GIGO, garbage in, garbage out. And this principle never fails. If you have garbage, you won't get anything useful out of garbage. And what kind of compromises may we have? There are some entities we use, and those entities do not always fit 100% the real world. Another thing is that sometimes we need to denormalize, especially when you need to move some field into a different table. And for instance, there is some data regarding multiple, and you don't have to pull this field on oil depot through 4 tables. But such decisions are made only after normalization has been done, and only if you have denormalization really justified. And, again, it depends on the interaction between the systems. For instance, measurements. Measurements come together with units. We need to understand whether we have liters, cubic meters, kilograms, tons, or like density. Kilogram by meter, gram per square centimeter, cubic centimeter. And we had some bad cases when we had some automated process control system, and we have a device using different measuring units, and we get trouble. Then the next principle is about time. We need to have time with time zone specified. And driver needs to have a unique identifier. We need to differentiate between the drivers having the same first and last names. And there is another specific thing. We have to transfer data in the units that the measuring device or the sensor gives you. For instance, there is some measurement error, and we have to pass it the way it is. So you can round it up. Okay, some reports, they need to have some measurements in cubic meters. So we can do the recalculation, but we know that the original units were different. There are some compromises and limitations. So for instance, there may be some system that gives you data only in UTC, and 1S developers cannot keep the time zone and need to receive local time. So, like 1S are used to that, and okay, we can provide them this information with recalculated local time. As for staffing, thing comes, for instance, passport data of a person has changed. It happens rarely, like 3 times for men on average, maybe more times for women. And we need to to make sure, we can re-record this person in the system as a different person, but we need to make sure that there are no clashes, that there are no two, for instance, drivers in a system that are actually one driver. And what we do, what we send, we have to track how much petrol is sent with the driver's phone. Because, you know, we have oil controlling authority, and they will be very demanding about it.
It should be done, because it should not. That's it. And now, interesting point. This is like a permanent contradiction when security wants to close everything up and the business wants to open everything up, so to speak. Another eternal problem. For example, developers of automated system, they usually just sit within their oil depots. They are usually isolated from the rest of the world and the corporate other elements, etc. And they don't really think that much about protection of information. The point is that Java and web programmers, when there is a certain cloud leakage where they have, for example, information about footprints, and when a leakage happened from the cloud, there was a real problem. We have had such situation, and this is a very painful thing. And of course, business wants everything to be done quickly, and at the same time, we have different other requirements at the same time. And now, with the help of those solutions that we previously had, we can tackle different problems. We can see arrows going in different directions. They go towards the base, and here we don't have continuous access, so no other system can make it to the oil depot. It means that they can read only those things that have in a database what was put there, but automated management system, so they can not just penetrate the system or add something up on top of that. And of course, automated management system cannot enter corporate systems, because everything works via the database management system. And of course, we should require different isolation. We should understand how Connect system should work and have a proper visibility as to how it should be organized. We have different approaches, like I said, and previously they helped us a lot. We have quite a formal structure, and of course it could not be presented by just two ways or approaches, but at the same time we can see all the illegal or not authorized access to the system. We can also limit access to something that we really need, and since our architecture is module based, we also can add something on top of the general business requirements, leave all the things that we want inside without any violations or problem from the outside. So as a result, here we can see basic requirements we have to comply with, that no applied system should have access to the tables. The system on roles should be absolutely transparent. For example, we have oil depot, and since every oil depot has a certain login and roles have been distributed, everything is clear. There they can work with different issues and also with security issues and other things, and database is quite autonomous from that perspective. It can work with its own information, and we shouldn't forget about the opportunities provided by PGConf, where only those things that are needed or necessary are actually allowed, and shouldn't forget about protection of personal data either. We have also understand how we should store personal data, etc. Do you have any questions? Thank you very much, Vasily, for your presentation. I would like to remind you again that you can also rank our presentations or leave your likes. You can also address your question to the speaker in the chat. So Vasily have just joined us, like I said, and is now with us to answer different questions. I hope that we are about to see some more questions, and I have my personal question for now. Vasily, do I understand you correctly that the system you were talking about has already been implemented? So it's in programs. We have a lot of oil depots, and they are being implemented one by one. This is quite a vivid system. Actually, I hope that if we have another meetings, there's also offline meetings, I probably could go through all those steps in more detail, telling you about every single past every single stage, how it was organized into different stages. I just extrapolate on a number of things, for example, how we uploaded data, how we actually worked with a number of processes, but not more than that. That's fantastic. Now, here we have a question. Roman Vladimirovich is asking you, what about, for example, failure of automated system? I mean, this might it have an impact on oil depots if it falls down or goes down? Yes, there could be a problem with data transfer, but we have certain protocols for these kind of situations. But you also have to understand that this is something that is not done in a manual mode, where you just press buttons, because here document flow or exchange is organized just like when we talk about some remote base. Even if communication is cut off, you can still use landline or I don't know, a phone or to make phone calls in order to communicate. So the level of atomicity, so this approach is quite autonomous by its nature, and it can survive in such a situation. Mr. Shostuk is asking you the following question. Could you please say what version of Postgres are you using? Right now we have their 11th Postgres and quite simple solutions. Quite the simple one, yes, I say physical replication, single master, active paster. So far we haven't implemented an opportunity to read data from replica, but this is already a part of the project. And since, like I have already mentioned, that the situation is not like when year ago I said yes, so there we always have to consider business requirements in 1S context, etc. But since our RTO is approximately 10-15 minutes and still we have someone on guard, we have this opportunity of manual switch, because the price of split brain is twice as higher than all those delays during switch over. We have just a very simple proxy there, and there we can make the switch in a very simple way, but you just need to make sure that this is something that should be done. And don't forget about the fact that physical protection is based on 3D visualization. It means that if something goes wrong from the physical point of view, then this virtual machine just jumped from one machine to another seamlessly, and could lead to a degradation of productivity. We basically here talk about total data corruption when we really have to perform a switchover. Yes, we have two nodes. I just wanted to clarify one thing. You said version 11. Yes, and also we had some Veno-based development. Now it's a little bit different, like I said. And Maxim is also asking, were you thinking about extension of VB for preserving historical data in order to reflect different oil parameters? We have been thinking about that, and it's actually does not lead to a real degradation of productivity. We have some current data, we kept track of that. We have data lakes, and they actually accept this kind of information. We don't have any like task to very quickly form a report for the last year or something like that, and only when we use search engine to find certain matches or things like that, yes, we use that. I would say that we probably could use other approaches, selection and many others. We will think about that, where we will accumulate, I mean, a lot of data from different old depots. We'll think it over. And also, so we started to use multi-master or logical replication. No, we don't have any logical replication, and we don't need a multi-master, even only physical replication, and also read function, data read function for reading data. Denis Rashkov, have you tried to implement special solutions as part of automated system for your data processing? And what about requirements there? Do you have any special requirements? Requirements are quite strict because we have certain requirements applied to this process, and as for example, direct or chambers of authentication, it works perfectly fine in Postgres, and so we haven't had any problem with that recipe. It's a little bit more complicated, and right now we are developing a certain solution in order to bring classification to the REST level. And as for backup, we used CUDAP. I have already said how it is organized in quite a standard manner. We make local copies with the help of backup when our corporate system takes this copy and then stores either, I mean, on some separate storage or somewhere else, because we have exact and post-exact scripts. And in terms of the use in general, we use these scripts. Yes, they are quite efficient, and we work with different file systems. And we also have a guarantee that we have a completely consistent backup copy. Thank you very much. There are no more questions in our chat, but I have a question for you. I think the last for today. Since we're about to finish our work in the presentation, you said that then you can also, while developing database, you can use some academic approach there. What about your approach and about your experience? Some ideas that you have, is it actually really different for something that you have in reality? I'm really glad that there we did not use kind of a cascading system where we had certain requirements saying like from this point on we're not going to change the technical brief and we will stick to this plan. As for all those contradictions, yes, we had this waterfall version with Agile. What does it mean? It means that we thought about the concept. Yes, it was an academic approach. We think about the structure, about the correlation between different components, what's the right way to design all that, to develop all that, and we try to upload the data. And then we thought, for example, oh, we need to do something on top of that. Of course, does it fit into that? Yes, and then we just took a pause to revise it a little bit and to think about it from different angles. So I should say that as for this academic approach, there are certain advantages behind that. On one hand, you do something based on some aesthetic or academic ideas. For example, 0, 1, where we shouldn't be like .2 or something. If there is only one link or there are a lot of them. I wouldn't say there should be like machine 1, machine 2. We even for example, our rolling track may consist of a number of wagons, and sometimes we have to change the number of them. It's also the same in our work. We stick to a certain approach, and sometimes we still have to introduce certain changes or amendments in order to make it to the desired results, which is not always easy. Or also sometimes we I might say that it is not a task. This task is not a part of our base, and then because of that, we do not change anything. So it's might be different. Dependent on the situation. It's like we work with JSONs and so on and so forth. Thank you very much, Vasily. I can see one more question, if I'm not mistaken. Yes, but we have to finish our communication right now because we are really running out of time. And now I would like to thank you for your presentation. Yes, thank you very much. And now it's time to take a 5-minute break, and then we will continue. Hello everyone again. We are about to continue. We would like to proceed to our next presentation that is called New and Training Courses by Postgres Professional. It will be delivered by a special person, needs no introduction, Yegor Rogov, my colleague from the educational department of Postgres Professional. We actually said that these training courses are developed specifically to help all those who wants to work with Postgres and work in close cooperation with developers, with different experts. And here he would like to talk a little bit more about what actually changed in our approaches. And we'll be talking also about courses specifically about our administrators, about certification process and many other aspects. Igor, please, over to you. Hello, thank you very much. Pavel, hello to everyone. Hope that you can see me. It's time to start together with my colleagues, Pavel Tomachov and other colleagues. We work together with Postgres Professional on special educational program. Everything that we're doing is available for public, for the audience, and so those who haven't seen that yet, I can share it with you. Here is our website. We can see these educational parts and different folders, as well as different pages where you can find some precious information. I basically focused on training courses, but let's also say a few words about some other things. Oleg in his introductory parts have mentioned some of the books that definitely are worth your attention. Here is a little book that we call Malutka or Baby, if we translate that into English. This information is about basic things related to Postgres. We update it on a regular basis. Unfortunately, today you won't be able to go to our booth or and just take a sample of this book, or a copy of the book, but you can download it later on just to grasp some basic knowledge about these basic things. So what about the training courses? We have a lot of data and a lot of approaches, and they need to be structured a little bit. We have had a certain picture like that before, but still it is well reflected in form of clear structure. We have basic level, have extended level, and specialist courses. And what can be said about this structure? Everything looks like that. Something that is marked in gray color here. This is courses that we have had for quite a long time. That is done in line with Postgres version number 10. As for this color, this is like brand new courses, and they have been updated not long ago, and now these are new parts of our training program. You can see that the whole training courses are divided into two parts. So the first part on this side, so this is more a path for administrators. And the second half is the path for applied developers, talking about specifically applied type of work. So it's applied to different procedures, methods that are used in real applied approaches. And here you can see some coincidence between them or matches. So they overlap in certain areas, and you have to understand how the whole system works in order to understand, to have the big picture. And now I would like to go through the courses that we have. As for the previously existing course, everything is quite clear. That's all the information. I would like to start to talk about new things. We first start with basic SQL, and to think that both developers and administrators are supposed to have some basic knowledge about SQL, but we don't have a separate course for that. Well, on one hand, it is weird because it's quite the basic thing. Well, I think that it could be explained partially by the fact that here we have some standard things, and it is implemented in different databases in pretty much the same way, and we have a lot of resources which are not even related to Postgres, but still there you can get some information about SQL. We have a lot of books, a lot of websites, and many other reference materials. So if you go to Postgres from some other database, then you won't be experiencing any problems using SQL, because it's pretty much the same. All the differences start a little bit later when we talk about more extended options. So we realize that probably there shouldn't be any special separate course for that. As for the book on our site, we can suggest this book by Mr. Morgunov. It's called PostgreSQL, or Basic of SQL language. What is good about that book? The point is that he has quite a good experience in teaching, and at the same time he is a specialist in PostgreSQL. So that's a good combination of two things. We also helped with this book. I mean, just to compile it. That is why I can be fully responsible for that book, and I can tell you for sure that this is a good one. We also have another idea regarding SQL. We would like another additional system, for the example, where you can learn language, SQL language, in an interactive mode, but at the same time we want to create our own platform. This is something that could allow us to reflect our own vision as to how all those tasks related to SQL should look like, and use some adjacent element or some books as part of our courses together.
Basically, in every course, on every subject, we have some practical tasks, but there is a difference. One thing is when you have those tasks on slide, and the other thing is when you have a special system just to practice. So that's what we have, and we have started implementing. Well, that's what we will have, and we started implementing that. Now, courses for administrators. Everything starts with basic course DBA, 1 3-day course within which we talk about PostgreSQL architecture, how things are in there, how you install it, how you work with the settings, how you launch it. We talk about data, organizing data, database, schemes, some basic administrating tasks are covered. Matters of access management is done, and of course some overview subjects like backups and replication. And this kind of beginner administrator can basically start working with the system. So, and after this course, you can check what kind of knowledge is there after this course. And there is a certification program, and you have to complete a test that covers the subjects and everything covered in the course. And if the test is passed, you receive the professional level certificate. And next, we have 3 advanced courses. Firstly, it's DBA2 course. It's called Customizing or Working with Settings and Monitoring. It's 4-day course. There we delve deeper into the architecture compared to the first course. And we take some components of databases like management system, like buffer cache. We look into how these components, what these components are in deep, and how you work with the settings, what you can change, and so on. This is for working with settings, but naturally it comes together with monitoring, because even if you know well how Postgres works, you won't be able to work with the settings from the very beginning, because many things are determined by the system that you have. So we start with some basic initial settings, and then you need to get the feedback from the system, how it works. You have to analyze it, and you need to adjust the system. So that's why it's work in the settings and monitoring. We are talking about what you have in Postgres and what you can use in Postgres to receive the information that the monitoring systems themselves do not show you. Also in this course, there are some important courses that are not covered in the first, and that are not part of the first course, like localization, managing the extensions. Next course is DBA3 course. They are numbered in order. This is a 2-day course dedicated to backup and replication. We take a detailed look at how you work with backup, like logical backup, physical backup, and replication, physical and logical replications. We are covering some examples of how you use it. We take use cases, and we look at what kind of settings you need to, or in this or that case. And at the end of the course, we have an overview within which we try to say why a replication alone is not sufficient to create clusters, and we explain why such clusters are complex, and they are complex due to a reason. It's like the clusters are a complex thing. And next course, it's not DBA4 as you would have expected. It's called QBT. Because we offer this course only to the developers, so it won't make sense to call it DBA something. In the beginning, we wanted to call it opt, coming from optimization, but then we thought that opt may be associated with optional, something that we want to avoid, this kind of association. So that's why we called it QPT, and a query performance tuning. That's what it stands for. It's a 2-day course. There we are working on how query is running, and we take a deep look at planning, data access. We study the settings to do with performance, and at the end of the course, we are checking how you track the problematic queries and what you do to optimize. And after those 3 courses, you can receive the expert level certificate. For that, you need to complete 3 tests. And as a result of all those 3 successful tests, you receive an expert certificate. And we need to update. We started working on updating these courses to version 13 of the system. How would it affect the certification? Well, once will update DBA1 to PostgreSQL 13. We'll start certifying for 13. And for some time, there will be 2 certifications coexisting. For those who are just joining it, they'll be receiving 13 certificates, so they'll follow the 13 string. And those who have started passing the test on version 10, they'll have a long time to complete. They'll have some long enough to complete the certification on version 10. Those who have expert certificate, those will be the people with some serious knowledge, and there are not many people. We appreciate them, and for them we are offering this transitional test that updates the certificate from version 10 to version 13, so they won't have to redo all the 4 tests. They'll have to sit like the updated single test. It doesn't make sense for a professional level. It's just for the expert level. Why would you need version 13 if you have version 10? Well, the certificates do not have the expiry date, but naturally the certificate kind of becomes outdated because the version becomes outdated. Version 10 will no longer be used, and the certificate won't be valuable. We have these plans to launch a 3rd level certification, master level. And to get there, you have to sit. You won't have to complete a theoretical test, but it'll be a practical test. We won't do it for version 10 naturally. We'll do it for version 13. So that's the plan. That's about certification. And now let's move on to the courses for the developers. Dev 1 is a basic course for the developers. It's a 4-day course, and we have recently updated it to version 12. What do we have in there? There, we talk give some new information about architecture. It's like DB1 level course, maybe a little bit below that, because some things are a little bit less important for developers. Then it's programming on, it's dedicated to programming on the server using 2 languages, SQL and PGSQL. What kind of functions there are, what you can do with that. And then we are talking about using some basic objects like tables, indices, and so on. But apart from that, we have subjects on entries and arrays. Here we use this application, special application, and it's we call it bookstore, and we have a VM. And for following the course, the students are creating some bits on the server side, and in the end, there will be some small application running there. And if you attended the previous Dev 1 version, Dev 9.6, so what's different? Do you need the new one? Not many things have changed, actually, despite quite a few Postgres versions happening. Procedures and transactions, managing the transactions is different. Also in in version 10, transition tables appeared. And in version 12, generated has appeared. So that's what we updated our course with. We also added a subject dedicated to logical backup. We thought that it would be good for developers because we don't have a separate course for developers on this subject. And we also added information on extension. Well, normally we demonstrate only the extensions that are within the Postgres, and this is an external, but we couldn't resist because it's PLPG SQL check, and it's by Pavel Stachuli, and this is the person who's doing a lot for SQL development. And it's not really external, he does a lot. So that's why we added information on this extension into the course. So that's about the content part. Then the format, presentation format also changed. We used to have for the courses, like we had a very long presentation, then we switched to terminal, and in terminal we show live demo of what we were talking in presentation part. And it wasn't really convenient because in demos we had to repeat things because you forget them by the time you are there. So we decided that it would be nicer to mix presentation and demo more tightly. So we talk a bit, and then we show something in the terminal, and then we are back to presentation, and so on. For it to be convenient, we have updated our platform on which we have courses, and now, at the right time, we have terminal appearing, something like that. Well, in video, it does not look smooth, but actually it's smooth. And here we'll be able, following the course of presentation, showing some things. And finally, we are highlighting the syntaxes, so it's easier to look at the queries. And once we don't need terminal disappears, and we carry on talking following the presentation. And that gave us the opportunity to split subject into things, because now we have some fragments that are presented at the same time in the form of demonstration and on the terminal, and you can leave the subject for a while without losing it, without forgetting it. Moreover, we have a single visual aid material, because we used to give out a file to read and a demo part. Now it's together. It's easier to use, easier to read and search for some information. And why did we go for HTML? Why? Because it's easier to copy from it. Because in PDF you always get these issues with copy and paste, and whatever you select does not always appear looking the same way when you paste it. But we left PDF as well, just in case somebody wants to print those materials out, and PDF is split into pages, and it's convenient. So these are the changes or updates. And this platform will be used for all of our courses. Now, let's talk about Dev 2 course. This is a new course. We have created it quite recently. It's an extended, expanded course for developers, also for day one. And if in the first basic course, we are giving the basic blocks, like how you create operators, how you create cycles, and basic things. And in Dev 2, we aim at showing how you take those blocks and put them together, making something fun. And the idea behind this course is the idea of expansion, or the ability of expansion. Postgres is great in such a way that it can be expanded, and you can add many things to Postgres or change something. So, and we took this idea and we are demonstrating how it can be done in this course. So what you get in this course, it's not really table of content here, but some pieces that we have. Well, traditionally, day one is dedicated to architecture. We talk in detail about what things are like, and we have nice training applications like a bookstore, but it's a bit more complex. And we are working on this application in the course, of course. Then we are talking about connection pools, some data types for storing big values. And we are talking about whether you can keep them in database. Maybe you can, you have to do it somehow differently. Weakly structured types, and we are looking at how you create the customized data types, how you can create your own data type. We check the operator classes, and it's the key to understanding what, how, and how you work with the indices.
We also talk about forms and processes, about backgrounds, and about synchronous data processes. Processing. Well, and in Postgres, we actually establish some kind of sequence, and we do it really nicely. We also think about our own extensions, how to work with them. We looked at about different servers, about different programming languages and what they should be particularly relevant for. We also take a look at our aggregates and window functions. We also worked with full-size search and replication, and also access to external data, different systems. So it's a kind of quite an intensive course, and we find it pretty relevant and interesting for users. So that is meant for developers. And here at the bottom of the pyramid, you can also see quite a big number of special courses. We don't have any of them yet, but still we have an idea as to how that can be arranged. For example, we want to organize a course to work with big data that could also include a particular focus on very relevant things. As for JSON, we could have a full-fledged course, because we have a lot of things, interesting things there. Usually it's only just about JSON overview. About context search, it could also be very interesting for users. I mean, FTS, GIS could be of interest, and so on and so forth. We have quite a variety of new ideas. Some courses do not exist yet, but I hope that sooner or later we will have some. These are some of the courses that could be of particular interest for quite a big number of different people. And apart from that, we also have certain activities related to the translation of our courses into English, so that those who speak English could also use these courses. So far, the only thing that we have at our website, this is quite a compressed version of DBA1. This is a 2-day compressed version, but we also started to work on the first DV1 and also wanted to, together with the update of PostgreSQL, think about some adjacent things that could be relevant for our work. That is basically it. But one more point, how can you actually take on those courses? First, you can do it on your own because we have materials available for our audience. You can start with a document that is called Guideline or Manual for I mean, those who just start working with this Postgres information about passwords, codes, and basic things can all be found there. Also, courses can be taken together or under the supervision of a coach. We also have over 10 certified training centers. Some of them are also presented at our website. All of the coaches or teachers at our centers, they are subject to very serious certification, and we are calling up on you to also be exposed to such similar certification where you could use the certificate upon the completion of such courses. And here, when we talk that we do have certain coaches, we understand that they have the needed level of knowledge for performing such a task. And by the way, it's located not only in Moscow, we have also a regional center all around the territory of the country. You can pick the one closest to you. We can also have training centers in Kazakhstan and Belarus, and that is why we can clearly state that you can be trained there. And you can also listen to some courses developed by various authors. Very often we like to go to different Moscow cities, Russian cities and towns, and to make presentations there. Sometimes it so happens that some companies, local companies, just invite us to come over and to make such performance or presentation. And also there we usually have some local educational establishments, some universities, and they also attract quite an audience to listen to such courses. We have already visited quite a number of locations in Russia, but unfortunately due to the pandemic we were deprived of such an opportunities, and the only location we went to was Tomsk, and we recorded 2 videos of our courses, and right now they are being a little bit adjusted, and soon they will be downloaded at our website. So you could invite us, and that would be a great pleasure for us to come over and to deliver or make our presentation. That is basically it. In case some of you from the audience want to be engaged in educational projects, or if you do have some questions, you are most welcome. I just specify a limited number of activities we are engaged in, but in fact we have more than that, and we don't have enough capacity to cover all of them. Probably have your own ideas you want to work on. You can always address those issues to us. You can write us, and here is our mailbox. So you can use it in order to address your ideas or your wishes, whatever it is. You can also address your questions, yes, I could say. And in case you do have some outstanding questions, want to get more information, here is our address. You can always send your information to this mailbox. That is it. I'm done with my presentation. Thank you very much for your attention. Thank you very much, Igor. Thank you very much. That was really interesting. And now it's time to proceed to questions, I guess. We have one colleague with us, represents also educational domain. I'm just looking at our chat just to see whether questions have been answered. Mr. Puchkov, question for you. He has already asked a question, but still, so exams are now only organized in Postgres offices, and what if we invite to do that? I mean, people, is it possible not just to deliver courses for somebody, but also to participate in examinations? Well, it can be discussed. That could be an option. I think that we could negotiate it. I would say that this is quite feasible. And also, we are happy to discuss that always. I would like to remind you that you could also make assessment of the presentation. You can leave your likes and address the speaker with your question in the chat. Actually, I have my own question for you. I have a question about certification. You have already mentioned something about certification for administrators, but what about developers? As for developers and certification, it's something should be definitely done. But again and again, we don't always have the capacity or always the power to do that. I think that's something that can be done in the near future, but I'm not sure about the exact dates. I don't know when it's gonna be done, but approximately. Speaking about the future, I cannot tell you for sure, because I hope that you do remember at our website for like 3 years we had this information that it was about to be developed and also put there in our website, but fortunately it takes time. But in case you want to participate in this process, you can send your information to us and we will examine it. Oh, you have already answered this question. You said something about update, but what about courses on SQL, something that you also plan to do? What about approximate date? We did not plan a course on SQL. We haven't even planned that. Probably it will be done. So far, we don't have such plans. We want to create some kind of a platform that we could use in order to tackle different issues and to do it in a way where we could work with different issues. And do you have an idea about the exact dates as when you actually are going to develop that platform? I cannot specify any dates, but we have already launched this process. And so far, I could not give you exact deadlines, but still we have, and we do bear this idea in mind. Thank you very much. Well, I have another question probably for you regarding the complexities where you had to work with this transition periods. For example, when you work with the materials and then you proceeded to demonstration, especially when it came to, this fragmentation and the use of different pieces of this information. I'm talking about that from the technical point of view. Well, as from the technical point of view, yes, of course, we realized that there was some difficulties, but like I said, we have all the necessary tools to work with these technical complexities. What can I say? I would say that at the very beginning we have to come up with quite a big script, the so-called creative script that was supposed to take presentation that we were meant to make in offices. So demonstration was taking, and for that matter we had an additional script p-form. So all the comments that you cannot see during the demonstration, these are the comments that are actually accomplished in databases. The only difference is that we do it manually with our hands, but it's done in advance in order to waste time on that. But actually, that is a real piece of work. This is something that is done as a part of this initiative. And we had to develop a certain script to work with this presentation, with demonstration. and also then we use it just as a part of this comprehensive process, so to speak. I would say that there have been some technical difficulties or complexities, and the procedure was not that easy, but at the end of the day we managed to come up with a ready-made product, and now we have something which is really watchable. Actually, you can go to the website to find out more about this piece of work, and I think that could be of interest for you. Yes, we had some technical issues, and you are absolutely correct, but they were quite insignificant. The point is that we do all those courses, we develop them with the help of also virtual machines. We also have particular software behind that, and you don't really get that much perplexed when you work with those complexities. This is doable, this is feasible, and yes, it can be done. Thank you very much. I have one more question for you. At the website, it was already mentioned that we certain books about database at PostgreSQL.com, but do you plan any update of those books as to actually how you can make an update of not only the books but materials, to have new versions of them? Yes, we do such plans. We are working on that. First of all, I'd like to say that, for example, Evgeny Pavlovich, he has already created something great. So that is a super book, PostgreSQL, and he plans to write second part of this book. There will be some information about programming, about some other significant issues. Work is in progress, but of course it also requires certain time. We are not quite sure about exact dates. I have an idea to also probably participate in those initiatives, or maybe do something similar. I'm working on that, and I hope that very soon I will be able also to present something, but we'll see what will come out of it. Anyway, that is doable. Well, that is fantastic. By the way, speaking about the hub, previously we saw a series of articles, but what about some other articles? Did you plan to any of them? Yes, probably it could be the case. It could be the case. I also have an article regarding query optimization. I will probably need some books to back up, so to speak, my work. But also there will be some other components or fragments that could also be of interest for us. So in case we have here readers of Hub, thank you very much for the questions that you left in the comments, because it's helped a lot to understand what is of interest for you, what was not interesting, what's actually worth mentioning, and stuff like that. So I think probably that could be the case in future. Okay, thank you very much. Anyway, we will be waiting impatiently for that. I'm gonna just check out our chat. Marat Razinovich Usurmashev is asking you the following thing. Good afternoon. Have you ever think about org mode? It can actually work with PDF. It can also, how is it called? Excuse me. Org mode. Org mode. No, we haven't actually analyzed or considered that, but I will definitely do that. Okay, good to hear that. Oleg Nikolaenko. I don't know whether it's a question or not. Cannot set the data. So Oleg Anatольевich said, I can work together with you in cooperation on the educational part. Well, when you use this kind of wording, like I could do something, yes, on the educational side, I don't think that it would work. If you have some specific ideas, that would be better if you know something that you would love to do. And we, of course, also want to assist you on that. So you could also share your vision, how you want to have something arranged or organized. We could discuss that together. You could also come over to our office in order to have a talk with us. We could find a way out just to how we can organize this process. Yes, just to discuss different options. Great. And Vasily Vichkov has a question. What about, is it actually to use through Expert 10 to Expert 13, or do it through Professional 13 to Expert 13? Both ways would work. I think that if somewhere we have some version 10s, through the 10th one, that would be easier. But as for version 13, if it's just the only one, that makes no sense, because some issues are covered in 10th. We have different answers, and actually in 13 it's a little bit different, and we have to remember about the difference between various versions. Well, basically it makes no big difference, I would put it this way. Thank you very much, Yegor. We are done with our questions, and thank you very much for your presentation. Thank you very much for your answers. Yes, we also have a special chat. I hope that you were able to ask your questions there. See you, Yegor. And we are gonna have a short break. Well, actually quite a considerable break. Approximately 45 minutes. Okay, see you there.
As in, just imagine what we'll do. As in, don't tell us what we can't do.
I'm unstoppable today.
Because with Intel-powered AI, cloud, 5G, there's no limit to what we can do. They said we'd never do this. Soon we will from 12,000 miles away. But there's still so much left to do.
So what are we gonna do about it?
How about something that enriches the lives of every person on Earth. Impossible? Not if we do it together, because all you need is an idea and intel inside to do something wonderful.
everybody and everywhere. Let's welcome Chris Travers. Many of PGConf attendees already know him well. He's IT director of a Just GmbH company. In the speech, we'll cover the good and not so good practices of technical support reactions to the incidents, on the real-life example of failed after vacuum and an inevitable approach of seed wraparound. So what happened? The speech is recorded, but I believe Chris will join us, so ask your questions in chat and he will answer them later.
Hello and welcome to my presentation, When Everything Goes Wrong, Incident Response in Large Postgres Databases. Now before I start my presentation, I want to call your attention to this picture I've used here. This is a DC-10 in 1989 making an approach for an attempted emergency landing in Sioux City, Iowa. The plane crashed. But as we'll see, this is actually a very inspiring case in terms of emergency management generally, including within IT. Now, my name is Chris Travers. I'm the Director of IT Operations at Adjust. I run the database department, the platform department, and such. And as a result, one of my major jobs is to keep everything generally running. So, my part in the story begins on a Friday morning, 3:45 a.m. I was sound asleep. I was woken up by my phone ringing. The voice on the other side made clear he was from our network operations center, and one of our database engineers was looking for my help. He gave me some warning messages that at 3:45 a.m. did not register very well. Like many of you, I assume I'm not thinking my clearest at 3:45. I was thinking about going back to sleep, but it occurred to me I should probably go out and actually talk to my colleague before I made that decision. So I got up, went over to my laptop, checked my Slack messages, and noted the impact statement was imminent major outage of our dashboard. Did some quick troubleshooting, and made the decision to call in my boss, the VP of sorry, not engineering anymore. He's the VP of infrastructure. By now, it's about 4 in the morning. Before we get back to this incident, what caused it and how we reacted, I'd like to go back to this picture I was showing. Now, this is United Airlines Flight 232, which crash landed at the Sioux City Gateway Airport on July 19th, 1989. You see here light coming through the tail. That's because 40 minutes prior, this number 2 engine here had exploded, throwing shrapnel through the tail. The explosion itself took out the number 2 hydraulic system, and the shards went through the number 1 and number 3 hydraulic lines, which all bled dry. The crew was then left with no standard means of controlling the aircraft at all. They had no steering, no brakes, no flaps, no elevator control. And the only controls they actually had were the throttles. Now, if you go and you watch that video, you can find plenty of videos of the actual crash online because it was a very well-recorded crash. You'll ask, how did anybody survive that crash? You see the airplane coming in, and then basically it hits the runway, bursts into flames, rolls over, and breaks into, I think, 4 or 5 pieces. But one of the very interesting things about this crash is that while it was initially reported very early on in the news that there might have been 190 deaths and, somewhere around 100 survivors, the numbers when they actually came in were almost exactly reversed. Almost twice as many people survived the crash as didn't. And while that does not minimize this terrible accident for those who did lose their lives or lost loved ones, it is an important reminder that some disasters are more manageable than others, and that sometimes even serious disasters have some manageability in them. Now, it's not just a matter of the fact that there were a lot of survivors, though. If you actually look at the injury rates, you would have thought if they had not crashed where they did when they did, again, the numbers probably would have been reversed. And so, the survivors included the entire flight crew, the entire cabin crew, 3 out of 4 lap children, and the majority of other passengers. So it's really, really, really remarkable. 2 years after this crash, the captain of the flight, Al Haynes, was giving a lecture to NASA where he was talking about this particular accident and what it could teach people about disaster preparedness generally. If you get a chance, Google Al Haynes NASA lecture. It's well worth watching if making sure you're ready for really unpleasant experiences is at all important to you. Anyway, Captain Haynes identified 5 major factors that he felt led to the survivability that they saw that day. The first, he said, was luck. But he clarified that to say we all have our own belief systems, and so he calls it luck in order not to intrude on other people's beliefs. The second one is communication, and this is actually the single largest one, as I'll talk about today, because it is on top of communication that the other 3, response, execution, and cooperation, are built. You can't coordinate an execution, and you can't cooperate or coordinate anything if you can't communicate. Responses, execution, cooperation, those are all things which rely on communication, and all these 5 factors apply very, very, very much to IT emergencies. Now, one of the things about this crash is that the way people usually portray the crash in popular media is that you had 4 heroic flight crew members who figured out how to control an uncontrollable aircraft and bring it in effectively to an airport where they finally crashed. But one thing that Haynes talks about at length in his lecture is the contribution of the ground response. 15 minutes before they crashed, the alert had gone out that an airplane had crashed. So when they actually crashed, they crashed in front of a waiting response. And hospitals were fully staffed, double-staffed even, and had lots of volunteers from the other medical clinics and stuff. And so the mobilization of the community and the ground elements contributed probably as much to the survivability of that crash as the flight crew did. And so that's something which we ought to all understand as very important and very inspiring. So back to our incident. Postgres is, as a relational database, I'm sure you all are familiar with it, is ACID compliant. And one aspect of ACID compliance is it always shows you a consistent viewpoint of the data. When a set of writes are happening, if that set of writes is not completed, we do not show any of the writes that are in progress. So in Postgres, the way we do this is we copy and write all data, and we track these with transaction IDs, also called XIDs, which are arranged in a circle of a little more than 4 billion values. Half of these values are ahead of any given point, half of them are behind, and so it's very important that all of your that your most recent XID is still in the future side of the oldest non-frozen XID. And the oldest non-frozen XID always has to be in the past of your most recent XID. So cleanup, because it freezes these old transactions, in fact, rotates the circle for you. And if you overrun things, what was in the future, what was in the past becomes in the future, and so you can't see it anymore. This is data loss. So Postgres tries very hard to keep you from losing data. It will shut down when it gets close and stop writes. And we were approaching this point, but we had not hit it yet. Now, in our specific case, these cleanup routines, auto vacuum had stalled for 8 days. We were at the point when I got up less than 10 million transactions away from wraparound. And within hours, we knew Postgres would shut down because we were using about 2 million transactions an hour. And auto vacuum was stuck vacuuming this table that's 3 terabytes on its own, plus 6 terabytes of indexes. Probably not going to be able to vacuum that in time, especially if we don't know why it stalled. And it's worth noting here, a lot of people say we fix XID wraparound by making them 64 bits, but by the time you face this issue, something else is wrong, and all you're going to do by making these XIDs 64-bit is you're going to allow yourself to dig yourself into a deeper hole before something else breaks. So I'm after going through this, I'm very not in favor of making XIDs 64-bit. So onto our luck. Timing of the incident was very helpful to us. It happened at 1 a.m. UTC. We happened to have a database engineer in Japan, which I'll get to in a moment, who noticed this within about an hour of it starting, hour and a half. And so by the time I was woken up, we were, basically almost 2 hours in to the warnings. But that was, still meant that we had 6 hours or so to respond. Finally, even better, the day of the week was Friday, and on Friday our dashboard is used the least. So we had the most flexibility in deciding what to keep running. If this had been on a Sunday or a Monday, we would have been under a lot more pressure to get things done, and so we would have been in far worse shape. But since it was Friday, we were heading into the weekend. People weren't going to use it very much on the weekend, so it took a lot of pressure off of us. So I want to talk about our preparedness and what really enabled us to weather this incident and come through it as well as we did. Because we had degraded services for about 36 hours. None of our production services ever had to be shut down. All we couldn't do was display all data to the dashboard, and a few other minor related pieces of functionality. So 2.5 years before, we had some stability issues. Actually, they were performance issues, which led some clients in Asia to be very, very unhappy. A couple of them even churned and were no longer customers of us. So in response to this, we instituted a number of reforms aimed at making sure we got all the customer complaints as quickly as possible and in as helpful a way as possible. We opened a direct line of support a direct line of communication to support. And this allowed us to address things like database issues bidirectionally. We could talk to them, they could talk to us. The second thing we did was we set up regular meetings with the support department to address stability and performance complaints from customers. Now, what these two things did was they ensured that we had a pattern of communication of talking to support. So when we needed to talk to support, we knew how to talk to each other. Because we knew how to talk to each other, we could give them the information they needed, and they could keep our customers updated and with all the information they needed to understand what needed to happen. The final thing was I fought for a while and finally got the ability to put a database engineer on the ground in Japan. Now, we did this so that we'd have somebody talking to Japanese support and operating on Japanese early morning hours. Again, it was aimed at communication, but here, of course, we also ended up with the extra time necessary because this was noticed at 3 in the morning instead of 9 in the morning when everything was about to break. So once this started, and I got the VP of infrastructure on the line, we started a video call. And we have some very important rules on these sorts of things. Everybody's equal. Anybody can say, stop, let's not do this yet. Anybody can object to any measure. Anybody can ask any question. It's highly interactive. And the major reason for this is because we want to know what we know, and we want to know what we don't know. It's very important that we don't do something that makes the situation worse. And so we have a strong emphasis on verification. So, for example, how close can you get to 0 before Postgres shuts down? I'll get to that one in a moment. But we'll talk about that communication as we get a little bit further. Now, going on to the first 3 hours, because the first 3 hours are basically we're trying to figure out how bad the situation is. We're trying to figure out what we can do before everything gets worse. We're trying to figure out what options we have to resolve the issue without taking down our dashboard and leaving our customers without the ability to get information from us that can prove to them that we in fact are still processing all the data that's coming in. So the first question is, how close can we get to 0 before Postgres stops writes? I mentioned that before. I asked that question. Mael checked the documentation. He says 1 million. My boss, Robert, says, can we verify that? And so at 4:15 or so in the morning, Mael and I are both digging into the Postgres code, making sure we understand how this number is used and what the impacts of it are. And he comes up with a number of 3 million, and I come up with a number of 1 million. Turns out, Postgres 13 is changed to 3 million because of a corner case where 1 million transaction IDs was not enough to clear it in single user mode. So as we discovered that, we decided we were going to shut everything down when we approached the 4 million mark. Second thing is, what can we kill? What can we do to slow the descent? What can we do to make it so that we can survive this as best as we can? So we kill the things we know we can kill with minimal customer impact, and then we start calling other engineers to get problem and impact statements about the rest. So that way we get the information, we can formulate a plan, and everything goes well. Correct answers in those cases are very, very, very important because you may not be able to recover from a mistake. Within those same 3 hours, we started reaching out to support, informing them of the current status, the plans, and what customers could expect when we started executing those plans. We were going to shut down parts of our data pipeline. That would mean that new advertising trackers would no longer show in the dashboard until we could get things back up to speed. We reached out to engineers in other teams for impact statements about shutting down these components. We determined we could shut them down safely. We made necessary changes to our infrastructure to do so. And it's important here to note that the communications we engaged in those first 3 hours set the tone for everything that happened. Our communications with support started strong, and they were strong the whole time. Our communications with some of the other development teams were really strong, and they continued strong all the time. Our communications with one development team in particular started out weak, and we never recovered that. That particular development team ended up spending the whole time being unable to figure out what the situation was, and they, in fact, had a lot of difficulty figuring out how to participate in, the recovery also, because we had to shut down some of their components too. So the next 3 hours, we executed this plan with advance warning to support. We told support what we were going to do. We told them what customers would expect. The development teams were already aware of what we were going to do. They chipped in, answering questions. The one question I got from support was, is the dashboard going to go down? And I was always able to say, we think the risk is very low, but if it changes, I will give you advanced warning. Support teams were able to have a clear idea of what to expect from customers and what to communicate to tell the customers what the situation was, and that the overall processing of the data was not in any danger, and that certainly on Monday everything was going to be fine. We were then able to respond freely to the database issues, and we were able to direct our entire attention to keeping it up. Of course, we could check into support, but on our terms, we didn't have to be distracted by support escalating questions to us all the time, because we had gone out and briefed all these development teams who were then able to step up and help out. For the rest of the incident, I describe it as the most boring emergency ever. The danger was, if some of these components we shut down ever came back up, the dashboard would go down and stay down for the rest of the incident. So we had somebody paying attention to the database all the time. I went to sleep. I got about 7 hours worth of sleep. In that time, the head of database had taken over for about 3 hours and then handed off back to the VP of infrastructure. This is very closely parallel to Al Haines' point that, in an emergency, somebody has to fly the plane. You need to keep an eye on everything, and if there are significant risks, keep an eye on them so that you don't get suddenly bit. At first we thought the incident would last about 6 hours. After all, fast storage. As it was, however, even standard vacuum freeze, went through 8 index scan cycles. And the whole incident lasted about 36 hours. During those 36 hours, we had made a few adjustments to things. I had tested whether vacuuming the oldest rel frozen XID, rel frozen XID table in a database, in fact, rotated the dat frozen XID. And did, so we knew we would be fine. Once this finished, we restarted services. We did the engineering necessary to make the data load faster to get things up to speed, and then we reached out to all the other development teams saying, hey, we're up. All this data is now real time. Can we help you figure out what you need to do in order to get your components corrected, as well as get an ETA on a full recovery everywhere. Now, we still had a few major misses in communication, but those misses were with the same teams where we started out with bad communication. So where we focused our communication at first and made sure we had it well, including calling people in the middle of the night, everything went very nicely. Where we decided not to call people in the middle of the night, we had continued problems throughout the incident. So that's on us. It's not on them. So I want to talk quickly about lessons learned. First of all, our shortcomings. Transaction XID wraparound problems don't happen because 4 billion transaction IDs isn't enough for somebody. They happen because you're not picking something up and monitoring, something's going bad, and you've missed an important trouble sign. That's what happened to us. It's the case in every other transaction ID wraparound case I've ever actually had a chance to talk to people about. We fixed that during that long period of time of watching the database. We actually put in monitoring so that we could track and hopefully next time get a week of a week of lead time, that would have been really nice. Then we wouldn't have had to shut anything down. But, monitoring will never be complete. And, any emergency you find yourself in, you'll see things that you wish you knew and you didn't. So that's an infinite task there. The more significant and completely important points that we found was that we had not prepared all stakeholders well enough. Those stakeholders then spent a lot of time without enough situation awareness, and therefore were not able to contribute as well to the recovery and customer satisfaction as we would have liked. That is on us as responders. It wasn't on them. Finally, we didn't really have a clear set of priorities at the beginning. We made decisions early on, but we made those based upon our understandings at the moment and what seemed important. We did not make them based upon sort of an organizational understanding of where our real priorities needed to be in an incident. So those are things which need to be corrected, and they will be corrected institutionally, not not simply in terms of technology. Now, the second thing was, this incident showed us the way in which preparedness that we had taken from one set of disasters carried us through another one, when this was a very, very different situation, and the importance of being prepared rather than just focusing on recovery. We all talk about disaster recovery. How many of us talk about disaster preparedness? But if we're prepared, we might have to worry, we will still have to worry about recovery, but the road to recovery may be a lot easier. Now we have been working on, and are still working on, improving our disaster preparedness plans. These will include, a lot of things that go into making sure that we are in a better situation if we ever face a major infrastructure disaster, whether or not it's about Postgres. Now, on the whole, I think we did very well. And not to say we always do very well, because we've had a few incidents while I've been there where I haven't been as happy with their performance. But on the whole, I thought we did very well. I thought our response was excellent. I thought it was a model for what I would like to see every time. And certainly we didn't respond to everything perfectly. That'll never happen. But if this were to set the bar, I would be very, very, very happy. And this shows the importance of planning, preparation, and communication when you're actually in an incident. And I would completely reiterate the fact that communication is an extremely important and underrated aspect of this. So on that day, we moved as a company. I want to thank you to the other responders, to the development teams that helped us out. It was an absolute honor to work with the first responders on that. And on the development teams, they were really, really great. I couldn't wish for better colleagues in that regard. Our technical support deserves a huge, thank you, just because, they were in a bad situation, customer expectations, etc. And, they were able to really rise to the occasion and, make sure that all of our communications to customers as well as back to engineering was solid. Couldn't ask for better help from the tech support team. Management was great. They mostly stayed out of the way, and kind of help. I don't know to what extent they were helping behind the scenes, but we really, really did respond as a company. And finally, the fact is, everybody here listening to this talk is doing so because there's something interesting about these cases that makes you realize, we need to think a little more about all the other pieces of preparedness. And so thank you all for I hope you find it useful, and I hope it changes some ways in which you think about your preparedness when it comes to your own databases. Now, if there's a little bit of time left, I'm happy to take your questions if this format allows for it. Thank you.
So, as expected, Chris joined us. If you have any questions, welcome, ask them in our chat, and we will have a little talk. It was quite interesting speech, not so technical, but more about management and about communication. And well, as the previous speaker said, we learn on incidents. And well, once we fall, we learn to work much better than if there's everything smooth and clear. I wonder what happened after vacuum.
I think, well, we may never entirely know. We've had a number of sort of changes in our write patterns over the previous couple of months, and it's quite possible that we just simply overwhelmed auto vacuum, especially with the cost-based delays, and at some point it got into a run where it couldn't finish. When we checked it, it had been running for 8 days. It was doing very little disk I/O, and it had not completed the first index vacuum cycle, which basically meant that about 30% of the table was massively under vacuumed.
I see. So it was sort of stale at state, and it was doing some work, but you didn't see the results of it.
No. Yeah.
I see. Also, after your speech, I can say that there is no such a thing like too much monitoring.
No.
you have to, if you once have an idea to will make a trigger or some graph of some metrics, you should do it. Better do it than don't.
So, yeah, in this particular case, one of my big frustrations was that we had actually tried to gather this data like about 3 years before, but the engineer involved in that had apparently calculated the age wrong, and so it never got into our production monitoring. And I only discovered this while I was trying to kind of figure out how to throw together some emergency monitoring, that in fact we were trying to gather this data, but unsuccessfully.
I see. So, and also, it's I have to say it's quite good for one to have incidents Friday evening. You should better have incidents Friday evening than any other day.
Yeah, well, I mean, in this case it was Friday morning, but yeah, I mean, the timing was such that it really took a load off of us.
I'm joking, sure. There is a question from chat. Is there any sense in ITIL for database administration?
That's a great question. I think that ITIL has a lot of there are cases where the framework makes a lot of sense. This is especially true where you have something, cases, for example, in financial services where your databases are very critical, and where losing them or availability is a massive problem. I think in cases where your primary loads are less critical, then I think you still want to. I still think you want to do all the risk assessments, and you want to figure out what it means for a piece to be down. You know, once you get to a certain size, I think that, you know, the kinds of problems that you run into tend to be different. And so while the methodologies help you, you also kind of have to adapt them and move in line with the sorts of incidents and problems that you've seen in the past.
Mm. So there is no more questions. You said about sort of horizontal communications and well, sort of team made of different layers of supporters, developers, engineers, etc. And I can agree, it's pretty vital, the horizontal communication with no position of, well, the big boss who's giving an orders.
So I think one of the things that's very important to look at in these areas is to take some lessons from things like I guess they call it a bunch of different terms, everything from command resource management training to I guess in the airline industries they call it cockpit resource management. Basically, the idea is that when you're in a difficult situation, you make sure that nobody is completely in charge, but that people who have specific responsibilities have the freedom to go ahead and do those responsibilities. So, what we would be happy to do is to, you know, we can take care of the database, we can brief other people, we can explain to them what we're going to do. Support can talk to the customers. We can ask developers to answer questions that might get escalated by support, so that we don't have to take that entirely on ourselves. But you know, I mean, the whole idea is communicate outwardly and try to make sure that other teams are in a position to help you out, because you know we think about these sorts of incidents as purely technical problems, but you know when it comes to a customer's experience, their concerns are going to range from is my service available, is money I'm spending on related things at risk, and do I feel like you know what you're doing when things go wrong? And those three questions are actually extremely important in these sorts of cases. You know, we referee advertising campaigns. If customers need to stop their advertising campaigns, that's a big deal. Mm-hmm. And they need to have the confidence to know that when we say they don't need to, they're happy with that. And that means that the support people who are talking to the customers have to have a pretty good understanding of what's expected and what's not when the customer reports a problem. And that's actually really hard when you're dealing with some of these database stuff, because you know when we shut something down, it may break some piece of functionality somewhere that we haven't thought about. And you know, in our case, that happened more than once, and it was the developer teams that were able to explain to support that. Because of the components we had shut down, that these pieces of the dashboard were not responding properly.
Okay, I see. The guy from chat also says about 64-bit exceed counter. Mm-hmm. You may say the same thing to him.
So first of all, I think that 64-bit XID counters provide something of a softer landing, in the sense that you know the database isn't about to shut down and be completely unavailable. The downside of them is that these situations don't happen just because you ran out of transaction IDs. Usually you run out of transaction IDs because something else is broken somewhere and vacuum is not progressing. the fact that vacuum's not progressing on itself is usually a bigger deal. So one of the serious dangers of this is that you can simply dig yourself into a deeper hole, and I think in our case we would have. There may be plenty of other cases where 64-bit XIDs would be very helpful, and I think if you have all the right monitoring, it would be it would be something that where you certainly don't have the time pressure, but it's also a danger that you could dig yourself into a much deeper hole, vacuum-wise, and have a much harder time getting out of it.
Thank you. And also, there is another one question. Could you tell me whether you do some kind of retrospective after incidents? If so, how it is usually looks like?
So when I was heading the database team, I started doing postmortems on every database incident, and an incident was defined as any case where our service level agreements were either violated or nearly violated. So if if something was down for over half of the time that we agreed it could be down on the service level agreement, we would do a postmortem on that. Postmortems I did were always in a number of sections. We'd start with the timeline, of course, and the technical discussions, and then we'd end with the recommendations, and typically recommendations would be half or more technical, and then maybe half or less, organizational. So it might be something like, in one case, one of the recommendations was, the team that should have called us when something went wrong didn't have enough people on it, and so they need to have more staff. Other times it's, we weren't monitoring for these things, we need to monitor for them. A few more times it's been, cases like this particular database has serious vacuum problems. We believe they've been resolved in the course of the incident, and here are the things we did to solve it, but we don't have any further recommendations. We'd also tend to look at what went well as what went poorly, and I think people tend not to look at both of those cases sometimes, in that the pieces that go well are important in order to understand what you're building on going forward. So I always make sure that we covered both of those as well.
Okay, thank you. So we already ran out of questions. There is such a thing like spatial chat. You can go there, and it's sort of, okay, we've got more question, and we've got 1 minute left. How did you mention it that after vacuum had been stopped by Zabbix, etc.?
So what happened was Mael got up in the morning, checked his emails, and he saw the warnings that we were running out of transaction IDs. He then investigated and found that AutoVacuum had been running on one table for over 8 days, and we then used tools like IOStat and IOTop to determine that while it was running, it wasn't really doing very much. So this was all active technical investigation based upon concerning messages in emails, and that's really not how you want to find out about these things.
Yeah, thank you. I invite everybody to spatial chat. You can ask Travis well, sort of individually. Thank you very much. Now we'll have a short pause. The pause will be 5 minutes. И потом Дэвид Стиле. Спасибо.
And next we'll have David Steele.
Our next talk is a recorded talk. It is by David Steele, who will tell us about PGConf best backup practices. So, welcome, David.
Welcome, everyone. The name of this talk is Backup Best Practices with PGConf. We'll start with a short introduction and then talk about why and how to back up. What is PGConf? We'll discuss different types of backup types and retention. Then we'll move on to archiving and the importance thereof. We'll discuss recovery point objective and how to meet it. We'll discuss backups and recovery time objective and how to meet that. And finally, restore and recovery. My name is David Steele. I'm the principal architect at Crunchy Data. I've been actively developing with Postgres since 1999. I'm the primary maintainer of PGConf and PG Audit, and I'm also a Postgres contributor. So the first thing we need to talk about is why backup. There are a ton of reasons, really, and you probably know some of them, but I'm going to go ahead and go through the list because there are some you may not have thought of. The first one, of course, is hardware failure. No amount of redundancy can prevent this, so you really need to have backups of some kind to prevent losing your data when you lose your hardware. The next one is replication. Having a wall archive is great when your async streaming gets behind. And you can also sync a replica from a backup instead of from the primary, which reduces load on the primary. You can use backups to deal with corruption. Corruption can be caused by all kinds of issues, hardware or software. In this case, of course, the real challenge is detecting that you've had corruption in the first place. There's also accidents. Someone dropped a table, or a user accidentally deleted the most important account through the application interface. There's development, so there's no more realistic data than production, and so if you can use that in your development environment, that can be quite useful. This may not be practical, of course, due to size or privacy issues, but if it's an option for you, it's a good option. And the last one is reporting. So oftentimes reporting is done against production servers, but instead you can actually restore a backup and allow the reports to run from that restored backup if they don't need real-time data. For instance, if the report is starting from the previous day or the previous month or whatever. And the nice thing about that is you can also bring that up as a writable server so that you can create temp tables and do other things like that you might need to do your reporting. You can also recover data that was removed on purpose for reporting purposes. So let's say you're expiring out data from partitions or whatever. You can recover an older backup and get that data, or you can recover a backup and then restore that data from a PG dump. All kinds of options there, but all that can happen offline and reduce the load on your primary. So what you should really be doing in your environment is making your backups useful. A lot of people think of backup as something that's used in a disaster recovery scenario, but it's actually better if you can find ways to use your backups in your general enterprise, like, as I said before, syncing or creating new replicas, offline reporting, offline data archiving, developing, etc. So the key here is that your backup and restore should be something that you're completely comfortable with and you're doing more or less on a daily basis. So that way, when it comes to the emergency, the restore that you're doing is just a normal procedure that you do all the time, and it's not something extraordinary that suddenly you need to go be looking up guides and figuring things out, and there's panic and sweating, etc. So practice, of course, your disaster recovery scenarios, but also integrate your backups into your enterprise in a normal way so that you're completely comfortable with those procedures when it comes time to use them. So what is PGConf? PGConf is one of many backup solutions that are available for Postgres. It's easy to use, it's enterprise class, it can scale up to the absolute largest databases that you use, and we built it from the ground up to be designed just for doing database backup. Some of the major features are parallelism and asynchronous operation, full incremental and differential backups. Backup and archive expiration is automatically built in. There are tons of integrity checks, checks on verification. We have Delta Restore to make restores as fast as possible. We have S3 and Azure compatible object store support with GCS coming very soon. Encryption, we have multiple compression types, etc. Some of you may know that the original project was written in Perl, but we spent a couple of years migrating it to C, and that migration was finished in 2019. So there's still Perl in the project used for testing and documentation and stuff, but the binary that gets distributed is now pure C. So let's talk about backup types. There are 3 different backup types we support, and these are the pretty standard types of backup types that lots of backup software supports. Not all Postgres backup software does stuff. The first type is full. Everyone should be familiar with this. This is just a complete copy of the database and is not dependent on any other backup. The next one is incremental, and in this case, we only copy the files that have changed since the last backup. And that last backup can be full, differential, or incremental. So an incremental can be based on the prior backup, can be anything. And then the last one we have is a differential. Now a differential is really just like an incremental, but it's always based on the last full backup. And the big advantage of differentials is they can be expired independently. So if I create a full backup and then create differential 1 and then differential 2, if I like, I can expire differential 1 to save space, because differential 2 just depends on the full backup, never on differential 1. Whereas with an incremental backup, incremental 2 will depend on incremental 1, which depends on the full backup. And you can't delete anything in that chain, or of course you'd lose data. Now the incremental is the default, because it's generally the least expensive backup type. If there is no full backup yet, then the incremental will automatically be switched to a full, if none is specified. So backup retention obviously is important. Backups are great, but they take up space and you can't keep them forever. So for me, I think a good default retention is 5. Assuming you're taking full backups once a week, this will give you 4 weeks of backups. Not everyone has enough space or money to do this, but this is sort of the ideal backup scenario. Some people go longer. I've seen backup retention as long as 2 years before. But for most people, 4 weeks is enough for disaster recovery. And then what I like to do is have 3 differential backups that are rolling. So we do a full backup on Sunday, and then we do differentials the other days of the week, and we've always got backups for the last 3 days to deal with the vast majority of disaster recovery scenarios. If we need to go back further than 3 days, that's fine. We have the full backups to support that, but there's going to be more wall replay, and the recovery is going to take longer. So that's always something to keep in mind when you're looking at the schedule, is how long is your recovery going to take, and how long can you afford to wait for that, which is something we're going to discuss in depth later. So with this retention, there'll always be at least 5 full backups, which means 4 weeks because we scheduled the full backups on Sundays. If the backups are run weekly, right, but if they're run weekly, there'll be 4 weeks of retention, but if they're run more frequently, then the retention will be reduced, because in this case, we're keeping 5 backups. But a safer option is to use time-based retention. So in this case, what we do is we tell how long we want the full backups to last. I've set this to 28 days here. So now when you run a full backup once a week, and differentials the other 6 days, there'll always be at least 4 weeks of backups. Now, if you take a full backup every day, then there'll be 28 full backups. But let's say you're taking them once a week, and then you accidentally add in an extra one, then you don't have to worry about, you'll always have 4 weeks of retention in this case, even if you have an extra full backup. And if you want to, if there are extra unneeded backups because someone accidentally created one that you don't need, you can prune out those backups with ad hoc expiration. Note here that if the dependent backups will always be expired, so if I have a full backup and a couple differentials and maybe an incremental based on that, and I expire the full, all those differentials and incrementals will be expired at the same time. If you want to see what's going to happen there, use the dry run option. The dry run will not delete anything, but it will let you know exactly what backups are going to be affected by your expiration. So if you want to have a completely custom expiration scheme, retention scheme, you can actually combine the info command, which will give you a backup list in JSON format and when they were actually made, and then you can use ad hoc expiration to prune out the backups that you don't want. This, of course, is going to require some coding, you'll need to have some kind of scripting around that to make that work. Okay, archiving. So let's talk about archiving. Archiving is taking the wall segments that Postgres produces and offloading them to another server or another place. It could be S3, object store, it could be another server. But the idea is to preserve those, because if you want to do point-in-time recovery, that point-in-time recovery is the last backup plus the wall segments that are required to play forward to that point in time. So the way we do it is we do asynchronous parallel archiving, which you need to turn on, but that allows compression and transfer to be offloaded to another process and everything run in parallel, and it improves throughput significantly. You do need to make sure that there's enough space to hold the wall for an extended period if archiving stops. Let's say you've got some kind of network error, someone messes up the configuration, some other thing happens, the archiver starts failing, and that archive those wall segments will build up inside the PG wall directory on Postgres. And if you run out of space, Postgres is going to panic and stop. And that will be it. Nothing will be corrupted in that case, but the database will go down, which is a very bad thing. So it's very important to monitor archiving. First of all, you need to have enough space to have an extended amount of time with archiving down, even though you don't want archiving to be down. And then you need to be monitoring it to make sure that archiving is working. All right, so now that we've got some of the basics there, let's talk about recovery point objectives. So a recovery point objective is the maximum acceptable amount of data loss measured in time. So let's say my recovery point objective is 15 minutes. That means it's acceptable for me to lose 15 minutes of data from my database after some kind of disaster or failover, etc. So we need to define our RPO. A lot of people will say, okay, well, my RPO is 0. I don't want to lose any data. And that's an acceptable answer, but you have to understand that there are going to be a lot of compromises you're going to have to make for that. For instance, the only way to really get to RPO 0 for sure is to use synchronous replication, which can have major performance impacts on your database, and especially if it's high latency, like you're talking between multiple data centers, or you've just got slow data links or whatever. And in certain situations, a 0 RPO may not be possible. So one of the scenarios we talked about earlier was the user accidentally drops a table from the database. If that change gets replicated to the standby, then you've got a situation where you have to restore from a backup and get to the point before that table was dropped. And so that may mean losing some data that was written after the table was dropped, or perhaps recovering that data from PG dump. There are lots of options, but the whole idea of absolutely 0 data loss in all situations is maybe not completely realistic. And when you're making your plans, you should be planning for what happens if there is some data loss. Because if you plan for 0 and then you get in a situation where you are going to have some data loss, you'll have no procedures in place to deal with that. So for a non-zero RPO, there are a couple of good options. One, of course, is the main one that people use is asynchronous replication. The problem with asynchronous replication is there's something called replication lag, where the replica is not able to keep up with what the primary is doing, either because the network is too slow to transfer all the wall files, or because the fact that the replica is doing recovery single-threaded is not enough to keep up with the multiprocessing on the primary. Various reasons here, but it's not uncommon to be generating enough transactions that the replica falls behind. So another thing you can do is use this value option in Postgres called archive timeout, and this ensures that a wall segment is archived at the interval specified. And as I said before, archiving in PG Backrest is extremely high performance, so we can keep up with data volumes that replication cannot. So your replica might fall behind, but at least you know that data is safely offloaded from the primary onto your backup server or object store or whatever. So if you get to the point where the primary goes away, you'll still have your data. You just need to wait for it to replay on the standby. So these two methods basically can also be combined, of course. In most scenarios, you're going to have both. Every disaster recovery scenario is contains multiple parts. You're not relying on any one thing to help you. You've got replicas, you've got backups. You may have redundancy in your hardware. You've got all these things going on to give you multiple outs when something goes wrong. Another good practice is doing backup from standby. So backup from standby allows you to run a backup from one of your standby servers, which can greatly reduce load on the primary. Now, PGBackup uses a slightly different technique than most software does. We have a hybrid technique that uses both the primary and a standby to make a backup. So the backup is started on the primary using the normal PG start backup command. And then we monitor the standby and when the replay location on the standby reaches that start backup location, then we can start copying from the standby. This reduces load on the primary because replicated files are copied from the standby, and then we pull a couple of files off of the primary that are needed, like configuration files. Anything basically that's not replicated that's in PG data will be copied from the primary. But usually that's an extremely small list of data, and so primarily everything goes from the standby. One of the reasons why we went with this method originally was that there are a couple of disadvantages to the typical way of backing up from standby, and one of the big ones is the standby is not able to rotate the last wall segment at the end of the backup. So you either have to wait for that wall segment to be rotated by the primary, or you have to just complete the backup without having that wall segment. And PGBackup is pretty picky about making sure that all the wall segments that are required to make the backup consistent are present at the end of the backup. And if they're not there, the backup's going to fail. Because the fact is that backup really isn't any good with all those wall segments, and pretending that it is basically a bad idea. Another reason why we did it, and this is a possible future feature, is because of the way we've done this, we can actually do the copy from as many standbys as we want. So that could be parallelized across an entire fleet of standbys for a kind of extremely large database. But the primary benefit is just to get this load off of your primary. So another thing is to always remember to back up to a safe location. If you're doing your backups to a directory on the primary, this is really not a good idea, because the whole idea is you're trying to make your primary not a single point of failure. And if your primary database is there and your backups are there, then you may still have a replica. The replica might be behind, but the replica is only part of a disaster recovery solution. And if you lose your primary and your backups at the same time, you kind of lost two legs of your solution at the same time, which is not a good idea. So what you want to be doing is you can back up to a repository host, which we support. So you can have a remote repository host, which has whatever storage you like. You can use NFS. That's perfectly acceptable. Just have NFS mounted on the Postgres host, because that's still copying off the host. Perfectly fine. And then you can have that same NFS mount on the standby, and they're sharing the same storage. These days, it's increasingly popular to use an object store for backup. They're by definition off-site, unless you're running your own, but they're at least off the server. And if you're using something, from one of the big services, then your space is essentially unlimited, or at least as much as you're willing to pay for. The next thing you should be doing is enabling page checksums. Now, there are some performance considerations with page checksums. They cause something called write amplification. I don't want to go into the details here, but know that if you're running with page checksums, you are going to generate more wall, and there are going to be more writes. But my belief is that what you should do is start with page checksums, and only in the cases where they cause extraordinary pain should you back off on using page checksums. The good news is in newer versions of Postgres, you can turn off page checksums fairly easily, but you can't turn them back on easily. So that's the benefit of saying, well, we'll start with page checksums and we'll turn them off if we're not able to use them. So the nice thing here is that page checksums, basically what Postgres is doing is creating a small 16-bit checksum for each page, 8K page in the database. And so Backrest is actually able to read and verify these checksums while it's doing the backup. And it doesn't really add a lot of additional cost, because we have to copy all the data through memory to compress it and do all those things with it. So while we have the pages in memory, we're applying these checksums. We use the same code that Postgres uses to calculate the checksums. Literally, just copied the code. So it's as fast as Postgres does it. So the idea with page checksums is you can actually detect corruption. Basically I/O corruption, something on the disk. Hopefully this is not corruption that's caused by Postgres. If it is, then that's really bad. But what we're hoping here is this is if you lose a page on disk, especially in virtualized environments, etc., this seems to be more likely to happen. So Backrest will tell you when you get these bad checksums, and you can get this information through the info command. So if you do get corruption, don't panic. The whole idea of having multiple backups is you can use those to do recovery. And if the corruption was caused by some kind of I/O issue on disk, there's a good chance that restoring an older backup and performing recovery by replaying all the WAL will actually get rid of that corruption. Before you do this, you're probably going to want to figure out what the source of the corruption was, or get on new storage or something like that. Another thing you can do is that sometimes it'll be the corruption is just in one area. So once you fix your I/O issue, you might be able to just go restore that table from an older backup. Let's say it's some kind of dimension table or something that doesn't change very often. If you can verify that it hasn't changed since X date, then you can go and retrieve that data and then load it back into the primary database. You can also do things like, if it's just an index, you can just rebuild the index. Again, after you've addressed the underlying I/O issue, you could just rebuild that index from the table and you're good to go. But the nice thing is Backrest is going to tell you when you have these conditions, otherwise you may not know because you may not be hitting that part of the index on a regular basis. And until you do, Postgres isn't going to give you the error. So failed backups. Earlier I was talking about WAL archiving and talking about how important it is to keep WAL archiving working, as well as possible all the time. So backups are a little bit different because we have lots of different backups. So a failed backup should not be a big cause for panic. Ideally, there are a number of backups that can be used to restore. Because remember, in the ideal retention scenario, we have 8. We'd have 5 full backups and 3 differentials. You may have fewer than that in your environment, but there's still going to be at least 4 or 5, 6 backups that can be used. So it's the recoverable database that we're looking for is the backup plus the WAL segments that were generated after that backup. So we restore the backup, we let it get to consistency, and then we replay the WAL as far as we want. In many cases, people are just replaying WAL to the very end, as much as is available. That's the standard scenario. You can say that if you're trying to recover from a situation where a table is lost, you might be doing point-in-time recovery to an earlier point in time to recover that data. And at that point, as I said before, you have multiple options. You can either bring that database up as your primary and accept some data loss. If it's a data warehouse type situation, you may just be able to reload your data. Or what you can do is do that recovery on another system to, right before the table was dropped, PG dump the data out of the table and then restore that back into your primary. So there are a bunch of different scenarios that you can do here. They really depend on the type of database you have, your retention rules, etc. But mainly the main thing is, so if your database starts archiving over the weekend, say on a Sunday morning or something, there's a good chance you're going to want to raise an alert on that and get someone to figure out why archiving is not working. Because not only you're not getting WAL off-site, which is bad for your recovery point objective, but you could fill up the disk and Postgres will stop working. So that's also not really good. However, if a backup fails on a Sunday morning, everyone should keep sleeping. This is an issue that maybe you can deal with on Monday morning. So if you're setting up your monitoring to look at backups, I would say maybe throw an error when you haven't seen a backup in 3 days, right? Because that'll give you the weekend to sleep in. And on Monday, you can figure out why your backups are failing, knowing that you still have a backup from Friday. So, it's really not the end of the world here. Now, the one disadvantage of working from an older backup, I should mention, is that recovery will take longer because there's more WAL to replay. So depending on how big your database is and how much WAL you generate, this could be minutes to hours to days, literally. The next thing to keep in mind is that if there are any gaps in the WAL, like there's some corruption on disk, or file is lost, or in object stores sometimes files just go away, there are no guarantees, then you won't be able to play past that point. So ideally, you always want to be using a backup that's as new as possible, but in general, a backup that's 2 days old shouldn't be cause for panic in most scenarios. But it's up for you and your enterprise to decide, where the panic points are and what you absolutely need to require in monitoring. All right, so let's talk about recovery time objectives. So remember, recovery point objective was the maximum amount of data that we would allow ourselves to lose during a recovery. And we talked about why RPO 0 can be tough, but something like RPO 15 minutes is generally a lot more reasonable and can be accommodated pretty well. Most people are going to try to find something in between those 2 points. 15 minutes sounds like a lot to a lot of people, and I agree personally. So recovery time objective is the amount of time it takes you to get to your RPO, right? So let's say our RPO at this point doesn't matter. It could be 0 or 15, but we need to know how long we can afford to be down, essentially. So we have some kind of disaster, there's some kind of failure, and then what's the period of time between then and when we resume normal operations? Is that 60 seconds? Is it 15 minutes? Is it 1 hour? And again, these things all depend on the enterprise and the database. If it's a data warehouse, which is feeding data to another system, there's a good chance that the RTO could be measured in hours, because as long as it's ready to load data into the transactional system by the next morning or whenever your data loads are occurring, then it's not a big emergency. And it might be that your data warehouse can just be, failures there can be dealt with during the day, and they don't have to be dealt with in the middle of the night. But so when you think about recovery time objective, just like recovery point objective, you need to be thinking on it really on a per database/application basis. To apply RPO, RTO across an entire enterprise is almost certainly a mistake, because different databases have different requirements, different applications that are using those databases have different requirements, and you need to keep all that in mind when you are making these rules. So how do we meet the recovery time objective? Well, the first thing, of course, is you have to define it. We were just talking about that. The easiest way to meet a low RTO is to have a standby server ready, and then fail over to that from the primary. This can be done manually or with a tool that automates the process like Patroni. Automating the process of failover is becoming increasingly more common. And you do need to think about the tools that you're using, because Patroni has a bias towards uptime by default. So it's going to, if you have multiple standbys, it's going to pick the standby that is most up to date, and it's going to promote that within some period of time. And it's not going, by definition, it's not going to care that much about how far that standby might be behind. So if it's 30 seconds behind, maybe that's not a big issue for you, but if it's 30 minutes behind, that might be an issue. And if it's 30 days behind, well, now you've got a real problem. So in this situation, just like we were monitoring the archiving to make sure we've got archive off system, we need to monitor the standby to make sure replication lag is within our tolerances. So if the replication lag exceeds our RPO, we need to have alerts for that. And know that's happening. In fact, you should be doing something like alerting when the replication lag has gotten to maybe 50% of your RPO, right? That way you have a chance to do something about it, hopefully, before you actually exceed your RPO, because if you have a disaster right at that point, you're not going to meet your RPO. Whereas in this case, you're almost certain to meet your RTO because failover it's not instantaneous, but it's quite quick. So this can't be said enough. A standby is not a backup, okay? So a standby is part of a disaster recovery solution, and we see here it's great because if we have a failure on the primary, in this case we're talking about hardware failure, system crash, networking failure, the thing gets isolated somehow and no one can talk to it anymore, who knows? So in that case, the standby is your go-to solution because the standby has a copy of all the data that was on the primary, up to a certain point, hopefully up to your RPO, and then you can just fail over to it and you're good to go. And then you can go figure out what happened to that primary. Now, hopefully you have another standby to take over if things go wrong then, but if not, you should have a little bit of breathing room. But there are other types of things that can happen that standbys are not good for, and what the classic scenario that we were talking about is something gets dropped or deleted on the primary. You can have delayed replication, which obviously affects RPO, and some people will do that. But in general, you need to be prepared for the scenario where something gets deleted off the primary and gets replicated to the standby. And in that case, the standby is not going to help you because that data is now gone. So you need backups to cover that scenario. As I said before, there are all kinds of other things you can use backups for. So you shouldn't think of backups are only for the use in this one scenario where the standby, data is deleted or the standby fails or whatever. There's all kinds of things you can use backup for in your daily enterprise, and you should be thinking along those lines. So daily backups are usually sufficient to meet your RTO requirements, but you need to measure, right? So like I said before, if you recover a backup and then you replay WAL, that's going to take a certain amount of time. The restore itself takes a certain amount of time, and then the recovery takes another period of time. Let me define those a little more specifically. The restore is what PGConf does, and that is the action of taking the files from the repository and copying them back into the PG data directory. And PGConf can do this very efficiently because of the Delta restore capability. We have checksums of all the files that are in the repo. We can compare those to the checksums of the files on disk and only restore what's needed. So Delta restore can be extremely fast even for a large database. It just depends on your rate of change. So the rate of change is what affects the restore time. If you're restoring to a system that already has data, if it's a completely new system, then you're going to have to restore everything, of course. Recovery time is what Postgres does once the PGConf has done its job. It's copied the files back. It's set up the restore command. Now Postgres is going to replay all those WAL files on top of that backup to get you first to consistency and then to whatever your recovery time, whether it's the end of the WAL or whatever. So you need to do tests and measure that restore and recovery time so you know how much that is and make sure that it actually meets your RTO. You can't always depend on having a standby around for RTO. That's the lesson here. So you also need to measure what it takes for you to basically restore cold from a full backup, restore an entire backup and do all the recovery from your last backup, which I generally recommend to be daily. So this is something I've been putting in my slides for a long time, but this is true. The state of any backup is unknown until a restore is attempted. So you need to be doing restores on your backups. And if you just are running the backup solution and hoping everything's going to work and you do a restore, you might be disappointed. PGConf has tons and tons of stuff built in to tell you when backups are not working correctly. But it's possible for those to be disabled. It's possible for those warnings to be ignored. Not everyone monitors their logs as well as they should. So you should proactively be testing your backups to make sure that they actually work. So like I said, multiprocessing can lead to dramatic reductions in restore time. But your network bandwidth is still going to be an issue. Delta restore can save time. Also, when you're doing recovery, double check where you're restoring. Backrest will refuse to overwrite a running cluster, but it will overwrite a shutdown cluster if Delta is used. So if you've got like let's say an old primary that you're going to recreate as a standby, but well, wait a minute, you don't want to overwrite the data that's already there initially, right? You want to keep that data because maybe you want to do some forensics on it, or maybe you're hoping to recover some data from it, or you're just a case. If you take backrest with the default configuration, which was in whatever PG data directory you had specified, and you do a Delta restore, it's going to make that primary look just like the last backup, and all that data will be lost. So my preference is to, in a situation like that, to leave that old database alone and bring a new node into the cluster to be the new standby. And that gives you some leisure to go look at that old primary and decide whether there's any data you need off of it. Maybe you need to do some forensics work to find out why that primary went down in the first place. It may not be clear. It could have been a software issue, hardware issue, maybe the storage dropped offline. There's all kinds of things that can happen. And if you know what happened, that can help inform you to make sure, that doesn't happen again in the future. So you need to do the restores to find out how long they're going to take, right? That's step number one. But then you need to test your restores. So what does that mean? We need to validate that the database looks correct after the restore. So there are a couple of things we can do here. First of all, if we're doing some kind of automated restore testing, which I recommend and a lot of companies do, you need to make sure that your RPO is met. And one of the easiest ways to do that is to check timestamps in the database. So everything, Postgres is going to have all the transactions up to a certain point, and then nothing after. So it's not going to really cherry pick. Now, if you have a really long running transaction, that one may not commit, whereas some smaller transactions will commit. But one thing you can do is you can actually just check the timestamps. So if you've got some kind of logging table, you can look at the timestamps in that table to make sure that you're keeping up to date on that table. And that's a pretty good indication that your RPO is met. RPO is RTO is easy to measure because you're just looking at the amount of time it took you to restore and recover. But RPO needs to be measured as well because it may not be clear that the database is only 15 minutes old rather than 30 minutes old unless you have some timestamps to help you verify that. One thing you can do in this case is just have some kind of heartbeat. If you really want this to be accurate, you can have a process that is just literally updating the timestamp in a table or logging to some table on an extremely regular basis. So you know for sure that you're getting new data, your restore has that new data in it. Because if your database has less traffic, it may not be exactly obvious to you that the restore is older because all the timestamps are old, and that's normal because it only gets updated once every 6 hours or something like that. But it could be updated more frequently, and you wouldn't know, and you would be losing that data. Another thing you can do is use tools such as AmCheck to verify the consistency of the cluster. So what this tool does is it goes through and it looks at the logical consistency of the database. So it's making sure that the indexes actually match the tables, et cetera, et cetera. So this is something that you can't really tell from just checksums. Because the pages may all checksum correctly, but there may be some logical inconsistency in the database. This can happen because of bugs in Postgres. It could happen if a file was copied over or swapped or something by a user. All the checksums in that file would verify correctly, but the file would no longer logically match the other files in the table. So if that file was an index and you copied it over with some older copy of the index or something like that, these files are no longer going to match. Like I said before, in some cases, when you find corruption like this, you can just rebuild the index. But if the issue you find is that there are primary keys in the table that shouldn't be there, and don't match your foreign key constraints, then you've got some more cleanup ahead of you. Another thing you do, which is fairly simple, is run a PG dump, and if possible, restore the cluster from that dump. And that'll let you know whether all your primary keys and foreign key relationships and all that stuff are good. This may not be possible if your database is particularly large, but at least I would recommend doing the PG dump because it'll let you know that all the heap tables the tables can be read at least, even if there are problems in the indexes. And the last thing that you can do is most organizations have some kind of smoke test or regression tests that they are running when when they, let's say you're upgrading your application, you do the upgrade to the database, and then you run these smoke tests. Well, you can run those same smoke tests after a restore. And that will just generally let you know that everything's there. It may let you know if data is missing, like say data and dimension tables that should be there, and now your tests don't run anymore because that data is missing, et cetera, et cetera. So if you have smoke tests or regression tests, that's a great thing to do here. And the nice thing is you don't have to worry about them being destructive because you've restored this copy of the database to do testing on. You bring it up as a writable cluster, and then you can go do what you want against it. And when you're done, you're actually going to throw away that result. So it doesn't matter what changes you might make to the database. So you might have tests that are even more destructive than your regular smoke or regression tests to adequately test this database. So in conclusion, you really need to make a disaster recovery plan. This is extremely important. You can't be winging it on the day of the disaster. You can't anticipate everything, of course, but you can, most database people have a fair amount of experience with, these are the things that have happened to me in the past. This is what I need to be looking out for. The next thing you need to do is document the disaster recovery plan. It's not enough just to have a meeting and talk about it. You need to write it down to make sure you know that everyone's on the same page and you've covered all your bases. And then the last thing is, we were just talking about, you need to practice that disaster recovery plan. The great thing is these days, there are all kinds of good virtualized environments you can use to make sure that you're, set up a bunch of servers, try all kinds of different scenarios, bring down the primary, bring down the network, fill up the disk, all these sorts of things, and you can try them and see what happens and practice how you would recover from those. All right, thank you very much. That's all I have. Are there any questions?
Okay, thank you for this very good recording, a very complete manual for backing up, and for the strategies and for tactics, how to do this. So for me, it was very interesting to listen to this talk, and we have a lot of questions, and now David is here to answer them. So let's start. First of all, what about wall archiving? Some guy is asking about how can you show an example or describe maybe some example of settings for correct wall archiving?
Okay, well, that's going to be a little hard to do here on video, but what you can do is
maybe just give some ideas.
Yeah, if you go to the PG Backrest homepage, actually, which is on that last slide, pgbackrest.org, in the user guide, which we provide for Debian and RHEL, in the Quick Start section, there will be a section called Configuring Archiving. And it actually goes through all the settings that you need for configuring archiving in the settings in Postgres.conf, like archive mode, archive command, wall level. And so those settings are actually set out there, and so that's the best place to go. There are also plenty of tutorials for PG Backrest written by many people like Stefan Foucault, for instance, etc. So one of those would be good. I'd be happy to get on the chat in a little while and paste in some specific URLs if that would help.
So if you have, for example, if you have given some PTO, for example, 10 minutes, what should be should you have some special settings for wall archiving?
Yes,
so it doesn't depend on PTO.
The main setting that I would set in that case is the archive timeout setting in Postgres, to make sure that Postgres is going to create and archive a wall segment every 10 minutes, right? So that way, if your replica falls behind, you get some kind of lag there, you know that every 10 minutes you're going to have a wall segment archived, and that will help you meet your RPO. Now, in that case, though, you do need to be monitoring the archiving to make sure archiving is actually working and is up to date. So that part will be very important when you're using archive timeout for that purpose. Monitoring is always key.
Okay, so next question about the streaming protocol. Are there any plans to add support of streaming protocol for PG Backrest?
Yes. One of the reasons why we haven't done this yet is that the streaming wall is actually quite slow, unfortunately, because it's uncompressed, you're transferring it to another machine, etc. So what we've been planning to do is some kind of hybrid scheme where we're using the streaming protocol to stay as up to date as possible, but we're also in the background using our normal method with archive command to archive wall quickly. So that way, if you get a big inrush of wall, we can not get too far behind because we'll be using our normal method there, and then we use the streaming protocol when things are a little quieter, just to keep the wall as up to date as possible. There are some challenges here dealing with object stores because a lot of our users use Azure S3. We're just introducing GCS in a couple of weeks. And so having partial rights to object stores is not necessarily all that easy. So we need to figure out how we're going to handle that, and maybe it'll be certain thresholds. Maybe we'll, we haven't quite worked out how we're going to do that, but it is in the plans.
Yes, it's an interesting problem, really, how to stream to object storage. Maybe you need to have some intermediate storage for
that's probably what we're going to do.
For accumulating the walls.
Yeah, then you have to worry about what happens if something happens to that intermediate storage.
Yeah, of course.
And how much wall are you going to lose based on your desired RPO. So maybe Backrest has to be aware of your RPO in order to make that determination of what to keep in intermediate storage and what to move off to the object store.
Okay, next question is what about restoring only one broken database in a Postgres cluster? For example, a cluster may contain many databases, you see, but for example, you have deleted one data directory inside the cluster, and you want to recover one database.
So we do have a feature for this, which is talked about in the user guide. We call it selective restore. And so you're able to restore a single database out of a cluster with some caveats. So the wall replay for the other databases still has to occur currently because we're not filtering the wall. So what happens is we restore the databases that you want. We restore all the other databases as sparse zero files, so they don't take up a lot of space. And then we perform wall replay. We also make sure that those other databases can't be logged onto. So if you try to log onto it, you'll get an error. And the only valid operation for those other databases is dropping them. But that's essentially how we handle restoring a single database out of a cluster.
Okay, thank you. Next one. So how can we restore the backup to another instance? So probably other, not this instance when it was taken, probably.
Well, the essentially the way you want to do that is set up that other host with the same configuration you have on the primary, pointing at the repo, all that kind of stuff, and then you do a restore. And before you actually start Postgres, you'll want to turn off archive mode, or there's an option in PG Backrest to do that. Because if you're not bringing this up as a new primary, you don't want it pushing wall into the repository. But there are instructions for this in the replication section in the user guide. So that shows you how to restore to a new host and set it up as a replica. Now, in those instructions, we're assuming that that's a replica that might get promoted to a primary at some time, so the configuration is identical to the primary. But as I said, in the case that you don't want to create a new primary, you'll want to turn off archive mode using either the PG Backrest option or editing for or whatever. That's pretty important because you can end up polluting the repository with a new timeline if you don't do that.
Okay, so is it possible to start simultaneously backup process for several clusters on the same host? Will it be okay for PG Backrest?
Yes, so you can start up as many backups as you want on the backup host, but you can only, each cluster can only have one backup running against it at a time. So we do have a limitation there just to make sure. A lot of this has to do with older versions of Postgres where if a backup wasn't stopped, it kind of got stuck in a state and you'd have to go stop it in order to continue. But in general, we feel that you shouldn't really be doing more than one backup against one cluster at one time. But if you're backing up different clusters, no problem. You can run as many simultaneously as you like.
So is PG Backrest protected from simultaneous running on a single cluster by two instances of PG Backrest?
Yes, we do that two ways. We take a lock on the actual database host. So we have a lock file on the database host, and on top of that, we have an advisory lock in the Postgres cluster itself, just in case there's some naming conflict or something like that. So we have two ways that we check to make sure that you're not running simultaneous backups against the same cluster.
Okay, thank you. Next question. Do you have experience of backing up very large databases, dozens of terabytes,
Yeah,
Are there any troubles from the long time of backup?
There are always troubles. So the biggest databases that I currently know of that are being backed up are hundreds of terabytes. There's a PG Backrest out of the gate is set up with gzip, compressed level 6, etc., which is possibly the worst compression you can use. But everyone has it. Gzip is everywhere, and it's the original default, so it's still the default. So if you're doing really, really large clusters, you're going to have to make sure you have a lot of bandwidth. 1 gigabit network is not going to do it. You need 10, 40, 100. You'll also need a lot of cores to do the compression, and you're going to need to be selective about your compression algorithms. So you can use LZ4, which is extremely fast but doesn't really compress as well. You can use Z-standard, which can be tuned to be extremely fast. You're not going to want to use gzip or bzip for those extremely large databases. And then the other thing is scheduling obviously is important. You don't want to run the backup too hard. But in general, PG Backrest will keep up with whatever the hardware can do. So if you have the I/O and the CPU and the network bandwidth to do those backups, then you'll be able to do those backups. There are some instances where people are using PG Backrest to do backup and then restore to the replica in a cycle because streaming replication can't keep up. So they got these very large databases, they do incremental backups of it, and then they restore those, and then they keep that cycle going to keep their RPO down to an acceptable level. In this case, RPO is generally measured in hours.
I see. Mm-hmm. Okay, go next. 2 questions in one, or 1 and 2. Are there any mechanism to take parallel backups and to restore in multiple streams?
Yes, so backup can be run in parallel. There's a setting called process max, and you just set process max to whatever you want. The upper limit on that right now is set to 999. It used to be 99, but there was someone who wanted to do 196. Had 196 cores, and they wanted to do a backup that big, so we had to bump up the limit. And restore is the same way. So restore, you can set process max, and generally speaking, for restore, you set it higher because the system's quiet during a restore normally. Normally, the database is not running if you only have one cluster on the system, so you can restore as many as you want in parallel. And we also do a delta restore where we checksum the local files and see what's changed. And we only pull from the repo what you need. So even for a very large database, if the rate of change is relatively small, your delta restores can be parallel delta restores can be extremely fast.
Okay, I see. So we're probably coming to the last question.
Okay.
And the last question is, if 2 clusters are backed up at the same time, will they be backed up in parallel or in queue? Probably parallel, yeah?
It really depends on how you schedule it. They'll be in parallel if you schedule them in parallel. A lot of people will queue them up by just putting the cron jobs sequentially or starting them at different times sometimes. But generally speaking, yeah, you can run in parallel or sequentially, whichever one you prefer.
Okay, thank you. So this is really a very good and very interesting talk. You see a great number of questions, and maybe now if you go to special chat to continue talking with the people who are interested in backing up in parallel or in sequence, you will get some more questions.
All right, thank you very much.
Thank you.
For having me here.
Yeah, so once more, thank you, David. Now you hear applause from all the people. And now we switch to a little break, and then there will be another talk by Bruce Momjan. Okay, so we are here now with Bruce Momjan, who will deliver his talk about artificial intelligence, and he is online. This is not a recorded talk. So you are seeing Bruce just in almost real time. So Bruce, prepare. Bruce, in real time.
Thank you.
Artificial intelligence, welcome.
Thank you, thank you. I'm certainly disappointed that we weren't able to do this in person. This conference is always a highlight of my conference here, but I'm glad we're doing it anyway. And I understand that the attendance is very good. So people from particularly regions outside Moscow are able to easily attend this conference, as well as people in Europe who I'm sure have also connected with this conference. I'm also impressed that we're able to translate these conferences into both English and Russian, which certainly is very helpful. My name is Bruce Momjan. I am one of the Postgres core team members, and I'm also an Enterprise DB employee. This talk is about Postgres and the artificial intelligence landscape. If you would like to look at the slides, they are at this URL right here. There are over 25 presentations on that website and many video recordings of those presentations. So if you're curious about this topic or others, I encourage you to take a look at that website. So what are we going to be talking about today? We're going to be talking about artificial intelligence in a large scale, a large sense. I'm going to talk a little bit about the history of artificial intelligence, which I think you'll find interesting. Then we're going to get into detail. We're going to talk about machine learning and deep learning, the difference between the two, and exactly what is machine learning and deep learning. I'll have a demonstration, of course, using Postgres. It's not a fancy demonstration, but it is, I think, a very clear demonstration of how you would do artificial intelligence, and particularly machine learning, inside of a database. We'll then, in section 4, talk about some of the hardware and software aspects of artificial intelligence. We'll talk about some of the tasks, and finally we'll talk about why use a database for artificial intelligence. Of course, artificial intelligence is in its infancy in terms of adoption, but I think as time goes on, you will see more and more artificial intelligence used inside of databases. So what is artificial intelligence? This quote is from Wikipedia. In fact, the Wikipedia link here is down here at the bottom. In this presentation, you will notice that many of the slides have blue links at the bottom. So if you download the PDF, you can click on the blue link and it will take you to the website to get more information about that particular slide. So artificial intelligence, according to the quote, are machines that mimic cognitive functions that humans associate with human minds, such as learning and problem solving. Now, the key word here is mimic. Is artificial intelligence truly the same as human intelligence? And that's a very difficult question, but there are practical reasons to answer the question, and I'm not going to provide an answer here. But the concept of whether human intelligence is the same as artificial intelligence really controls how completely artificial intelligence will be effective. What are the limits of artificial intelligence if, in fact, it's different? So this is sort of the philosophical slide, and I know the Russian population will find that interesting. What I'm trying to state here is that if artificial intelligence and physical intelligence are effectively the same, meaning that if they differ because of the way they've been created, but they're the same in terms of the way of their fundamental nature, then effectively things like free will become an illusion, because the words I'm using right now, the slide I've created, the thing you're doing right now, is really predetermined by whatever inputs you received over your life, whatever neurons are in your brain, whatever, physical things that are happening inside of you, so that the free will you think you have is really not free will, it just appears to be free will. So again, there is an interesting article here at the bottom that goes into this in a much bigger detail, but it's a philosophical, interesting problem. I don't get a chance to really talk about philosophical things a lot in computers, but I think this is something, if you're interested, is something interested in considering whether human processes are really just mechanical processes, and if they are, what does that mean for free will? What does that mean for artificial intelligence? Very, very interesting question. But back to the practical, artificial intelligence has gone through various stages over time. In the pre-computer area or time span, you had sort of some very rudimentary mechanical processes that sort of looked like human intelligence, playing checkers maybe, or moving an object. Early on, you had robotics. So early on in maybe the 19th century, if you could make an object move like a human, it was considered to be intelligent, right? So it was the physical movement that was sort of thought of being artificial intelligence. Then we had the Turing test, in the 40s, 50s, where there was a sort of test that whether you asked a computer questions, if you could tell if it was real or not. Then in the 80s, we had expert systems. Expert systems would try and take the knowledge of experts in a particular field and codify them into sort of a decision tree, if you're familiar with that, for doing artificial intelligence. And then we had what's called AI winner, which was pretty much from the 90s into the mid-2000s, where there really was, unhappiness with expert systems. Robotics really wasn't art. It wasn't intelligence. It was movement, but it wasn't intelligence. And the joke that I've always heard is that artificial intelligence, like fusion energy, is always 10 years away. So I've been around for a long time, but in fact, I remember when they were working on fusion energy in the 70s, and they said, when is it going to be going to have fusion energy? Well, okay, 10 years from now. Okay, so it's quite a years from the 1970s. We still don't have it. Whether we'll ever get true artificial intelligence is obviously an interesting question. But let's get into specifics here. The URL there at the bottom is a video of an MIT professor, a 3-hour video talking about artificial intelligence. So if you're interested in sort of spending 3 hours going deep into artificial intelligence, that video link there is one I would recommend. Effectively, artificial intelligence is the umbrella that covers a whole lot of different things like robotics and expert systems and so forth. But the artificial intelligence field that we're going to be discussing here, and the one that's gaining the most amount of traction these days, is something called machine learning. So machine learning is a specific approach to artificial intelligence. I'm going to show you diagrams of what it is. I'm going to explain how it works. I'm even going to show you Postgres implementations of that. There's also something called deep learning, which you might have heard about, which is a subset of machine learning. So there's artificial intelligence, machine learning, and then inside that is deep learning. And deep learning is basically an extension of machine learning, which I'll graphically show you going forward. Okay. So this is the basic slide for machine learning. And I'm going to walk through the terms. I'm going to walk through the stages. And we're going to build on this slide going forward, and we're going to build on this slide as we go through the demo. So, excuse me. This slide actually has 3 sections. The top section is called the initial state. So this is the initial state that the machine learning starts with. The middle section is called the training section. So this is where certain weights are set inside of the machine learning mechanism. And the bottom is actually the operational stage of machine learning, where you're actually using machine learning to accomplish some kind of task. So let's go through these three in detail. So this is the first one right here, the initial state. So the initial state in this particular example has what are called 3 neurons. And in this case, the neurons are represented by these 3 black and white boxes, okay? Now, they're called neurons. They're not really neurons like are in our brain, but that's the term that artificial intelligence uses. Combining neurons together in a machine, you create something called a tensor. So this entire pink area is called a tensor. Now, a tensor is a mathematical term which really means something similar to vector, if you're familiar with the vector term in mathematics, but it's a little different. But they call it a tensor. So it's just a collection of these neurons or a collection of these weights, which, as you can see, start out empty. All right. Now, when you go to the second stage, you're actually training those neurons, and you can see in the diagram here, I've got the blue area, which represents the weight, and you can see it's going up and down, okay? So as the training data from the left is being fed into these neurons in this tensor, all these weights are going up and down, depending on the type of data that's coming in, depending on how predictive that particular weight is compared to other weights, okay? And then finally at the bottom, you have your operational stage. Here I'm taking my request, I'm passing it into the neurons, where the neuron weight has been set here. You see this one is about 60%, this one's about 40%, this one's 100%. So you can kind of see through the training process, I've set my weights, and now I can send my data into the tensor. The neurons will adjust their output based on the weights of each neuron, and then there will be a result coming out, which will be the result for that particular machine learning operation. Okay, so it's initial state, training data, and then operational. Now that's a very high level, but there are actually 3 types of machine learning, and I'm going to go through all 3 in the next 3 slides. So this is a type of machine learning called unsupervised machine learning. Now, if what I'm saying doesn't really make sense, when I get to the demonstration, it'll be much clearer. But I need to give you this background. So in the unsupervised machine learning, you basically take training data in the second stage and you feed it into the neurons, but you don't actually have any results with the training data. You don't see unsupervised machine learning used very much because it's much harder to figure out exactly how to set up the neurons when there's no results to target. The only example I've ever seen of unsupervised machine learning would be you have pictures of cats and dogs, and you just the data into this machine learning system, and you set the neurons up so you try and detect whether it's a cat or a dog, but you don't tell the computer which one's a cat and which one's a dog. You just send them in and you ask it to separate, just into 2 piles or into two possible outputs. Again, it's a little hard to actually make that practical, but there are some uses for it. But it's really the simplest case. Supervised machine learning is the one that you see used most often. It has an initial state just like the previous one. But in this case, we actually have training data that has results. Okay? So in this case, the training data actually has some results to it. So it's telling us that there's a cat, there's a dog, this is a valid transaction, this is a fraudulent transaction, this is a success, this is a failure. So every piece of data that goes in has some kind of output, a known output that goes with it. So as you can imagine, it's much easier to figure out sort of how this process works because you're effectively sending the data in with a known output. And then when you get to the third stage, the bottom stage, you're sending some data in and the system's saying, okay, for all of the fraudulent transactions that I saw come in, this particular neuron is very predictive of that type of output. And this other neuron maybe isn't so much. And the machine learning uses that to figure out whether it's a cat or a dog, or it's a fraudulent transaction or a valid one, or whether it's a success or a failure. So this one is a lot easier for me to understand. You're training with some type of result in mind. The third one is a little more complicated. It's the same as the second stage. It has training data with results. But the difference is that when you are in the operational stage and you're doing your neurons and you're getting your results, there's a feedback loop. It's called reinforcement machine learning. There's a feedback loop which takes the result, and if the result was successful and it was predictive, it was accurate, we may want to increase the neurons for some of these cases. And if the result was incorrect, we may want to decrease the neurons for some of these cases. So this is an interesting aspect of machine learning. There's a lot of research around this. For example, it's hard to determine how much feedback should I send in. If you send too much feedback, you start to eliminate the training you've done and the results become unpredictable. So there's a lot of research still going on about exactly how much feedback you should be providing and when you should be providing feedback. But again, that's not really important here. The important part is that there is this reinforcement type of supervised learning where you're feeding back data back in. I promised I would cover deep learning. And deep learning is really just machine learning in multiple stages. So when I talked about machine learning, we had one stage here. This was the entire machine learning process right here. What you have with deep learning is that you feed the output of the first stage into another machine, which is the second stage, into another machine, which is the third stage, and so forth. And as you can see from the arrows, each neuron, the output of each neuron, feeds into all of the neurons in the next stage. Okay, so I have 3 neurons here, I have 3 neurons here, I'm effectively doing 9 data transfers into the next neuron, and the same thing here, 9, and so forth. Now, of course, these are small, but I may have hundreds or thousands or millions of these neurons, and I may have hundreds or thousands of these stages. So when you start to think of deep learning, you can see why it would become very computationally expensive. Now you may wonder, why would I do deep learning? Why would I want to do this? Well, it could be that you're trying to analyze an image, and the first stage separates the foreground from the background, and the second stage looks for color, and this third stage looks for the shape of the ears, and so you can see it would, or if it's voice, you would have one stage would look at pitch and volume, another stage would look at spacing, the third stage would look at try and determine words, and then the word meaning would be the next stage. You can see why you would have to do multiple stages often to do something complex. Okay, I promised to give you a demo, and here it is. This demo is very simple. No one would actually use this demo in real life, okay? But the reason I chose this demo is because it's so clear. It's something I can visually show you. You can see the numbers, and the numbers actually make sense, okay? So again, this is a demo, not something you would do in real life. So what did I choose as my artificial intelligence target? What I chose was the question, does an integer have non-leading zeros? So as you can see in the first bullet, that number, 31903, does have a non-leading zero. The second number does not have a non-leading zero. Okay, so this is the zero right here, and there's no zero in this number. Now this is a trivial question, which you would think nobody would ever care about. But there are use cases where this type of example, I think, is very illustrative, and that's why I chose it. So how are we going to create a machine learning to solve this problem and in Postgres? So the first thing I did was to choose a server-side language because we're going to be running this query inside of Postgres. The machine learning is not going to be done at the client side. It's going to be done at the server side. So I chose PL Perl. PL Perl is a very powerful server-side language, very good for arrays and very small in terms of how it the code is very small, so it's very easy to show on a screen. If you're curious about this demonstration, this URL right here is the SQL that goes with this presentation. So if you'd like to run this presentation live in PSQL, you can download that SQL and just run it, and on your screen, the whole presentation, the whole demonstration will show up, and you can play with it. You can see how it works. Okay, so the first thing in creating our machine learning example is to create our tensor. So as you remember, the original tensor had 3 neurons in it. In this particular case, we have 11 neurons. And the 11 neurons represent, the first 10 neurons represent how many digits are in that integer. So the thought here is that the more digits in a number, the more likely that number has a 0 in it, right? So a 2-digit number is less likely to have a 0 in it than a 7-digit number, all right? Now, that's not a great example, but it's good enough. The final neuron is going to decide, is this number divisible by 0? Because if the integer is divisible by 0, certainly the first digit is 0, okay? So this is a PL Perl function, which returns a Boolean array, okay? And if you're familiar with Perl, it's going to effectively return true or false. An array, if you put an integer in, it'll return 1 or 0 or true or false, depending on how the neurons test that integer. Then we're going to, now that's the first stage. We created our initial stage. Now we're going to do our training stage, okay? So we're going to create a training set of data made up of 10,000 integers. So here's 10,000 integers, okay? I'm going to randomly generate those, okay? And they're not random numbers particularly, they're random number of digits. So I'm not sure how familiar you are with randomness, but usually if you ask for 10,000 random numbers, most of the numbers are going to have the same number of digits. They're all going to be big. So I made it so that it has a lot of small and long digits at the same time. And I'm going to insert it into a table called training set. So there I have my training set. We're going to load that into the system there. Okay, and this is what my training data looks like. You can start to see it kind of matches what we had in the example where we had the neurons and they had little weights and so on. So here's my training data. It just has true and false. Okay, and I'm kind of, this is my training set. Here's my neurons for those values for those, and I'm going to basically load in 10,000 values. So I also have to create a function that generates the weights. Remember the little scales that go up and down in blue. Okay, so this is the generate weight function. It's actually 3 pages. This is the body of it, the start of it. This is the major part of it. It basically loops over the rows, and it generates weights depending on how, for each neuron, I'm going to run through my tensor, right? And I'm going to generate weights on whether that was a valid value or not. And I'm going to compute some percentages. I'm going to balance the weights, and I'm going to finish it. So effectively, this is my training part where I'm sort of adjusting my weights. Okay, I have to create something called a tensor mask. This is because I have some data that's true and some data that's false, so I have to kind of separate those out. There is some technical parts for machine learning. There's something called a sum weight. There's something called a softmax. These are really designed to make all of the percentages add up to 1, because in your tensor you have a bunch of weights. They're all going to be different, and you want to balance them out so they're all like 100% when you add them together. So you're kind of taking the weights and you're saying, okay, what's the sum of all my weights? And then what percentage is that of the whole? And you're generating percentages there. Pretty straightforward mathematics, but it's the type of thing you do a lot in machine learning. Now I'm going to store the weights. So here I'm actually creating a weight table using my training data. Here's my training set right here. Okay, so I'm querying my training set, and I'm creating the weights at my training stage. Okay, that's going to basically set up the proper weights for true, the proper weights for false. Okay, these are my weights. They do add up to 1, and you can kind of see how they kind of lay out here. This is the one where he has like 11 digits, it's 10 digits. I think it's 10 digits, 9 digits, 8 digits, 7 digits, 6 digits, all the way down. And this is my last one where it's divisible by 0. And this one is very predictive, as you can see here. This 0.6 is pretty predictive. Okay. So let's run it. Let's actually go and do an operational test. So I'm passing probability. When I do 101, the probability of a 0 drops to 11%. And that's because one of the tensors, which is the divisible by 10 tensor, is very predictive. And because this particular number, that last tensor, is false, it's much more likely, 88% instead of 77%, as you can see right here, it's much less likely to be considered divisible by, have a 0 in it. Okay. So not a great example, but you can kind of see slightly that it is being predictive of these kind of cases. Here's a bigger number, 48, whatever, big number. There is no 0 in that, but in fact, the tensor believes, 68% believes that there's a 0 in there. Why is that? That is because there are so many digits. So there's a higher probability of a 0 being in there, so it assumes there is one, even though there isn't. So again, very simple example, but you can see how it tries to predict the result. But let's look at another example. What we're going to do is we're going to test input 1,000 values, and we're going to see how predictive it is for 1,000 values. So here we have 1,000 values. We're inserting them into the table. I'm then going to run the tensor mask, tensor weight, softmax, sum weight on that. Okay, and then I'm going to do some statistical analysis to see how predictive it was. Okay, and these are the results I get. Effectively, the number down here is telling me that it was 15% better than random. So not really great, but it was somewhat predictive. Because if it randomly guessed, it's 15% better than that. And the 0.72 is it's sort of, if it was 50%, it's a little better than that. So this is not a great example of predictability, but it gives you an idea of how you would look at a particular AI example using just numbers, right? Very simple. We could have done this in in using arithmetic very easily, but using AI for it, I think, is much more easy to see. It wasn't very predictive, but it was better than average. It actually had some knowledge in it, and I think that was useful. Okay, so let's get more specific here. Now that we've talked about these demo, what are people actually using for artificial intelligence? Well, most people are not using PL/Perl. They might be using PL/Python, but a lot of people are using standard libraries to do this. Now, many of these standard libraries are client-side. So MATLAB, MATLAB are client-side. TensorFlow is one of the more popular AI client-side libraries. There's something called Weka, and also something called Scikit. Now, the interesting thing about Scikit is that you can do that server-side using PL/Python. So if you're interested there, there's a Cybertech blog entry that sort of shows you an example of using Scikit on the server side. Also, there is a client-side URL there from Object Rocket, if that's interesting. Both using Postgres. Again, one server-side, one client-side. Another aspect that I alluded to earlier is GPUs. As you can imagine, for particularly for deep learning, you can have millions of neurons and thousands of stages. That's very computationally expensive. So effectively, what a lot of people are doing who are doing machine learning are using GPUs, because you can program a GPU to do these operations in parallel, right? So GPUs are really designed to do parallel operations on pixels. Here we're just using parallel operations on neurons. It's kind of the same thing, really good at repetitive calculations and simultaneous repetitive calculations. So I know that some people are using this, even with Postgres, particularly to do deep learning and machine learning within a database. So we've talked about the history of AI. We've talked about what terms or what types of machine learning there is. I've shown you an example. I talked about the software support. Let's talk about a little bit about the tasks. What things can you do with AI, right? When I was a kid, the classic one was chess. We used to have little chess computers, software that would do chess, or programs on the PC, or even little devices that would do chess, which is kind of interesting. Those actually are not technically, at least the ones that we had as a kid, were much more brute force. They weren't necessarily machine learning in the same way that we're going here, but it is a type of artificial intelligence. I mentioned Jeopardy here because a couple years ago, there was IBM's Deep Blue, which won a Jeopardy game by using artificial intelligence. The that's an interesting case because they got a lot of press for doing that, and they created a whole division around this Deep Blue approach, but there has not been a lot of success of Deep Blue in business applications since then. So I see that as a kind of a cautionary tale for artificial intelligence, because there was so much fanfare when IBM was able to do that, but not a whole lot since then. In fact, past 2 weeks I noticed that IBM is considering selling off its Deep Blue medical division, I guess, to be a separate company. So that was interesting. Voice recognition is something we've gotten used to with our phones, with something like an Alexa or Google Home device, where we can talk to it and it will understand our commands. That is definitely machine learning, because as I said before, it's taking your voice, kind of breaking it up into pieces, going through stages and so forth. Search recommendations are very machine learning driven, where it knows the types of words you put in, what types of searches you've done in the past, and sort of comes up with an algorithm that does that. Recommendation engines, things like Netflix recommendations or recommendations for articles, definitely use machine learning. Image detection is a very popular machine learning one. Things like recognizing people's faces in an image, or even recognize individuals, is machine learning. And of course, weather forecasting, which is really a classic case, because you have a particular plot of land, you have a certain weather conditions, and you can say, historically, when I've had a plot of land and I've had this type of weather condition, this is the result that I've gotten. It's rained, or it's snowed, or we've had a tornado. And you can take a lot of weather data, pass it into a machine learning system, and get really useful results. Let's look at an example I think is really useful for artificial intelligence and machine learning, and that is fraud detection. So this is the detection of whether a particular financial transaction is valid or fraudulent. And if you were given that job of determining, is this a valid or fraudulent transaction, you would probably come up with a number of of neurons, like a number of measurements that you would use to determine if it's a valid transaction. Charge amount, how big is the charge? Whether the charge was through a magnetic stripe or a chip and pin or an online charge. What is the distance from the vendor to the chargee's billing address? How far away is it? How far is it from the last charge of the person? What country is the vendor from? What was the previous charge for that vendor? Is there previous charges by that vendor? These are all kind of things you would use to determine how you would use it. And down here I have a video at the bottom, which is from US Bank, which talks about using artificial intelligence in a banking scenario. Now, you might think, well, how do I know which ones of these to use? Like I don't know. Like, even if I asked an expert, they might give me a couple of these, but how do I know how important they are? Well, the beauty of machine learning is you don't have to figure it out ahead of time. Okay? You can pick as many neurons as you want. Okay? You choose the neurons. You create a machine learning neuron. You create a machine learning neuron for each attribute. Okay? You create training data. So the training data is going to be valid transactions and fraudulent transactions. And you would probably use supervised learning, because you know, or ahead of time as you feed the data in, here's a bunch of valid transactions, here's a bunch of fraudulent transactions. Then you'd feed the training data in, it would set the weights for each neuron, then you would start feeding real data into the machine, and you would get results. Okay? If you want to do reinforcement learning, when this machine learning incorrectly guessed something, you would go back and you'd feed some of the data in and maybe adjust the neurons, because as the machine will only be as valid as the training data you fed in. And as you may know, fraudulent transactions change their characteristics over time. So by having a feedback loop, you can adjust the fraudulent detection to be more accurate over time, and it would sort of learn itself and become more accurate as it got more data, as it got more feedback. As the patterns changed, it would adjust as well. Okay, so I think that's really interesting, and it's really kind of a useful example of how you would use machine learning in a case. But a lot of people are using machine learning outside the database. They have separate machine learning software, separate machine learning computers. But I think over time, that is going to move into the database. Just as data warehouse used to be separate, that's moving into the database. Just as JSON processing is moving to the database, just as full text search is moving into the database. You see, as machine learning and as AI becomes mature, I think there's some definite advantages that are going to move that into the database. Particularly machine learning requires a lot of data. So obviously having the data, the machine learning close to your data is helpful. Most of your data is in your database, so why not do the machine learning where your data is instead of doing it separately, having to download the data to do processing. So the advantages of doing machine learning in a database, you can use previous activity as training data, because that's where all your data is. You have seamless access to current data, not batch data. You can take immediate action. For example, before you commit a transaction, you could check to see what the probability, whether that transaction is fraudulent, before actually committing. And that's very easy to do when your AI is inside your database. Your concurrency and your backup would happen inside your database. You can use things like GIS, full text search, and other complex data types and indexing to do your neurons, to do your machine learning. That type of capability, like GIS, would tell you how far the charge is from the vendor, or the charge is from the owner of the chargee. That's a GIS process. Doing that in the database makes sense. And of course, Postgres can do GPU operations inside. So I've already covered user applications of artificial intelligence, but there are other uses of artificial intelligence for databases, things like performance adjustments. I know there's some people, I believe, in Russia who are working on feeding the executor data back into the optimizer, which would help the optimizer make future decisions, using AI to determine database settings or resource usage, and also for administrators, alerting to malicious activity or alerting to resource exhaustion can be done sometimes better by AI approaches to the problem. So that is all I wanted to talk about today. I'll leave you with this real image from Phoenix, Arizona, which I think illustrates artificial intelligence in two interesting ways, and I'll let you figure out what that is. But it's been a pleasure talking to you, and I hope this has been helpful. I'm planning to attend a number of talks tomorrow in the conference and look forward to being part of the conference with you.
Okay, thank you, Bruce. Thank you, Bruce. It was very interesting.
My pleasure.
I really tried your SQL scripts.
Yeah, you did.
SQL. Yes, I tried. It works. Really.
I think you might be the first one who tried it while the talk was going on, so that's cool.
Yeah, so it works, and it's so I of course need more time to understand what is written inside these functions, but it is interesting. And by the way, we're really also working with AI query optimization, and we have a partner company which works in machine learning for detecting fraud transactions.
Oh, wow. Okay, great.
Okay, so they analyze SQL traffic and try to find some injections and so on.
That makes a lot of sense, yeah.
So we have some questions for you in chat. So one guy, his name is Vasily, he invites you later to a special chat to discuss the philosophical aspects of what is the difference between computer intelligence and natural one.
Oh, so, boy, okay.
Yeah. So I remember a talk of this guy. It was also, he started with philosophy. So probably it might be interesting.
Yeah, the real interesting part is if you believe that the only thing that exists is the physical world, then effectively that is you have to assume that machine learning and our intelligence is the same because it's all physical process to some extent.
And
right?
Anything is allowed. Yeah.
Right.
Okay. So next question is, so Postgres backend is rather expensive, and that's why one guy interested if such approach is scalable, and can you make really high performance computations in machine learning inside Postgres? Is it good?
Right. So when you're doing this AI process inside of the database, the tensors and the weights and the deep learning or machine learning, that's all being done. When you're doing that in Postgres, you're not creating new SQL, you're not running Optimizer or anything. You're doing that at the same level that the client would be operating. So you're not, I know I'm showing you an example that's using SQL, but in most cases you would probably not do that. I only used SQL so you could see it, but in most cases you would not actually have your tensors and your neurons stored in the relational space. You would have them stored in flat files. I was using SQL just because it was very easy for me to show you visually the stages, because every other AI talk I've seen, you can't see it. You can't see the tensor. You can't see the neuron. You can't see the weights. You can't see the training data. So I decided to do it all in SQL so everything would be visible. But if you're doing AI and machine learning inside of Postgres, odds are your query is going to call a library or your own code, which is going to then interact with a GPU and so forth. You're not going to be doing this at SQL level. So maybe the training part may be done out of Postgres, and the result of it might be formulated as SQL, and it will run inside Postgres. Exactly. Your training data is going to have to come from somewhere, and that's typically from your database, right? So the actual data is going to come from the SQL, but it's going to feed into a much lower layer, which is going to create the weights and the tensors and hopefully use a GPU to do the processing.
Okay. So do you have an idea how soon AI will replace DBAs? So I know it's going to replace taxi drivers. What about DBAs? Yeah,
that's a great question, and obviously as somebody who did a lot of DBA work in the 90s, what we're seeing, and we're seeing this even before AI became popular, but I mean, you even see it probably in your normal work, even non-computer work. What you're finding is that humans are being required to do much more complicated tasks, and the simpler tasks are now being done by either by machines or by AI or whatever. You know, when you think of how a car is produced, right, or even, you know, how crops are props are collected from the fields. Originally it was just thousands of people would be out there picking corn or picking wheat. Now we have machines to do that, and the person controls the machine. And I think in the same way at the DBA level, we've already seen that the cloud has made provisioning of databases much easier. So as DBAs, we don't have to provision the database as much. But what we do have to do is to use our intelligence for much harder problems. And we're now using so much more data than we used to, that now because of cloud and because of AI, it's not that we'll be replaced, it's that we'll have to do the harder stuff. And the easy stuff will be done by either AI or the cloud or something that automates a lot of what we're doing. We see that even with something like Ansible now, where we don't have to provision things as difficult. You still have to understand it, but now we're doing much harder things as DBAs.
Okay, Bruce, you got a question. So, you see, an American gets a question from Japan at a Russian conference. So it's interesting itself. Yuga Nagata asks you, so now we know that machine learning works on Postgres. So next, what feature enhancements do you think will be needed to use machine learning in Postgres more efficiently or make it more useful?
Yeah, I think that's a great question. And I think it goes back to what I said about 15 minutes ago. If you look historically at databases, right? And I think of databases in the 80s or 90s, right? That you thought of the database as a container for data, right? You just put the data in and you got it out. Very, very simple, right? And Postgres, I think, has led the way in saying, no, you don't have to use it just for flat data. You can do GIS processing in there. You can do full text processing in there. You can do JSON processing in there, right? You can have complex data types. So what happened is that people used to have separate data warehouse, separate full text search, separate GIS. That kind of need is moving into the database. And I think AI is probably too new. People don't know what exactly to do with it yet. But I think as it matures, we're going to have to start adding tooling to Postgres to do the exact type of operations that I've shown you here. So it might be a library. It might be, it might be Scikit, which is the example I gave that uses Python to do machine learning inside of Postgres. So, I mean, Yvonne, you and your team have been sort of at the forefront of bringing things like JSON and full text search into the database. And even doing something like nearest neighbor searches in the database. And I think that eventually we're going to have to bring in something, whether it's a library or a language, which is going to make machine learning much simpler inside of Postgres. I don't know what that is yet because I don't think the industry has settled on exactly what they want yet. And I think that's why you start the complex processing outside the database. As it matures, it typically moves inside the database.
So there is a remark by Marcus Nullmeyer that he found that there is a Postgres extension which adapts MATLib library, which is not MATLAB, but MATLib. Yeah. So there is already such an extension, probably.
Oh, really? That's great.
Maybe
if you could email me, I'll put it in the slides because I had trouble finding. The only server-side example I saw was the Scikit. But if there's a MATLib one, I'd love to add it. MATLib one, sorry.
Okay, yeah. I forwarded this message in Telegram. So
thank you.
Read it. And by the way, if we have PL Perl or PL Python, it makes automatically all the libraries available in Postgres. So
and that might be the way we go. Is not adding an AI specific thing, but adding a library to PL Python, which makes integration with AI much easier. That would be a great way to go.
Yes, a larger problem from my point of view is finding the subset of tasks which are most effectively solved by AI means just in database, inside database. So probably this should be tasks which are close to the data, some data-centric tasks.
Right, exactly.
Okay, and maybe later we will see some artificial intelligence which mimics a database, having no database inside it.
Well, one example that somebody gave me was AI that automatically adds indexes that are needed. That would be a good use of AI, because administrators kind of have to guess now.
Yes, maybe. So some kind of plan analysis, finding ineffective queries and so on. Yeah, probably.
It would be cool if it could add indexes and then remove them when they're not needed, like so it would dynamically add and remove indexes depending on, you know, what patterns it sees.
Yeah. Okay. So probably the questions are coming to the end, and our time is coming to the end too. But Bruce, there is a special chat.
Yes, I saw that.
Found it. Yes. So if anybody wants to discuss, to continue the discussion with Bruce, please move there, and don't forget to rate this talk. Yes, because champions will get awards at the end of the conference. So if you like Bruce's talk, please mark it with a star. Okay, and don't forget to submit your lightning talks, which will take place at the session at the last day of the conference. And don't forget to submit, if you like, some special topics for discussions, for custom meetups. All of this can be done at the conference platform. Okay, so we are running out of time, and so let us thank Bruce once more, and those who are interested, please move to special chat. Thank you, Bruce.
Thank you, everyone. Bye-bye.
Bye. Так, мне надо сказать еще несколько слов. Да, so here I am in English. So this is the last talk of this conference today. So I'm grateful to all the speakers and all the attendees who came here. It was really a very large conference, very large event, and first experience of such a great online Postgres event, at least in Russia. And of course, it was interesting, though maybe there were some glitches with the conference, but I think tomorrow we will fix all the problems and it will run even better. So tomorrow we will have a complete day of talks. There will also be 3 halls, and we will gather the topics for lightning talks. We will gather topics also for meetups. Don't forget about that. So the program for the schedule for the next day is already available on the PGConf.Russia website and on the online platform. So please look through the schedule, select the talks you want to see tomorrow. You can form your custom schedule for tomorrow by marking talks that seems interesting for you. So once more, thank you for this day, and see you tomorrow.